International E-Conference on Science and Technology for Society held during 9 to 11 September 2020. It is jointly organized by Kanglei Khongyang Thijinyon, KKT Imphal, and Manipur Technical University, MTU Imphal. KHUMANG is a conference series on the theme Science and Technology for Society organized by KKT Imphal under its Science Communication Program. Last year, KHUMANG 2019 was successfully organized in collaboration with Dhanamandjuri University, Imphal in the month of November 2019. This year, KHUMANG 2020 is being organized with MTU Imphal under the aegis of Technical Education and Quality Improvement Program Phase 3, Ministry of Human Resource Development, Government of India. A short information about the organizing institutes. KKT Imphal is the Advanced Research Institute set up in 2018 under the joint initiative of Longjam Trust Kumbang and the Maitram Foundation Imphal. The main objective of the center is to perform high-end research in the field of science and technology and to set up a state-of-the-art research facility. The center also envisages setting up outstanding schools of research to harness rich biodiversity of the state. The Manipur Technical University is the first technical university of the state established on 23rd April 2016 under the Manipur Technical University Act 2016. Ministry of Human Resource Development, Government of India has appointed the College of Engineering Pune as mentor of Manipur Technical University under Technical University Quality Improvement Program Phase 3 till year 2020. With these few introductions about the co-organizing institute with the kind permission of all, let's move over to the formal inaugural program. At the foremost, I would like to request Professor L. Tombi, Honorable Vice-Chanceller, Manipur Technical University, to deliver a few lines regarding the conference. Over to you, sir.
Learned delegates, friends, ladies and gentlemen, this is a great privilege for Manipur Technical University to organize such kind of international conference. This is for the first time that the university got this opportunity of organizing this kind of conference. As we know that the theme of this conference is to bridge the gap between general people, general population, and the development on the one side of this technical education, science and technical education. As I understand that globally, in this 21st century, the science and technical research has taken a very fast step towards the development and its contribution to the society. However, on the other side, the people who are based on this are actually, according to me, majority of them are illiterate to science and technology. So how to base this kind of gap? On the one hand, the development of this technology, science, and on the other hand, the knowledge gap. And therefore, sometimes it happens that throughout the world, it happens that it is misused. And in fact, we human beings are very prone to using this in a misuse form. But this kind of use in the wrong form should be corrected by these scientists. And we know that nowadays, even this, there are so many cyber crimes and other things, and which are in fact we use in a positive direction. The economy can grow better. This in the stage of globalization, as we should this, and we first to make awareness of this population of the global And so also, in particular, in a country like India, to make awareness of this science, importance of science and technology and its uses and its implication are very much important. So this is my humble opinion, and the scientists and who are engaged in the field of research and the development of the science and technology, we consider that this, first of all, when we develop a particular technique, and first, the basic foundation is that we have to make aware of people who are going to use this also. Otherwise, no, if we use it in a wrong way, no, it would be very dangerous. For example, to me, now it is in this our security point of view, we have produced so many nuclear bombs, This is only for killing the society. But when we have the coronavirus, and there is still we are trying to invent a medicine of this. How to invent this? So on the one hand, we have very much developed, but on the other hand, we are very much backward. So this kind of lopsided growth of this side by side, but it should be abridged by the technicians, by the technologists, and by the scientists, and each and every citizen of a country should be made aware of the use of a particular invention of a science tools and techniques. With these few words, I have nothing to say more. I thank you, all the participants and delegates. Thank you very much.
Thank you, sir, for your enlightening words. We hope under your leadership, MTU will shine throughout the country. Next, I would like to invite Dr. L. Jaideva, Director KKT Imphal, to deliver a short speech.
At the outset, a very good morning to all of you. On behalf of the organizing committee and as a director of the Kanglei Khongyang Thijinyon, KKT Imphal, I am very happy to extend my warm welcome to all invitees, speakers, and the participants from inside and outside the country with their keen interest. I would like to pay my due regards to the patron, Professor L. Tombi Singh, Vice-Chancellor of Manipur Technical University. Next, Madam Vidyarani Ayekpan, TEQIP Coordinator, and Dr. Swapana ISO, Department of Chemistry, Manipur Technical University as a co-convener. And lastly, Dr. Maitre Neeraj Luang, Chief Consultant of KKT Imphal, for their wholehearted support and guidance in organizing this conference. This conference is jointly organized by the Kanglei Khongyang Thijinyon, KKT Imphal, and the Manipur Technical University, MTU Imphal, under the aegis of the Manipur Technical University, TEQIP-III, Government of India, for the 3 days, that is 9, 10, and 11 September 2020. I am going to give a brief account of the KKT Imphal. This Advanced Research Center was inaugurated on the 5th of April 2018 as an initiative under the joint collaboration of the Long John Trust and Maitram Foundation Imphal. So the main objective of this center is to perform the high-end research in the field of science and technology and to set up a state-of-the-art research facility. With the support of all our fellow members who are working in and outside the country in different professional fields. In the days to come, the center is planning to set up an outstanding school of research to harness the rich biodiversity of the country, especially in our state. Just on a quick glimpse on activities of the center, we had the Research and Development Program and also successfully organized KHUMANG 2019 at the University in Imphal. Next, KHUMANG 2021 is in the pipeline with the Jawaharlal Nehru Institute of Medical Sciences, JNIMS Imphal. Looking forward to see you all again in KHUMANG 2021. So the main theme of this conference is mainly the science and technology, which includes the chemistry, natural products, food technology, physics, microbiology, mathematics, etc. And in engineering section, it includes the pilot plant instrumentations, electronics, civil electricals, and on theme of these smart materials, nanotechnology, sensor, human-computer interactions, cancer diagnostics, artificial intelligence, etc. And in the industry entrepreneurs, Industry 4, vocal for local, funding local markets, etc. And in general, COVID-19, face masks, biosensors, nanofabrics, climate change, oil refinery, etc. So this international e-conference will bring together a diverse community of researchers to formulate new ideas with improved strategies for technology development and the provisions of better society. This e-conference covers multidisciplinary professors, scientists, industrialists, engineers, etc., working in the field of science and technology to share their research motivation, knowledge, and expertise to address societal problems faced by the public. The scientific program includes plenary talks, invited talks, and oral presentations with the full interactive session. Yes, award and the citation will be given to the best 5 research work presentation amongst the young researchers below 45 years. So the complete manuscript of the winners of the Young Scientist Award will be published in the Kowloon International Edition after the peer review procedure of the journal. All the submitted papers will be published in the proceeding of KHUMANG 2020. With these few words, I would like to thank all of you for participating in this international e-conference and making it for a grand success. Thank you all.
Thank you, sir. Let me invite Dr. Swapana Ningombam, Convener, KHUMANG 2020, to deliver her speech.
A warm welcome to all of you. Respected Vice-Chancellor of Manipur Technical University, ladies and gentlemen, I'm fortunate to have all of you out here on this KHUMANG 2020, an international e-conference on science and technology for society, which is held from today till 11th of September 2020. It is indeed a big event for Manipur Technical University, and as our Vice Chancellor has already told that this is the first kind of international event happening in this university. I'm extremely delighted. And this program is set in such a way to attract your interest. And it would have been my pleasure to show you the scenic beauty and the rich culture of Manipur if it would have been performed in a ground level, but due to this pandemic, I'm unfortunate, so I'm really handicapped in this COVID-19 situation to show all this beauty and the rich culture. And I hope with the valued contribution of all the delegates, the organizing committee members, and the untiring help of the patron, Professor L. Tombi Singh, the Vice Chancellor of Manipur Technical University, and Technical Education Quality Improvement Program Phase 3 Coordinator, Madam Aikpam Vidyarani. And with this untiring support of this, I feel that this conference will be a successful one. And I wish a very grand success for this conference. Last but not the least, I also would like to thank the TEQIP-III Phase 3 under Manipur Technical University for the financial support. Thank you all.
Thank you, ma'am. Now may I invite Director KKT, Dr. Jaideva Singh, to release the proceedings of KHUMANG 2020.
So I released the KHUMANG 2020 proceedings today. That is the 9th September 2020.
Thank you, sir. Next, I would like to invite Professor N. Rajmuhon Singh, Department of Chemistry, Manipur University, to deliver the keynote lecture on the topic, how science and technology will revolutionize the 21st century.
anh này có trong riêng có giàu riêng còn cái square. Sangeeta, are you hearing me?
Yes, sir.
Okay. So, a very good morning to all of you. Honorable Vice-Chancellor Professor L. Tombi Singh, Manipur Technical University, officials of KHUMANG 2020, and their delegates. The topic which I would like to present here in this conference is visions, how science and technology will revolutionize the 21st century. It was the 20th century that split the atom, probed the site, spliced the genes, and cloned a ship. It invented plastics, radar, and a silicon chip. It built aeroplanes, rockets, satellites, television, computers, and atom bombs. And behind each of these great ideas, great discoveries, and great inventions is in most cases an extraordinary human mind. We all heard about Wright brothers' aeroplane, Albert Einstein's theory of relativity and E equal to mc square, Edwin Hubbles telescope, Alexander Fleming's penicillin, Marie Curie's radioactivity, Bayard's television, Alan Turing's electronic brains, Stephen Hawking's black body, James Watson and Francis Crick's double helical structure of DNA, Bill Gates' software computer, Steve Jobs' Apple computer, Raymond Tomlinson's email, Christian Barnard's human heart transplant, Wilmot's dolly, and many more. By the end of the 20th century, science has reached an era, at the end of an era, unlocking the secrets of atom, unraveling the molecules of life, and creating the electronic computer with the three fundamental discoveries triggered by the quantum revolution, the DNA revolution, the computer revolution, the basic laws of matter, life, and computer were discovered, characterized by new technologies fusing the physical science, digital and biological worlds. The fourth industrial revolution will impact all disciplines, economics, and industries. For the past 3 centuries, coming to this designer genes covers one of the important topic. Designer genes covers the most important designer genes covers the most important of Darwin. How is science, genetic science will soon allow us to speed up and transform our own revolution. There will be a profound change in this process with a perfect storming revolutions in the field of genetic modification, stem cells. The result is that it will soon be possible for parents to consciously choose the genes of their children, defining their intelligence, appearance, athletic capability, and health. The ramifications could be enormous, with each generation smarter and more technologically profitable and better able to design the genes of their offspring. It was said by Stephen Porter, postdoctoral research fellow at Harvard Medical School and professor in the Department of Pediatrics, Division of Developmental Biology, Children's Hospital Medical Center in Cincinnati. The wealth of nations. For the past 3 centuries, wealth was usually accumulated by those nations which were endowed with rich natural resources, of which large amounts of the great powers of the Europe in the 19th century and the United States in the 20th century follows this classic textbook principle. Lesser Sheet Hero, former Dean of MIT's Sloan School of Management, has stressed in the coming century, and this statement was made in the year 1990s. There will be a holistic and historic movement in wealth away from nations with natural resources and capital. Hero wrote, I quote, in the 21st century, brain power and imagination and innovation and the organization of new technologies are the key strategic ingredients. He further said, I quote, today, knowledge and skills now stand alone is the only source of competitive advantage. As a consequence, some nations have already drawn up lists of technologies which will serve as the engines of wealth and prosperity in the 21st century. In this regard, a typical list was compiled in 1990 by Japan's Ministry of International Trade and Industry, and it includes microelectronics, biotechnology, new material science industry, telecommunications, civilian aircraft manufacturing, metal tools and robots, computers, both hardware and software. Without exception, every one of the technologies singled out to lead the 21st century, and the point is that the three scientific revolutions, particularly quantum revolution, computer revolution, and biological revolutions, are not only the key to scientific breakthrough. These are the keys to the scientific breakthroughs of the 21st century. These three revolutions will also be the dynamics of engines of wealth and prosperity. Nations may rise and fall on their ability to master these three revolutions. In one of the important books, Visions How Science Will Revolutionize the 21st Century, written by Michio Kaku, and this book is very, very important, and it is very much related to this particular topic, and he highlighted many important changes to come in this 21st century. He examines the ways the great scientific revolutions that have dramatically reshaped the 20th century, quantum mechanics, biogenetics, and artificial intelligence, which will transform the way we live in the 21st century. Computer revolution, the invisible computer machines that can think beyond silicon, cyborgs and the ultimate computer may come up very soon. Time frame for the future. Beyond 2020, it is like that a end of silicon will end, and entirely new computer architectures will be created very soon. Smart office and home of furniture that contains smart rooms and smart screens will come up. Smart cars with sensor and smart clothes based on the nanomaterials will also come up very soon. From 2020 to 2050 in between, robotic science will be developed a lot, and brain science will also be developed a lot. With the following topics, main topics, which will work on these topics: optical computers, molecular computers, DNA computers, quantum computers, speech recognition, talking robots, personal DNA code stored in CD, we can call encyclopedia of life, and gene therapy to solve the problem of heart disease, arthritis, autoimmune diseases, schizophrenia, and like. Isolation of age genes, which control our aging process and allowing us to extend the human lifespan. New generation of lasers and holographic three-dimensional technologies will come up very soon, and fusion technology or fusion science will be developed a lot. Room temperature supercomputers will come up in a commercial level. Molecular size machines based on nanotechnology will also come up. Ionic rocket engines for interplanetary travel also will come up. Beyond 2050 and 2100 and beyond, robotic science will develop in such a way that robots having consciousness will come up. Unlike the quantum or biological revolution, the study of consciousness is still in infancy. Will humans become obsolete is a big question now. Robots of self-consciousness, this could greatly increase their utility in society. They are able to make independent decisions and act as secretaries, butler, assistants, and aides. Advanced DNA revolution, where biogeneticists are able to create new type of organisms with hundreds of genes, allowing us to increase our food supply and improve our medicine and our health. To design new life forms, quantum revolution will exert a powerful influence, especially in the area of energy production, beginning of rockets that can reach the nearly stars and planets to form the first colonies in space. Beyond 2100, convergence of all the three revolutions to duplicate the neuron patterns of the brain on a computer. Extending life by growing new organs and bodies, by manipulating our genetic makeup, and even by ultimately merging with our computerized creations. President Barack Obama, former President of the United States of America, in the year 2014 allocated $3 billion on the project Brain Research through Advanced Innovation and Neurotechnologies, in short BRAIN. And it uses reverse engineering brain technology. Diseases like Alzheimer's disease, Parkinson's disease, schizophrenia, dementia, bipolar disorder, etc. can be solved very soon. Another important project, European Commission on Human Brain Project, was also sanctioned under the leadership of Dr. Henry Markram from Switzerland, and it allocated 1.19 billion euro, which is equivalent to $1.6 billion, to create a computer simulation of the human brain using supercomputer. And it will create a copy of the human brain made of transistors and steel, building a brain computer scientists, neurologists, rapid advances in automation, robotics, and nanotechnologies and neuroscience. And if this project is successful, these scientists could alter the course of human history, not only new cures and therapies for mental illness, but also will unlock the secrets of consciousness. There is one impact of reverse engineering the brain, that is immortality. If consciousness can be transferred into a computer, does that mean, and then we don't have to die? So many that ethical problems may come up, but many developments will come very soon. And quantum revolutions, anyone who is not shocked by the quantum theory does not understand it. It was said by Niels Bohr. In 1950s, quantum physics that first ignited the DNA and the biomolecular revolutions. In 1990s, with the introduction of PET, MRI, and CAT scans, quantum physics helped to change the way medical research was conducted. 2020 to 2050 in between, molecular machines and atomic micro machines based on nanotechnology will come up. These machines, like viruses or bacteria, may be able to scavenge molecules from their environment to reproduce themselves, creating an ultimate number of molecular robots. They could be used in destroying infectious microbes, killing tumor cells one by one, patrolling our bloodstream and removing plaque from our arteries, cleaning up the environment by devouring hazardous waste, eliminating world hunger by growing cheap and plentiful foods, repairing damaged cells, and reversing the process of aging, building computers in the size of atoms, the first generation of micro machines called micro electromechanical systems, MEMS, MEMS, are expected to find wide commercial applications. MEMS, the prototypes of MEMS are already entering the marketplace, creating $2.2 billion industry, which is expected to exceed $15 billion very soon. MEMS could revolutionize a number of fields. For example, in the field of medicine, MEMS might be able to dramatically reduce the current cost of $20 lakh laboratory spectrophotometers down to $10 only. Create a complete laboratory, one on a chip capable of full medical diagnostics and chemical analysis. With latest advances in brain science and recent breakthroughs in technology, smart pill is yet to come as an outcome of the latest advancement of neuroscience. With this, it will be able to upload our mind to a computer. Will it be able to communicate telepathically with a friend? So this is the smart pill, and it is yet to come. Biomolecular revolutions. After the Human Genome Project, that is, this Human Genome Project, which costs around $3 billion, hundreds of scientists are involved in this project under the leadership of Francis Collins and Jack Venter. When Human Genome Project was completed in 2003, it heralded a new era in science. Eventually, everyone will have his or her personalized genome available on a CD-ROM. It will list all your approximately 25,000 genes. It will be your owner's manual. Biology is today an information science. It was said by David Baltimore, the Nobel laureate. Human Genome Project had cost $3 billion. Stanford engineer Stephen R. Quack has perfected the latest development in the gene sequencing of a person's genes to $50,000 and forces the price plunging to $1,000 in the next few years. Scientists have long speculated that when the price of human gene sequencing drops to $1,000, this could open the floodgates to mass gene sequencing. Within a few decades, the price of sequencing all our genes may cost less than $100, no more expensive than a standard blood test. So these two scientists are the Human Genome Project leader, Craig and Venter. Some of the world's most powerful computers are involved in bioinformatics, analyzing millions of genes found in plants and animals for certain key genes. Your bathroom will have more sensors than a modern hospital, silently detecting cancer cells years before a tumor is formed. If there is evidence of cancer, then nanoparticles will be injected directly into your bloodstream, which will, like smart bombs, deliver cancer-fighting drugs directly to the cancer cells. Again, tissue engineering is one of the hottest fields in medicine, making possible the human body shop. So far, scientists can grow skin, blood vessels, and heart valves, cartilage, noses, years in the lab from our own cells. So organ development is also another important area, and in this 21st century, maximum number of organs may be met very, very soon. So using these stem cells which have a potential to cure a host of diseases such as diabetics, the Alzheimer's, Parkinson's, and even cancer. Stephen Davis of University of Colorado, impressive success in treating spinal cord injuries in rats. It was performed and it was quite successful. And so transplant science in 2020, it is also another important area. And in this 21st century, so much developments will come up in this transplant science. Even Australia also, they have already started working on this field. Stem cells biology and regenerative medicine is also a very, very important area. American Society of Hematology is working on this area and helping hematologists conquer blood disease worldwide. So biomolecular revolution, in short, we can say that new era of science after completion in 2003 of the Human Genome Project, sequence of 3 billion nucleic acids, creation of a map of 1 lakh human genes hidden among 23 pairs of chromosomes in our cells, reading the code of life, DNA testing, gene hunting, gene therapy, conquering cancer, molecular medicine, aging research, and so on. So genetically engineered eggs and sperm or designed genes or clones, genetics of a new brave world, babies of mass produced in huge embryo factories and cloned to produce a caste system of alpha, beta, gamma, delta, and epsilon of human beings are yet to come. It was predicted by Dr. Huxley long back. So Francis Collins, the current director of National Institute of Health and the man who led the government's historic Human Genome Project, said, all of us have about a half dozen genes which are pretty screwed up. In the ancient past, we simply had to suffer from these often lethal genetic defects. In the future, we will cure many of them via gene therapy. So it was highlighted by Francis Collins. Gene therapy. Some of the promising areas ones include anti-angiogenesis, or choking off the blood supply of a tumor so that it will never grow. Nanoparticles, which are like smart bombs, direct at cancer cells. Gene therapy, especially for gene P53. New drugs that target just the cancer cells. New vaccinations against viruses that can cause cancer, like the human papilloma virus, HPV, which can cause cervical cancer. As Nobel laureate David Baltimore notes, cancer is an army of cells that fights our therapies in such a way that in this regard, I am sure it will keep on continuing in the battle. It was said by David Baltimore, the Nobel laureate. So scientists developed gene therapy that could restore partial vision. It is a case study, gene therapy for the blind. And it was quite successful in 2017, November 2. According to a recent research, as many as 8.8 million people in India were found to be blind in 2015. Another 47.7 million people had moderate and severe vision impairment worldwide. There are estimated 36 million people who are blind. In 2050, it might grow to almost 115 million people. The study was presented by a group of scientists at the annual meeting of the American Academy of Ophthalmology. And so gene therapy will have a lot in the ophthalmological science also, very sure. And one more breakthrough. Scientists from Armed Forces Institute of Regenerative Medicine could know that salamanders have remarkable powers of generation, regrow entire limbs after their loss. The new goal is to extend the process to see if an entire human limb can be regrown, just like the salamanders. The first major organ, the bladder, was grown in 2007, the first windpipe in 2009. Within 5 years, the first liver and pancreas might be grown, with enormous implications for public health. Nobel laureate Walter said, I can foresee just a few decades into the future when practically every organ of our body will be grown from our own cells. So another area is the cloning. If we can grow organs of human body, then can we regrow an entire human being, creating an exact genetic copy or a clone? The answer is yes in principle, but it has not yet been done. And there may be so many arguments on the basis of these ethical problems. The concept of cloning hit the world headline in 1997 when Ian Wilmot of the Rosalind Institute of the University of Edinburgh was able to clone Dolly the sheep. By taking a cell from an adult, extracting the DNA within its nucleus, and then inserting this nucleus into an egg cell, Wilmot was able to accomplish the feat of bringing baby a gene copy of the original. And clones are favorite theme in Hollywood movies even. In the movie The Sixth Day, Arnold's character battles the bad guys who have mastered the art of cloning human beings. In his unsettling yet prophetic book, it is a novel, Brave New World, written in 1932, Aldous Huxley made his fertile imagination for 600 years in the future. Babies are yet to mass produce in huge embryonic laboratories and are cloned in the laboratory with a caste system of alpha, beta, gamma, delta, and epsilon human beings. So it was predicted long back by Huxley. And this is a big question now, and whether this human cloning will be accepted by the people in the whole globe. And so many ethical problems also may come up, and it is yet to see what will come later on. And in the so another important area where this E. Wilson also said, the great Harvard biologist, Homo sapiens, the first truly free species, is about to decommission natural selection. The force that made us, soon we must look within ourselves and decide what we wish to come. The ramifications of human cloning are considerable, ranging from to the human to the fantastic. Prominent, if this human cloning is supposed to be accepted, then prominent athletes from different sports and even different decades can be cloned to create a lucrative dream team. Wealthy individuals and aging monarchs without children might bequeath their fortunes and the thrones to their clones. And parents might want to clone a child who died from a fatal disease or accident. Cells may be stolen from the famous of glamorous figures and then sold to the people who want the individuals for children. Graves of famous people may be raided to obtain DNA samples capable of being cloned. Dictators may create armies of cloned soldiers, slaves with great physical strength but limited man capacity, and human hybrids resembling the nightmare from the island of Dr. Muri. So these are the concepts of this cloning, element cloning. Then now it did from shifts to rats to pigs. So it is now quite successful, and regarding human cloning is still yet to see how it will come later on. So with this background, I would like to conclude my talk, and I wish this KHUMANG's conference will be a quite successful one, and in the years to come, such type of conferences and seminars will be organized by this KHUMANG, and I wish all the best. Thank you very much.
Thank you, Professor N. Rajmuhon Singh, for your immense lecture on the hot topics of the current era. Before closing the inaugural program, I would like to inform an important message to all our delegates and participants that our Honorable Chief Minister of Manipur, Sri N. Biren Singh, sent his best compliment to our KHUMANG 2020. We can find his message to our proceedings of KHUMANG 2020. On behalf of the organizing committee, I would like to thank our Honorable CM for his kind support. After the ending of inaugural program, let's move forward to the technical session number 1. For this, I would like to invite Dr. Raghumani, Bhabha Atomic Research Center, Mumbai, to kindly chair the session. Over to you, sir.
Good morning. Yeah. Hello. Yeah. Good morning. Yeah. So So now the first technical session will be start. Before that, I thank Organizing Committee, Dr. Lilas Luang, and Dr. Longjam Jaideva, and N. Swapana and their team members. I thank you all, the team members, to conduct this KHUMANG 2020. And many people ask what is KHUMANG. So I want to mention that KHUMANG means move forward. So this already I'm very happy that science and technology for society is one of the very good in this situation and very suitable topic of this conference. So I welcome all these speakers and the participants, attendees outside, inside in India. I welcome all. Because of you, we are going to conduct this conference. And thus first session is of this first technical session. The speakers, just I was mentioned some few of the speakers is this one's Professor Katsuhiko Arigal, that the names Japan. And Professor Gunnar.
Dr. Raghumani, kindly unmute your mic.
Okay. Yeah. So can I start now?
Yes. Let's proceed.
Of course. So that have you heard before something? I speak before? No.
Yeah, we heard almost first half.
Okay.
You can continue on.
Yeah. So then Professor Rajnish Kumar and Professor Y. Jaideva Singh. So first I pick up our first technical session talk, the invited talks. This Professor. Yeah.
Professor Ariga is here.
Yeah, sure. Professor Katsuhiko Arigal. I just briefly he's mentioned his brief biography. Professor Arigal is the principal investigator of World Premier International WPI Research Center for Materials Nano Architectural Techniques (MANA) at the Nims, Japan. He received his PhD degree from Tokyo Institute of Technology, TIT. His research field is based on the supermolecular chemistry and surface science, including the boundary research area of organic chemistry, physics, physical chemistry, biochemistry, and material chemistry. He also appointed as a professor of the University of Tokyo since 2017. His index is 106 for Web Science and August 2020. He has been selected as a highly cited research in both material science and chemistry in a few years. In fact, he was the editorial activities he has done. One of the editor-in-chief of the Bulletin of Chemical Science of Chemical Society of Japan, International Advisory Board of the Egawadi Chemi International Edition, Chemistry and Eastern Journal, and Chemistry Nanomaterials, Editor Board member of the Advanced Materials, and Chemistry Materials, Reviewer, SS Applied Material Interface, Applied Materials Today. He is the member of the board of the Economics Forum Expert Network, honorary member of the Materials Research Society of India. With these few words, I am inviting Professor Katsuhiko Arigal for his beginning talk. Please, start.
Okay, thank you very much. Can I share my slides?
Yes.
Yeah.
Yes.
Can you see my slides?
Yes. We started.
Yeah. Okay.
Yeah, please.
Thank you very much. I'm very happy to participate. This very exciting.
Yes.
It have a very exciting starting. Today I want to show my recent research, and my title is Beyond the Nobel Prize: Handling Molecular Machines by Our Hands. Yeah, as you know, the molecular machine got Nobel Prize in 2016. And for these three professors get Nobel Prize. And their work for Nobel Prize is listed here. For example, in the case of the Professor Studard, he invented molecular shuttle. In this case, this molecule is some kind of train rail. And this is shuttle. And upon the simulation, this shuttle molecule can switch from here to here, from this station to this station. And Dr. Sauvage invented catenam. In this case, it's quite depend on the oxidation state of the central kappa. This ring rotate. This case is, okay, green side is coordinated, but with this stimulus, it's rotate, and this blue part come here. It's some kind of molecular rotation. And also Professor Fehringer demonstrate molecular motors using several series of the stimulus. He can rotate this red part against this black part. These are very simple, but very innovative. They are first example. Although they are not useful enough, but initiation was one good idea, get Nobel Prize. And nowadays, we know new technology, nanotechnology, and we can use this molecular machine in nanotechnology. For example, molecular machine for Nobel Prize, we observe molecular machine motion in solution. Actually, we cannot see the machine in solution, but some spectral technique like NMR or IR, we can specify the motion of the molecules. But now we have technique to observe molecules directly. Now we can control machines and observe molecules directly with very advanced technique like STM, scanning tunneling microscope, to specify place of the molecules. One of the example from our group. So my colleague, Dr. Jonathan here is collaborate with, he collaborated with Dr. Uchihashi. He is a specialist of the STM. And they create this molecule. This porphyrin molecule make dimer, one molecule and one molecule here. And by using STM chip, and we apply electric field stimulus, and we can rotate this machine. This case is clockwise, in this case counterclockwise. We can control rotation direction through this chip directly. Now this is a contribution of the nanotechnology to molecular machine. And then the people in molecular machine, in advanced technology, okay, think about, we have some good event to show ability of the molecular machine. This event is called as a nano car race. Car race that use a single molecule as a car. It was held in France, 2017. The totally 6 teams attend from the world. They have their own nano car and have competition with STM technique. This is for completion of the car race. We can synthesize such a car-like molecule, and using STM chip, we can drive the car, and we compete, and to have such ability to control cars. And the rule of the nano car race is okay, simple. The total distance, this is a starting point here, and 3 corners, and the total distance is around 100 nanometers. Within 36 hours, scientists can drive car from here to here. And these are 6 teams attended. And from France, Switzerland, America, Australia, Germany, Japan, and America attend this nano car race. For example, Switzerland team use this car-like molecule. Also, American team use this car-like molecule. And German team and Switzerland team use some propeller-like rotating molecule. And then this is American Australia team, rocket. This is very strong. They use rocket type machines. And our case is some kind of insect, some worm-like flexible motion. This is a new, some kind of, we use conformation change for nanocar. And as you recognize, okay, we have sponsors. For example, French team have sponsor from Peugeot Citroën. And German team have the sponsor from Volkswagen. And our Japanese team have sponsor from Toyota. It means also car company pay much attention of this molecular level car race. And our strategy is we use some kind of the conformation change by excitation. Our car is here, and when we apply some stimulus with tunneling current, we can stimulate, and then this molecule change the shape. And then when shape return to original, it have some distance. Actually, we test car motion before race. For example, this is a image of our car. This is a molecular image. And when we apply electrical stimulus, this part, this car can go ahead. However, if we apply stimulus here, car hold it, no driving. It means now we know how to apply electrical stimulus to molecule to make such a car-like motion. We investigate before actual nanocar race. And nanocar race started. Okay, this is our initial result. We have here, car is here, and one stimulus. This car molecule have one step further. 1 nanometer progress. That's one small step for a molecule, but one giant leap for mankind. We get 1 nanometer drive, one electrical shot. And this is a result for race of our team. First day, 11 o'clock, race started. And first pulse, as I showed, 1 nanometer run. However, unfortunately, software crash. This software crash induced destruction of the racetrack and nanocars. And overnight, we established nanocar again. But software crash again. And Japanese team retired. But okay, honestly speaking, this is a computer problem. The computer was supplied by France. It's not fault of a Japanese team. And this is the final result. Okay, we have 1 nanometer ahead, and French team. This car is very heavy. Too heavy car cannot go ahead. But other cars have some distance, especially American team and Switzerland team have long distance, and they get gold prize. However, we have second nanocar race in 2021. We have chance for revenge. In this case, some additional team from China or other countries will attend. Maybe third nanocar race, some people from India can attend. This is some kind of the top level research of molecular machine and nanocar by using nanotechnology. But however, our original research beyond Nobel Prize and nanotechnology, our trial is very unique. We use our hand, by our hand motion, to control molecular machine. No one is working in this area in the world because no one can imagine how to operate molecular machine by our hand. This is the world unique, only one research. And first we think about necessity force to control molecules. And my colleague summarized all necessary forces for many motions of the molecule. For example, biological motion like myosin walking or RNA polymerase motion, they use rather weak force. However, the artificial system like photoisomerization for azobenzene, spiropyran, such an artificial process use very huge force. It's a difference. The molecular system use very faint forces, delicate forces. Our artificial system use very strong forces. This is a typical difference between biological system, biological machine, and our artificial molecular machines. And most of the research in organic chemistry, supramolecular chemistry, uses very strong power or strong forces to control molecular machine. However, the biology utilizes very faint, delicate forces. This region to control these forces is not explored. However, if we can successfully control these forces, we may control many things for cell migration, cell differentiation, protein conformation change by artificial stimulus. This weak force region is not explored yet. This is a frontier. No one is trying to do this. And next step is how to control molecule by our hand. Usually, molecules have such a shape. However, material have big shape because we assemble these molecules to such a material. When we get material, we cannot touch the molecular mechanism because it's very big. The problem is we assemble such a unit in three-dimensional way, all direction. That's why we cannot touch nano dimension. If we reduce dimension from 3D to 2D, for example, interfacial soft 2D material, this direction and this direction are macroscopic. However, motion of this direction can couple with molecular nano dimension. For example, we can get, one method to control such a thing is a very traditional Langmuir-Bourget method. We can spread molecules here on water surface, and we can apply macroscopic force and control molecular conformation. And we calculate the actual energy and forces. And the force is very weak. It is similar to this biological motion. It means the molecular control on surface is very close to biomolecular control in molecular machines. And I want to show one first example. Catch and release a molecule by our hand motions. And we synthesize this type of the molecular machine with the Professor Kikuchi. And this machine has this shape. It has central ring here and 4 rigid walls. And rigid walls are connected through flexible arm. And this wall has a hydrophobic phase and hydrophilic phase. And if we spread this molecule on water, it has open conformation because touching this side to water is energetically favorable. But we compress monolayer of this machine by a hand-like motion, macroscopic motion. When it's compressed, molecules have such a compact cavity form. If gas molecule is here, this machine can catch the molecule inside. And it's demonstrated with a fluorescence probe molecule, this molecule. This molecule is highly quenched in the water, but once caught in cavity, it shows fluorescence. It means if this machine can catch this gas, we can observe fluorescence from the surface. And we can detect this fluorescence reaching with optical fiber. And this is a result. This is the isotope between molecular area and surface pressure. And we compress monolayer from large surface area and small surface area, increase surface pressure, and compression, expansion, compression, expansion. We repeat. We spread this molecular machine on water surface. And water surface, we compress monolayer by hand-like motion, tens of the centimeter. And we evaluate molecular catching. This is the result. This is a time and fluorescence intensity. And this is compression, expansion, compression, expansion, compression, expansion, profiles. In this case, compression-induced fluorescence increase. It means compression-induced molecular catching, and expansion-induced fluorescence decrease. This is molecular releasing. Catching, releasing, catching, release, catching, release, catching. There is some decay, but stabilized. By using macroscopic motion of compression, the expansion of the film, we can actually control molecular machines. We can control molecular machine by our hand, by using interface. Okay, this is summary of my first trial. We use such a simple water surface, and we set molecular machine on the surface. And we can apply macroscopic pressures in lateral direction. At interface, we can couple such a macroscopic motion and molecular motion, and we can control molecular machine. We can manipulate molecular machine by our hand. This is a world only one research. Okay, only we can control, manipulate molecule by our hand motion. Next target is the tuning of receptors, because previous molecular motion has very dynamic motion. But we can control molecular receptors with faint force application. For example, this is a receptor given by Professor Tsukube and Professor Shinoda. Professor Tsukube is one of the best supramolecular researcher in Japan, but unfortunately, he passed away a few years ago, but he kindly gave me this molecular receptor. This molecular receptor has the chiral center, and it can have twisting motion. When we assemble this receptor on water surface and give pressure and change twisting angles, and it's change chirality on the surface, and we evaluate binding of the D and L amino acid. This is a result. Surface pressure, and this is the ratio of the binding constant between D amino acid and L amino acid. This is one is a 50-50 binding. But in the case of the valine, at lower pressure, D amino acid is preferentially binding. But higher pressure, L amino acid is preferentially binding. We can switch affinity of the chiral affinity of the amino acid by our hand motion. Usually, molecular chemists think about they investigate such a binding using crystals, making crystal and detail. They investigate detailed structure. But this case, they only think about one possibility, because crystal is researched only at most stable state. However, molecule can be change their conformation. We can softly change molecular motion and conformation and switch binding affinity. We can control molecular recognition. Another case, we use such a molecular receptor and check binding of uracil and thymine derivatives. They have only one difference of the one methyl group. And actually, RNA or DNA cannot distinguish them because they use both adenine for recognition of these nucleotide, nucleic acid bases. However, by using this tuning system, we can differentiate between origin and timing at around 75 times. We can tune best receptor structure for discrimination of very similar molecules. Okay, this is maybe most important slide in our talk. I summarize the history of the molecular recognition. The basic the molecular recognition, like this is ion recognition by Crown Racer. Okay, they use only one state. They consider most stable state for binding. This is one of the basic of the molecular recognition. This is a traditional host guest system. And actually, this concept received first Nobel Prize in 1987. And Professor Shinkai in Kyushu University have pioneering work. He switched conformation of receptor, for example, azobenzene photoisomerization between cis and trans, and switch binding. This is a switching between two states. Such a molecular switching is used, same mechanism is used for most of the molecular machine. In case of the molecular machine, they use 2 or 3 or 4 states and switching between them and making machine motion. And this concept get Nobel Prize in 2016. This is one state. This is a switching between few states. But our concept is totally different. Our concept is tuning, continuous tuning of the molecular conformation at the interface, and create numerous possibility, and then adjust one best candidate, one best possibility to get best functions. This is a tuning from numerous candidates. This is only one possibility. This is only few possibility. But this is the best solution from numerous candidates because we use tuning of soft molecules conformation. It get Nobel Prize in 1987. After 30 years, it get Nobel Prize. It means I may get Nobel Prize after 30 years. If audience may join to my group, you may have chance to get Nobel Prize together. Please collaborate with me. Okay, this is a new concept. Organic molecules have huge possibility of the conformance, but most of the chemistry using only most stable state, like a crystal, or they calculate only most stable state. But we may have huge possibility in remaining parts. If we can logically control molecular conformations of organic molecules, we can explore these regions. Most of the chemistry only play around stable state. But the molecular confidential control, we can explore this field. We can create new science. Okay, finally, I want to show my recent topic, control of living cell at the interface. Cell-fate control at the interface. And it is well known, the cell at surface are controlled by elastic, viscotic behavior of the surface material. For example, from very soft region to hard region. For example, fate of stem cell is determined of the this surface viscoelasticity. And most of the scientists are working on with polymer or such materials and play around on very narrow region of the elasticity. And but we are working on very soft region and very hard region. For super hard condition, we use fluorine. By using liquid-liquid interface system, we can precipitate very hard nanorod from C60. And actually, from C60, we can create very hard nanorod, and by using Langmuir project technique, we can align. And we culture stem cell and observe their behaviors. We can control such a morphology by using Langmuir project method. Sometimes we can get such a very rough particle surface. Sometimes we can get very aligned environment. And we culture stem cell and we observe behavior. And the cell interact with the surface. And this stimulus control genes and then control differentiation. And I do not tell detail, but our case, we can successfully control differentiation. But we suppress undesirable, uncontrollable differentiation. With keeping stemness, we can increase number of the cell because we can control surface viscoelasticity. Another crazy research in my group is we use organic solvent for cell culture. Usually cells is destroyed at contact with organic solvent like a chloroform. If we pour chloroform, hexane, benzene to living cell immediately died. But this is from Wikipedia. Some solvent, like fluorocarbon, it is not totally immiscible. It is not totally miscible with water, but it is not so harmful for cells. And not so many people are working in this area because it's very crazy research. By using fluorocarbon and the aqueous medium between this interface, we try to culture living cells. Actually, okay, its cell growth is quite depend on the fluorocarbon species. However, actually, cell increase. It means between water and fluorocarbon, cell is living. And we try to use it for stem cell. This case, protein self-assemble at interface, and protein and cell communicate each other. Actually, at the interface, this is a protein nanosheet. Such a beautiful two-dimensional sheet is softly grown at interface. And we culture stem cell, and stem cell change the shape like that. Stem cell feel small force from the interface. Actually, this case, protein change from sheet to fiber. According to this change, stem cell change from original stem cell to neural cells. We can control cell differentiation from the weak stimulus from the interface. This is summary of our research. As we show, we have a huge range of the forces, and most of our research in our chemical history, we are only using these strong forces to make such a machine motion through, for example, photoisomerization. However, nature is using such a delicate forces among thermal fluctuation. Control of this region create new sciences. And actually, I successfully control, for example, tuning of molecular receptors, and sometimes control of cell fate by using such a small forces at interface. This concept creates new field. My research is not useful at all yet, but the new concept creates new sciences. Finally, I want to show my colleagues. This is a picture a few years ago, but you may be surprised. This is my group in Japan. However, it includes only 3 Japanese. Most of them are foreigners from the UK, Czech, Poland, French, USA, Nepali, Belgium, China, Brazilian, and India. I know Indians are very hard worker. Actually, these 2 guys are very hard worker. It means in future, I want to have more Indian. Please recommend your student to apply some scholarship or funding like a JSPS to join my group. Thank you very much. It's end of my talk. Thank you very much.
Thank you, Professor Arigar. Very nice and interesting your talks in the supermolecular chemistry. I hope that the new routes of the tuning of the supermoleculars will be next Nobel work will be in the future. Okay, so now just one or 2 questions will be from the audience attendees. So please 1 or 2 questions from the attendees, please. So you can write to the email letter in the chat, also you can write so that you can speak to the speaker. Please, 1 or 2 questions. Yeah. 1 or 2 questions from the, yeah. So. Hello. Yes.
If there are no questions, I think
wait.
forward.
Yeah, okay. Yeah, so Professor, so can I ask one question for Professor Arigar? Hello?
Yes. Hello,
Yeah,
yes.
one question, actually, very interesting, actually, was very nice. I'm very thankful for your accepting our invitation. And
Yes.
I just want to, is there any light-induced host-guest interactions in the, is there any light-induced, means, like I use UV light or near-infrared or visible. Is there a change in the light in this one, the host-guest interactions?
Yes, okay. Host-guest interaction may be much weaker than photoisomerization.
Okay.
Also, okay, the control such a weak interaction by light is meaningful.
Meaningful. Okay.
Yes. But we have to pay attention weakness of the forces.
Okay. Because very interesting and very new challenging and for future, and this is very good for the good interface in the life science and science operations. A new concept. This is very useful for future. I thanks Professor Arigar for your interesting talk, and hopefully many students of India will join your group. Thank you.
Yes.
Yeah.
I know. India is working.
Yeah.
Actually, I have one postdoc from India, and she is working in weekend.
Okay, sure. I'm very happy. Sure. Thank you. Yeah, for giving your time giving to us. Yeah. Thank you.
Okay, thank you.
Yeah. So next speaker is Professor Gunato S. Okram. His talk is outcomes of nanotechnology, and he's coming from EGCD Consortium for Scientific Research, Indore, India. And his brief biodata is just, I just mentioned here, just few. Professor G.S. Okram did his PhD from IIT Mumbai, and he worked at 3 research institutes, including NIMS, Japan, 1996-98, where now Arigar is the director of the institution. I thanks Professor Arigar for this study, and as the STF fellow before joining the EUCD Consortium for Scientific Research Indore. And he was a scientist D in 2001. He is now scientist G, has guided 3 PhD students, 6 MPhil, and 4 MTech program, and 50 MSc, and 5 BSc project students. Deliver over the 70 invited lecturers at the different national and international conferences, and awarded outstanding contribution in the reviewing the papers of 7 reputed journals, many others published over the 120 peer review journals, and he was attended about 117 conference presentations, and he has citation around 1,435 citations. With this brief biodata, I'm inviting Professor G.S. Okram for his giving interesting talk. Please, please share Professor G.S. Okram for your. Hello, Professor Okram, are you hearing? Hello.
I think he
Professor,
just stuck.
Yeah, just turn something. Okay, that's right. Yeah, just 5 minutes.
Yeah, he is coming online now.
Yeah. Yes. Yeah.
Professor Gunado, kindly share your slide.
Yeah, please. You have this. You have the slide also. I think you will be having slide for his. Hello. So, Neeraj Luang, do you have his slide? You can upload also.
Yeah, I have the slide, but he wished to share from his end now.
Yeah, but he is not sharing his anything. Yeah. Hello. Can you phone call him or something like that? Or I should phone call him? Because it seems to be he has not been doing anything properly.
Okay, I will share from here.
You can speak from there. Hello. I think Dr. Luang, you can say, I think you can do better because he could not do, I think, maybe some technical problem. I think. He's stressing, I think. Yeah.
Hello, I am
So
sharing
Professor,
the screen now.
Professor Okram, how do you?
Hello. Am I audible?
Yeah. Yes, we can hear you. Actually, the screen is shared by me. So let's proceed. You can just say next after your. Hello.
Hello. Hello, Okram.
Am I audible?
Yeah, we can hear you.
Yeah, so we are waiting you.
Hello.
Yeah. Yes. We're waiting you. Hello. Hello, Okram. Are you hearing my?
Hello.
Yes.
Hello.
Hello. Yes, we can hear
please,
you.
Please start. Please start your talk.
Hello.
Yes. Please start. Yes.
Am I audible?
Yes.
Hello.
Yes, I'm hearing. We are hearing. Hello.
Hello.
Yes. Please continue your talk.
Am I audible?
Yes, we are audible. Yeah.
Tavi bro.
Yes. Please continue your talk.
Okay, please start from the beginning.
Oh, first beginning. Okay. Dr. Neeraj, can you start first slide? Yes.
No, I'm not audible.
Yes. Can you see this? Have you seen?
Okay. Am I audible
Yeah, please
now?
start. Yes, please. Yeah.
No, I'm not listening any.
Okay. Yeah, we are listening your yes. I think you are mute, I think. Please keep the sound unmute. Hello? Okay, and he's just bring his phone. Hello? Hello?
He has come online.
Okay.
Yeah.
Please.
Dr. Akram, you can kindly proceed with your lecture.
Should I start?
Yes. I will control the slide from here.
First of all, thank you very much for inviting me to this conference. And I thought that this topic will be very much appropriate for the conference. And as Professor Rajmuhon and the Professor Arik has already introduced some parts of it, that's why I am easier still. I try to again some of the facts are not yet told. Okay, in that what we are I'm going to tell is that science technology of 100 nanoparticles, how they are changing our society, okay, as to how like this presently we have the sort of genetic arrays to how we are restricting to our houses or offices only, we could not meet each other, okay, right? So that is how we can do this thing with the help of internet or computer. All these things the consequence of such application of nanotechnology in the quite few of them would like to be given in this presentation. Next. Next. So there are some issues because of all these problems. We have so many other problems like the global warming and all other issues to how to control this or decelerating, and then how this nanoism tends to enter, and finally how to understand this. Then along with I will give application, potential applications, and finally outlook. Next, please. Next. So with this, see how technological advances in the last even millenniums, 11,000 years. So in that, the maximum development has been taken place in the last 50 years, 200 years. This is it is up vertically, almost vertically. Okay, this is how the all these events are going on. Okay? Like this beginning of second cultural revolution. Okay, beginning industrial revolution, invention of war engine, beginning of railroads, germ theory, so and so on. Okay, like you see nuclear energy, genome project, meant to move this and that. Okay, like this. Okay, this. Next. So our knowledge of computing power increases, our population increases, means it is proportional or the is coming up as an exponential function. Okay. So next please. So accordingly, these Creative Commons has classified what type of technology it is at and how art opportunities and things like that. In there, biotech is one that, and this is technologies, nanotech, green technologies. In that, what a frontier. Okay, in biotech, for example, integrated discipline in biotechnology of synthetic biology, biology and functional genomics for application in health. That in the opportunities like maintenance of genetic diversity of seeds and cultivated plants through utilization of genetic research and so on. Okay, digital technology, Internet of Things, this is what right now is going on with us. Okay, 5G, mobile phones, 3D print, massive open online courses, data sharing technologies, emerging model for financing transactions. Okay, now many things are going with this. Okay, like okay. Then what are the opportunities like manufacturing, resource efficient countries, action of financial inclusion in developing countries, okay, or resilient agriculture practices. Okay, in nanotechnology like solar energy, and then organic and inorganic materials, including the thermoelectric materials. In that, energy efficiency, increase renewables in global energy mix, improvement of water quality and saving water, and so on. Green technologies include energy, more cooking stoves, advances in battery technologies, smart grids, solar, salinization, third generation solar voltaics, and on. Okay, in that, environment, climate, biodiversity, sustainability, production, and consumption, so on are there. Next, please. Next. Sorry, this I just will introduce the whole because the experts. Sorry, I apologize for that. It is just for the beginners and other areas. Okay, to what is nanometer? It is the nanoscale. Okay, like the 10 volt is about 10 centimeter. That is 8 nanometer. Okay, you come down the line. Okay, small grade there. The hair is 10 to 5. Okay, and then as you come down and down, it comes first the protein and so on. At the glucose lies in molecular or atomic level, this is the scale, and in the region 1 to 100 kilometer is the one in general, people you believe there are a nanoscale, okay, like various types are there. Next, please. Next. Okay. So because when the size changes, the physical properties are also changes, because in solid there is crystalline structure with Lorentz, and then in glass range. In no material they be combined better. Okay, so like that they have same physical properties like quantum confined effects. As you decrease the particle size, energy will increase. Okay, so surface effects are there like this sort. Surface magnetization. Okay, means the either a material which was not magnetic will become magnetic when the material comes nano size. Okay, catalysis and boundary effects like subplasticity, hardness, excess free volume, etc. Okay, so next please. So the ground grain bound, how this is the boundary, these are grain, and they are very different from the main region core. Okay, so like these are some complicating in nanostructure. Next please. So let's see as to how these are involved in terms of the volume. Okay, set 1 cc in liter. Okay, 80.6 for the case of spherical particle or micron. How many such particles can be in a volume that it will be divide this number by this, then you get this number. This is about 9 billion number of particles in this. In the case of the particle and the size is nanometer spherical particle, it becomes this the volume. Okay, by this number, this you this number. Okay, that means about 9 into 18. Then how much is the difference? Is a difference of 10.9 order of magnitude. Okay, so 9 order of magnitude. Because of this, there is such a difference in the bulk material and the nanoparticle. Bulk can be like a city. Okay, please, next, please. Next. City like indoor anywhere. Okay, it several hundreds of people to come and go every day, but nobody knows if they are not related to you. Okay, so if when you have a next, please, a small family is next. Only like you have family of 4, you want your relatives like the grandmother or uncle is king, then everybody knows that are the things and what is planned, where we will sleep and that, or like that. All things are in. Okay, that means the small particle or the small family is actually active. Okay, so the history of nanoscience very old. Okay, it is about 2400 years old, like us 400 we see a glass. Okay, depending on how the light is falling, the color changes. This is how these are made of is only in 2004. Okay, so 80% of all is there and 14% for silver. Only this kind of phenomenon is less. Okay, similarly this calendar is there. Next please. And so in the context, carbon IIVT now also here. Okay, please. So in fact, modern technology has started probably enhanced since 1959 after research when the Nobel laureate physics has given a lecture in this 1959. There is plenty of room at the bottom. Next. What he suggested was that why not we possible to put all the information in Britannia, in Britannia. Okay, this likes we can put in this. That's why this IB has made a writing of xenon atom 38 atoms of L. Next, please. So like this, these are the features, the bulk metal which we already know here. Okay, already known. Okay, next. So we next list. The widths we have different materials we already see. Okay. This is silvery color, but this is black. Okay, for the same material when the size is very small. Next, please. So the copper color is like this. When it is made into smaller, different sizes of copper, it becomes this colors, okay? For different like silver, this is the color, and this is the gold, and this is titanium, and this is copper, again similar to this. So you can tune as to what is the color you want. This way there are different applications, various applications of nanoparticles, okay? So biomedical is there, healthcare is there, food, agriculture, industry, electronics, environment, renewable energy, and textiles, okay? With this, you can expand it whatever you want, okay? So like the environmedical, cancer delivery, antibacterial studies, drug delivery, molecular tagging, okay, bond growth, and UV blocking textiles, MRI, contrast agents, like that, okay? So many are there, like in energy, renewable energy, lithium ion battery electrodes, okay? Hydrogen production, photocatalysis, and others like the paint on solar cells, dye sensitized solar cells, fuel additive catalysis, and automatic catalyst. Next, please. Like this, several are there. This is how I am now introducing about the computer or the mobile in general as to how our calculation has been started from 2400 BC, okay, like abacus in China, okay. So like this, it grows slowly, but in the 20th century, okay, like this Microsoft and Apple, after the introduction of this transistor, okay, solid state device, and then finally ICs, the growth of the computing capacity has been growing just like that, okay. Every 2 years it should be double the density or capacity of the computers. Next, please. So I will just remind you about the phone calls. Many of you might have known about the phone calls in 1990s, okay, like this here, okay, how many users are here and how many users are there, and what is the call rate in 1990s, okay. So it was 1,000 to 10,000 rupees per minute, right? Okay, today how much? We are paying nothing, almost nothing, just paying how much? 5 milli rupees per minute, okay. How? Next, please. So in 95 approximately, I have taken as 100 rupees per minute. In 2020 value, it comes out to be 10,000, okay. My estimation may be too much, so you can take down to 1,000 only, okay. Typical salary was like this, and then in 2020 now it is about 600. You divide these numbers and finally you get this 5.5 paisa, okay. So like this, in cents, in American this thing is 700 nanocent is there, or $7 nano is there, okay. So this amount is too small to consider that we even don't have any is that in increase by 6 orders of magnitude, okay. So because the number of users have increased just like that, okay. This way the evolution of computers have taken place like this. Hard drive, okay. In 1956 the IBM ships the first hard drive, okay, that costs about $10,000 per megabyte, okay. That costs about 50 to 80 millions of rupees, okay. And what will be the weight? It will be about 1,000 kilogram, okay. But in 1980 IBM introduces the first gigabyte hard drive that costs how much? That was $40,000, 7 million rupees only, okay. How much was the weight? It was 250 kg, right? This one, okay. So in today's case we have 2 terabyte external hard drive, okay, pocket size of this size, and the weight is like 200 kilogram only, okay, like this, okay. So that costs hardly 6,000 rupees, but when we see this with the earlier capability, it will become 14 billion rupees equivalent in the earlier case, okay. It's like, okay, you have a truckload of banana that costs 50 to 100 lakh rupees, but if you have one only, it costs 100 5 rupees only. Like that is how this is how the dollar value is changing with time, and then this is the way how your capacity for the space for the so this slow please. So the computer has it like this. In 1976 the computer shape was like this, okay, but this was the only computer in the world, okay, not so many, okay. As you increase the years, okay, it is keep on changing the phase like this. While changing the phase is changes the capability so much so that, okay, you next please. So like this in 1960s or 50s your computer is like a room, okay, big room, okay. So as you come down the line along the years progressing, okay, the size is becoming smaller and smaller. Finally smartphone is coming, and your pen drive is so much that you can compare with the tip of your small finger, right? Next. So how this is decreasing is that in earlier times it was the electromechanical, and then relay in 40s, and then in 50s it was the triode valve, and it requires the main electricity, okay, not the battery, okay. In transistor now the battery has come in, not the electric line, okay. So finally integrated circuit has come in some 70s and up to now. How this has been changing, okay, is the case. So this is the telephone in 19. Please go. Okay. This is the phone in 1854. Okay, and then this is the in 1896 and next. So 1931. Next, please. And this is what we have now. Next, please. So this is the progress as to how the phone has become mobile, and how it has been integrated with computer is what is called a smartphone, okay. This is how the iPhone 11 is entered. Please change. Okay, so iPhone 11 brand Apple, they have so many slogans, okay. Pro cameras, okay, pro display, so on and so forth. Fastest CPU, fastest GPU, faster neural energy engine, sorry, okay, the A13, okay. And how much transistor it has? 8.5 billion transistor in an area of 98.48 mm, means that this is the size of the nail of your smallest finger. Please see your finger, okay, the smallest finger size, okay. So in that this many please next please. So much transistors are packed in that finally it turns out that the transistor size is just 7 nanometer, okay. So because of that it has faster performance, okay, reduction in power consumption, and 4 high efficiency core, and 20% faster with 40% reduction in power, and so on and so forth, okay. And not only that, their charging can be done without wire. Next please. So these are the different versions as how many transistor can be introduced in a chip, okay. Next please. So what Intel says is that the inexpensive, ubiquitous computing rapidly expanding all around us is fundamentally changing the way we work, play, and communicate. The foundational force of Moore's law has driven breakthroughs in modern cities, transportation, healthcare, education, and energy production. In fact, it is quite difficult to envision what our modern world might be like without Moore's law. Next, please. Okay, like this, we have several applications and advantages of using this massive Internet of Things, mission critical control, enhanced mobile broadband. This is what right now we are doing, okay, in for our conference, even though we are not able to see each other, okay. So this is what is, I think these are the other capabilities. Next, please. Now I turn to the global warming, okay, as to how this our overall activity is affecting to the ozone layer, and finally our climate change. Okay, this is what is the orange snow. Next, please. This is flood. Now it is going on several places, okay, where it is not expected. Okay, so with all these our activities, our environment is possible that we can reverse it. Okay, this is what. Next, please. When we use these thermoelectric devices, okay, so we can probably reduce or retard this process of global warming. Okay, so because the recent advances in this area, okay, figure of merit JT is very high. Okay, it's coming to around 6. And please next please. And because of that, so this efficiency, okay, can be equal to the same as the present machines or the engines. Okay, that means that finally we get 70%, not just the 30%, and that global warming factor 66 has been reduced to 30%. Is it possible, or what is the question? Okay, next please. So the thermoelectric figure of merit Z is given by this. Okay, so this is the Seebeck coefficient square, and then multiplied by the electrical conductivity and multiplied by the temperature divided by the thermal conductivity. If we see simply that this will be maximum, that is very important to be usable and very applicable. Okay, then kappa should be as minimum as possible, okay, and this should be as much as possible. That in fact is not possible in a material. That's why we need to engineer such a material that it should be composite, so that a phonon glass means the phonon flow is restricted as much as possible, but the electron flow is not. Please come back. And then efficiency, so sorry, okay. So the efficiency will increase as to how we can alloy the material in such a way that such a possibility is maintained in that material. Only then we can achieve this. Please. So next, please. With that, in that direction, we have next, please. We have this compound, okay, the copper doped bismuth sulfide. Okay, so in this what we prepare was in 2 hours at 180 degree, which was done earlier by Wang et al. In 62 hours at 120 degrees Celsius. That too requiring the extra waste, but we didn't do that. Okay, we did it simply. Okay, the next, please. So this is another in which silver is introduced in the silver sulfide. Okay, that enhances the thermoelectric properties of the material. Okay, so that is prepared by simple method, polyol method. Okay, so like that, final this there is a significant improved thermoelectric power factor at 325. Okay, so like that, because of that nano silver nano inclusion, okay, the highest JT was about this. Next, please. Okay, so in the case of camphor sulfonic doped polyaniline, we found 2.17 at 17K. For the case of selenium deficient layered titanium selenite, it was 0.14, but it was 6 orders of magnitude improvement from compared to the stoichiometric composition. Okay, this is how the material is made complicated or complex or composite. Okay, only then the material becomes better. Okay, so like that, we have done several approaches of making such material, like the choice of the non-toxic, naturally abundant, and the inexpensive elements. Okay, so like that, these several compositions have been studied. Okay, and then similarly for copper and copper oxide also was there. So that means that they are likely to open up new vistas for development of near room temperature for non-toxic and the solution process thermoelectric materials. Next, please. So in another case, there is a high yield multi-component synthesis of triazole 1,2-A indazole trions using silica coated zinc oxide nanoparticle as heterogeneous catalyst in the presence of ultrasound. Okay, so these materials have applications in combinatorial and medicinal chemistry, for example, antidepressant drugs, HIV protease inhibitors, and the present results demonstrate added advantages as high yield product, making them environmental friendly, doubly green reactions with wide applicability due to their efficiency, ease of handling, and cost effectiveness. Silicon coated zinc oxide nanoparticles as catalysts combined with ultrasonication at 60 degrees Celsius have been shown for the first time using UV visible spectrophotometry to exhibit excellent catalytic activity. Next, please. So there are some other example I am giving here, like potential impacts of nanotechnology in materials. If you have clothes, okay, which are not making dirty, that is good. Now, so this is what probably nanoparticles are likely to be able to do that. Okay, healthcare also, you can have several options, like already described some of that by the previous speakers. And so like that, chemical and biological sensor, drugs and devices, and in environment, how to clean the environment. Okay, this is what is the thing. And thin layers of gold are used in tiny medical device. Okay, like that, you have the environment, how to get the energy from the sunlight. Okay, that is what is the nano solar cell. In that, the efficiency becomes enhanced. Okay, so nano solar cell mixed in plastic could be painted on buses, roofs, and coatings, and solar energy becomes cheap energy alternative. Okay, so like this, you have several options in this. Next, please. So like that, nanotubes of carbon also is there. Next, please. So suppose like that, you have that if your car or any item is not getting dirty, that is what people like it, because many people are lazy. Okay, so paint that doesn't chip. Okay, so protective nano paint for cars, water and dirt repellent. Okay, like this here. Okay, when the lotus leaf doesn't stick to water. Okay, water doesn't stick to the lotus leaf. Okay, like that, some other leaves don't get stuck to water. Okay, like that, if you have car and car also, then you don't have to clean your car. Okay, so that means that resistant to. Okay, so similarly, environment cleaning, okay, with painting of certain compounds, okay, like titanium dioxide, okay, nanoparticles in paint break down organic and inorganic pollutants that wash off in the rain. Okay, decompose air pollution particles like formaldehyde. This is how it is air purifying with this thing. Okay, the extreme case, which is imagined by many people, okay, that Professor Arega also talked about such kind of thing. Okay, this is still more sophisticated imagination, right? You have nano robot. Okay, so that is injected to you just like any other drug, information and give it to your monitor, computer monitor, and that is seen by the physician, and check how it is to be checked and how it is to be relieved from that disease. Okay, like cancer and such thing can be possible. Okay, by such kind of healthcare. Okay, please. Next. Okay, this is nerve tissue talking to computers. Okay, this is what is the thing I told you. Next, please. So this, when you use nanoparticle, okay, the sensitivity increases. Okay, like when you introduce the silver nanoparticle, these are distinctly seen. Okay, this HIV virus is easily visible, not here. Okay, so similarly in the case of tumor cancer also, okay, you like in the red, these are the thing when you introduce such nanoparticle, you can see the spots where the cancer affected area is seen. Next, please. Next, please. So another thing one can say is the shark skin fashion in naval technology. Okay, like this, the skin is very smooth. That's why you can swim in water very fast. Similarly, if you have this, then your swimsuit. Okay, so then you can swim faster. And similarly, in the case of this submarine, okay, it will not be rusted, okay, or corroded with this kind of thing. This is what is the expectation or the thing in research. Okay, finally I will give some outlook. Okay, it is very fast emerging and ever growing interdisciplinary science, integrating all sciences such as chemistry, physics, biology, materials engineering, earth science, computer science. The power to gather data and control particles at such a minute scale leads to new opportunities of research and technology design, better understanding of materials, new ways to deal with important problems in healthcare, energy, environment, and technology. Sizable applications now, but the majority are fast progressing. Next, please. With that, I thank you very much for your patience with so much interruption. Still, then I'm not sure I can hear or not. If I can answer some of your question, I'll be happy.
Yeah, thank you, Professor Govt. Singh Swapana, for your very interesting talk on the nanoscience, nanotechnology, how the revolutionized.
Dr. Rajmuhon, I am not audible to you.
Now?
Actually, it is audible to us. I think, Dr. Okram, you might have some problem with your speaker.
Okay. Okay. So, the Professor Okram, so can I speak now, or I can continue to speak? Just see you unmute the mute, just check.
I think he is having some problem with his headphone.
Okay, and because maybe some technicalism, yeah.
So Dr. Ragumni can kindly continue.
Okay, continue with this. Okay, I think so now he could not listen to something. So time is so very now already times so limit something. So I think that I thank Professor Govt. Singh Okram. His very good talk and neuroscience, nanotechnology, and how they related to the society, how the revolutionized of this new technology. So now next, now I will give for the question answer because he couldn't listen. Okay. So next, I continue another third speaker.
Hello, Dr. Ragumni. Can you kindly unmute?
Okay, it's okay?
Yeah. Yes, it's okay now.
Okay, so now Professor Govt. cannot listen, so I continue the third talk, okay?
Yes.
Third talk is Professor Prof. K. Mukherjee. He's the director, IBSD Imphal, and he's just his talk is exploring the national product as a drug and keynote profiling and evidence-based validation. Okay, and brief his biodata is just sorry. Okay, I know he's very famous in his field. Professor Prof. Kumar Mukherjee is presently working as director, Institute of Bioresource and Sustainable Development, and in Imphal, and this Autonomous Institute of the Department of Biotechnology, Ministry of Science and Technology, Govt. of India. And having his center at Imphal in Manipur, Bangkok in Sikkim, Shillong in Meghalaya, Aijon in Mizoram. This research academic work highlights on the traditional medicine inspired drug discovery from the Indian medicine plant to make them available from the farm to pharma. He has been working as a director, School of National Product Study, a professor on leave of the Department of the Pharmaceutical Technology, Jaideva University, Kolkata. He has made several innovative and outstanding contributions in the academic, research, and the area of national product studies. And Professor Mukherjee is a Fellow of Royal Society of Chemistry and a Fellow of National Academy of Science, India, Fellow of the West Bengal Academy of Science and Technology. He has been awarded with the Commonwealth Academic Staff Fellowship from Association of Commonwealth University, UK, and the TEQIP-III Innovation Fellowship by Department by Technology, Government of India, Outstanding Service Award from Drug Information Association, USA, Career Award for Young Teacher from All India Council of Education Society. So for this brief, I request Professor Pulok Kumar Mukherjee giving his talk. Please. Yeah. He's there? Hello?
Hello, PK.
Yeah, he's there.
He's there?
PK, please.
Okay. Please upload his talk. Yeah. So I don't see him.
Yeah, we are not able to see his, what to say?
Yeah, it's his face.
He's not yet joined.
Yeah. He's not joining? Can you phone call or something like that?
Yeah, it was informed to us that he is joining. He's ready for the presentation.
Okay.
I think he might be having some problem with the connectivity.
So I don't find any in the.
Yeah, he has not joined till now.
Otherwise, can I continue for one, or is it too wide?
Yeah, let's wait for 1 or 2 minutes. If he's not available, then we can proceed with Dr. Rasnis from IIT Madras. He is present here.
He is present here.
So Dr. Brajakishore is making a call, so let's wait.
Okay, okay.
Hey, hi, can you hear me, Neeraj?
Yes, we can hear you.
Yeah, I was away actually. Did you say something to me? I forgot.
Okay, actually the IT number 3 Professor Mukherjee is not actually joining. Okay. So can you just give your talk for the IT number 4?
Yeah, no problem.
Yeah, so Dr. Raghumani, can you just give a small introduction about IT number 4 as Professor Mukherjee?
Okay, so the time we can be...
Yes.
Sure. Yes, so just introduce Professor... okay. Yeah, the Professor Rajnis Kumar is faculty of the Chemical Engineering IT Madras, and his talk is Future Energy in a Gas Hydrate. And just is his brief biodata, just I want to just pick up from his. Professor Rajnis Kumar is an associate professor in Chemical Engineering Department at IIT Madras. He hold a PhD degree in Chemical Engineering from University of British Columbia, Canada. People know BC, okay, in Canada. His research interests are unconventional energy and carbon dioxide capture and process development and scale-up. His research work has so far presented in close to the IT refree publication and with the ICE index of 35. Rajnis is recognized as a highly cited researcher from the NRIC. He has received Nazi Scopus Young Scientist Award 2006, and you can see his more his Google scientist. You can see more. So with this brief introduction, can I start this Neeraj? Because Pulap can join after some time, right? Hello.
Neeraj, you have to unmute.
Yeah.
I think let's start Professor Rajnis Kumar so that Pulap can join after there. Okay, Pulap Mukherjee can join. Okay, so please start this Professor Rajnis Kumar. Okay, please. Yeah.
So, thanks. I hope all of you can hear me well.
Yeah, we can hear you.
Yeah. So thanks Neeraj and thanks Professor Mani Lima. I came to know about this initiative of yours and I said right away yes to Neeraj. Before I start my talk, maybe I'll just play a small video. This is why I have shared this video slide over here. Can you see this in your screen?
Yes, yes, we can see.
Yes.
Yeah, so what you see, the red lines and these dots over here. So basically the dots are methane and the lines which you see there are water molecule. And basically they have randomly been mixed together, and what we are showing a simulation of water and gas being mixed together. And then you see what there is a pattern which evolved now, and then you see a very nice pattern. Can you see the pattern now?
Yes.
Yes.
Yeah, so the pattern which you saw was basically hydrate. So if you look at molecular level, this is how it looks like. You have a gas and water when you bring it in contact with each other. Can you see my screen?
No, you have
the PowerPoint one. Yeah,
No,
now can you see
it's coming out.
Yeah. So maybe I'll go to the full screen mode. Let me see. Yeah. And can you see, all of you can see this?
Yes.
Yeah. Yes.
And can you see my pointer also, like a pen?
Yes, yes.
Yes, I will see. Yeah.
Okay, fine. So then it's better. So what I'm going to talk today about is the gas hydrates, which you just saw at molecular level. I'll show you a few more photographs how it looks like in lab. Gas hydrates, why it is important? Let me explain you that first from this particular slide. So you see in this particular slide, you have in the x-axis different time zones. So I have broken it down into post-industrial revolution and pre-industrial revolution. And in the y-axis, you see amount of carbon which gets emitted when you get per gigajoule of energy. You see the y-axis, it says per gigajoule of energy. So pre-industrial revolution, typically the uses of energy came from wood, muscle power and all. But because of the identification of coal as one of the densest form of energy, actually industrial revolution took place. So coal became a prime source of energy. People used to burn coal to produce energy, and because of that energy, they generated steam, and then steam became useful for locomotive and all other applications. So primarily because of that, this industrial revolution took place. One of the challenges though, when you use coal as an energy, that you produce huge amount of carbon as carbon dioxide. So for every gigajoule of energy which you obtain by burning coal, you produce almost 27 kilogram of carbon as carbon dioxide. Now, there are other challenges. One other challenge is that if you burn coal, it produces huge amount of ash. And you remember that locomotive which used to run by coal now got converted into oil. Basically, overall, we shifted from coal to oil for all on-board application, because oil was much easier to burn, does not leave a huge amount of ashes at the end. Even though it was slightly costly at that point of time, today it's not that costly though, but still coal remains the cheaper form of energy compared to oil. One of the advantages of using oil is that now when you produce 1 gigajoule of energy, you only produce 21 kilogram of carbon as carbon dioxide, because in oil you have multiple other, not multiple, but one another component, that is hydrogen, which does not contribute into the CO2 emission. So oil is liquid, burns easily, does not produce any ashes, and it also gives you a slightly cleaner environment in a sense that it does not produce as much carbon dioxide. Now the next phase was natural gas in around 2000 to 2005, due to the oil shale gas boom and all. You see natural gas become quite inexpensive. I would not say cheap, I would say it's inexpensive because it's very valuable commodity. Today, natural gas is being utilized in pretty much most of power generation, which used to be initially done by coal. In India, we still rely on coal because we have huge amount of coal as a reserve. One of the advantages of natural gas is that the emissions which comes out after natural gas combustion is much better. You don't really pollute your atmosphere significantly. And also the amount of carbon which you produce for getting 1 gigajoule of energy is only 14 kilograms. So basically what you have achieved while moving from coal to natural gas is that you have reduced your CO2 emission by half. If you convert all your coal powered fired power plant to natural gas powered fired power plant, you would reduce your CO2 emission by half of what you are doing now. Now the future is hydrogen, which you see over here. Obviously, there are many challenges when we talk about hydrogen economy, and one of the biggest challenges is that the storage and transportation of hydrogen is still not economical. We are not still scientifically so advanced that we can store and transport hydrogen at economical cost. So this is why it's a challenge. But if you convert all your hydrogen to water, you get a certain amount of energy. And for per gigajoule of energy which you obtain by burning hydrogen, your CO2 emission will be significantly lower. Obviously, it will not be zero, because unfortunately, hydrogen is not a fossil fuel or not a fuel which you get as a pure hydrogen. You'll have to convert your natural gas into hydrogen, or your oil into hydrogen, or your coal into hydrogen. The other option is to convert water into hydrogen by splitting of water, either by solar or something else. But today the reality is that natural gas is one of the cleanest form of energy. However, in India, we do not have a huge amount of natural gas, and this is a challenge. Even though the shale gas boom has brought down the natural gas cost significantly, but we still have to import it. And importing natural gas is a challenge, and gas hydrate presents a solution for this problem actually. Now, what you see in this particular slide, you see a pie diagram where you see gas hydrate associated with a unit 10,000, and then fossil fuels associated with a unit 5,000. So basically what this diagram tells you is that gas hydrates, which are basically a source of methane, is twice as much as all the fossil fuels put together. So the amount of carbon which you can get by dissociating gas hydrate, which is also present under the earth, is twice as much as all the fossil fuels put together. And since gas hydrate is a source of methane, you basically have a plenty of source of natural gas, and which can sustain us for at least another 100, 200 years. This is again an unconventional form of fossil fuel. It's not a renewable source of energy, but for bridging the gap between current requirement of energy and in future whatever we will produce, either solar or air or wind. So if you have to bridge that gap, gas hydrate comes into picture. Now, gas hydrate at molecular level are nothing but ice. You have seen water, which has different forms in crystalline structure. So when you bring down the temperature of water, go below 0 degrees centigrade, you form hydrogen bonded water network, and that basically converts into ice. Hydrates are something physically very similar to ice. It's also hydrogen bonded water network. The only difference over here is that the cages which are formed in ice are much smaller in size compared to hydrate, which has a much larger cage. The other big difference is that hydrate can be formed even at room temperature. Ice you cannot form at room temperature. You have to obviously go below 0 degrees centigrade for water to go into crystalline form, solid crystalline form. Hydrates can form even at room temperature if you are at right temperature, right pressure condition. So gas hydrates are basically a crystalline compound, very similar to ice, physically resembling ice, which are again formed by hydrogen bonding of water molecule. This forms cage-like a structure, and inside this cage you have a gas, and a common gas which is found under the earth is methane from the biogenic origin or the thermogenic origin. And over a million of years, this methane and water has come together under the seabed and has got converted into solid hydrates. These are, again, as I was telling you, very predominantly exist all around the earth. India is basically, particularly India is blessed with huge amount of natural gas hydrate in Andaman and Nicobar Island, in Krishna Godavari Basin, in Mahanadi Basin, all the outer continental margin of India, we find hydrates over there. Now, hydrates at molecular level are basically of different structures. What you find under the earth are mostly a structure 1 hydrate, which is seen over here. You see a structure 1 hydrate. It is made up of hydrogen bonded water cages, which has two different kind of cages. One is called a small cage, which is represented by S over here. These are basically pentagons. 12 of pentagons come together to form this cage actually. So you see pentagon over here, 1, 2, 3, 4, 5. So this is 1, 2, 3, 4, 5. This top you have 1, 6, and then 6 at the back. So you have total 12 pentagons coming together to form this cage like a structure. You see this kind of cage forms because of this pentagon all put together. These are small cages. Then there are also large cage in a unit structure of a structure 1 hydrate. The large cages have 12 pentagon and 2 hexagon. So you see on the top, there is a hexagon. So the top surface is basically a hexagon. The bottom and the top are two hexagons. And then you have 5 pentagons at the top and 5 pentagons at the bottom. And then you get a cage which is slightly bigger in size, which is made up of 12 pentagon and 2 hexagon. Now, methane is a molecule of size which goes into this large cage as well as the small cages. You see the radius of these cages written over here. So methane is of perfect size which goes into the large cages as well as the small cages. And in one unit cell, there are 6 large cages and 2 small cages. Now, it looks a little complicated, but basically what I'm trying to say is that when you bring water and methane together at certain temperature and pressure conditions, these gas and water will crystallize together in a form of a crystal. The crystal has 2 different kind of cages. One is a small cage and one is large cage. There are 2 small cages and 6 large cages in one unit cell, which is made up of 46 water molecules. So basically, if you do the math, you see there are 46 water molecule and there are 8 gas molecule in one unit cell. That roughly around the hydration number of 6. It means for every methane molecule which is present there, there are 6 water molecules surrounding this methane molecule. Okay, that is why it is called hydration number of 6. So if you have most of the hydrate which is under the seabed, why it forms under the seabed? Because hydrate formation requires higher pressure. Under the seabed, you have hydrostatic head of water. So the pressure over there is high. Under the seabed, the sunlight does not go. So the temperature over there is quite low. So you have low temperature and you have high pressure, which is one of the basic requirement for hydrate growth. And this is why under the seabed, you have huge amount of hydrate growth over there. Now, methane forms hydrate, but suppose there is a gas which is bigger than methane. A gas which is slightly bigger than methane is a propane. So if you crack your crude oil, you will get methane, you will get ethane, you will get propane, you will get butane. So basically, if there is a thermogenic origin of methane under the seabed, you see there are not only methane present over there, there will be propane also there will be butane also. Now these large molecules cannot fit into the large cage of a structure 1 hydrate. So if it cannot fit into the large cage, obviously it cannot fit into the small cage. So propane is a molecule which cannot fit into the large cage of a structure 1 hydrate. And this is why it forms a different structure, which is called a structure 2 hydrate. Now you see what is different over here. You see there are 12 pentagon faces, no problem in the large cage, but there are 4 hexagon faces. Instead of 2 hexagon faces, now you have 4 hexagon faces. Now this cage is even larger in size because there are 4 hexagon faces, the cage size becomes little big. And this is why propane, which is slightly bigger than methane, can occupy one of the large cage. The small cage remains empty in a structure 2 hydrate when propane forms hydrate. Now, if you are forming hydrate of a mixture of propane and methane, then methane can go into the small cages and large cages will be occupied by propane. So if there is a thermogenic origin of this methane under the seabed, you see some structure H hydrate also present over there. But primarily, most of the methane which is under the seabed is of biogenic origin. That is, only methane can be produced because of the decomposition of these life forms under the seabed over millions of years. So most of the hydrate which you see under the seabeds are a structure 1 hydrate, but some of the hydrates are a structure 2 hydrate. And then there is another hydrate called structure H hydrate. The only difference over there is that the cage, the large cage over here is even bigger. You see there are 8 hexagon faces over there. So if there is a molecule which is much larger in size, cannot fit into the large cage of a structure 2, it can actually form a structure H hydrate. So you see a much larger cage of a structure H hydrate. Now another difference in a structure H hydrate is that there are 3 different types of cages in one unit cell. There is a medium cage, there is a small cage, and then there is a large cage. So typically, if a structure H has to be formed, it cannot form only by a large molecule. It also requires a help gas, and methane can be a help gas. Methane can occupy the small cages and the medium cages, whereas the other large molecule can occupy the largest cage which you see over here. So in nature, structure H hydrate has also been found at certain places. Basically in Alaska, there are some structure H hydrate also identified under the seabed. There is another type of hydrate which is called semi-clathrate hydrate. Now the difference over here is that in a structure 1 or a structure 2 or a structure H, the methane molecule or any other molecule which is present inside the cage, there is no chemical interaction between these molecules and the water molecule. So chemically they do not interact, they only interact physically, which we also know as van der Waals interaction. So whatever interaction you see there is physical interaction between the water cages and the large and the guest molecule which is present over there. There is no chemical bonding between the two. The guest molecule, basically the methane molecule or propane molecule freely rotates inside the cage. It does not come out of the cage. It comes out of the cage also at times, but it again goes back into the cage because there is only some kind of attraction between the cage and the molecule. There is no chemical bonding. So there is a large amount of movement between the methane within the cage. Sometimes it also can come out of the cage actually. So that is the classical clathrate structure where there is no chemical interaction between the guest molecule and the host molecule. The host molecule is the water cages and the guest molecule is say for example methane. In this semi-clathrate, however, the guest, you see there is a guest over here, this shown by this kind of large molecule. Now this guest molecule actually participate in cage formation. So the cages are not only made up of water molecules coming together by hydrogen bonding. These cages are made up of water molecule as well as this guest molecule coming together and forming a cage-like structure. But even in this semi-clathrate, you see there are two cages which is empty for gas molecule to occupy. These gas molecules can occupy these cages, does not chemically interact with the cages, but physically only remains over there. One of the advantages of semi-clathrates are that because you form hydrate with the chemical bonding of these guest molecule, these hydrate forms at much lower pressure compared to in these cases where there is only physical interaction. As you know, physical interaction is better when you are at higher pressure. So semi-clathrate hydrate basically forms at much lower pressure. So this could be one of the way for some technological application. For example, if you have to store methane gas in hydrate form, you can use semi-clathrate hydrate because you can store it at a much lower pressure. So after I have discussed about what are hydrates, let me explain you what basically you can do with these hydrates. So you see the hydrates, as I was telling you, the unit cell, this is the small cage, then this is the large cage, and when these two cages come together, how many cages has to come together? 2 of the small cages and 6 of the large cages. Then you get this unit cell structure, which is made up of 46 water molecule, and this is called structure 1. This is a cubic structure with PM3 and arrangement, and the size are 12.1 angstrom. Since this is cubic structure, you only need one size, that is 12.1 angstrom, the unit size of this particular structure. Structure H, however, is not uniform. You see there are A of 12.2 angstrom and C of 10. So these are basically hexagonal structure. These are not cubic structure. So there are 2 different sizes which you have to give for basically determination of the structure H hydrate at molecular level. Now, how does it look like in lab? It's very easy to basically form hydrate in lab. You see in this particular image, you have water molecule over here and you have gas molecule over here. You basically do a stirring of water and gas molecule because they don't dissolve each other very easily. You'll have to basically stir them. So once you stir them, you see you have stirred a gas molecule and water molecule. This is the interface you see over here. The temperature is 1.5 degrees centigrade and the pressure is 3 megapascal. And you see once you start stirring, you see there is some ice-like structure forming over here. Is this visible to everyone?
Yeah, we can see.
Yeah, so you see this crystalline ice-like structure forming because of this hydrate growth actually. You see there is this crystals which has now started forming. So it looks, if you look into this physically through your eye, there is no difference between ice crystal and hydrate crystal. They look exactly the same, no difference at all. And it forms quite fast. See, within 200 seconds, you see, 1200 seconds, you see there is almost entire hydrate is filled with this ice-like crystals, which are basically not ice, but hydrates. However, hydrates does not form at any pressure and temperature condition. There is a thermodynamics, there is thermodynamic phase equilibrium, which we call, so you see this line over here, this is the coexistence curve. So if you are below this line, hydrates will not form. This will be methane gas and water only. Unless and until you go beyond this line, hydrate does not get converted into solid. So what is the difference on this line? So actually when you are below this line, you are at low pressure and high temperature. When you are at above this line, you are at high pressure and low temperature. So basically, if you could be at very high temperature and high pressure, and hydrate will form. So basically, this could be room temperature also. So at room temperature, if you are at sufficiently high pressure, you see there will be a solid hydrate, ice-like hydrate structure which will form. Now this can also form at low temperature and atmospheric pressure. So when you go below at much lower temperature, hydrate will form at atmospheric pressure like ice. So there, this is the phase diagram that basically guides when hydrate will form. So under the seabed, because of the depth of the water, there is enough pressure and the temperature is low over there around 4 degrees, 5 degrees. When methane, water come together, it forms solid structure. Now, if under the seabed, if you have solid hydrate, the challenge over here is little different. So these hydrates have formed under the seabed over millions of years. Now these are all kept there. Unless and until you dissociate it, you cannot basically get the methane out of it. So for dissociation, you'll have to either increase the temperature or you'll have to reduce the pressure. So once you increase the temperature, you come out of this phase diagram. So solid hydrate will get converted into methane gas and water, and you can get your methane gas and convert it into electricity. Or when you go down in pressure, you can again get methane gas and water. So one approach for exploiting these natural gas hydrate reserves is to basically either increase the temperature or reduce the temperature. The temperature increase is known as thermal stimulation. That's a classic way of basically producing any heavy oil. So you thermally stimulate it. This is very similar to that. It is super heavy because it's in solid form. So you'll have to basically convert it into liquid and gas form. So basically you'll have to do thermal stimulation. The other option is to do depressurization. So you can basically depressurize the well, and then you will be able to produce your methane. However, there is a small catch over there. Unlike in oil and gas industry, where there is no phase change, a liquid oil remains a liquid oil. Just there is a small change in the density, there is a small change in viscosity. There is no phase change. Over here in hydrate, there is a phase change. You are going from a solid phase to a liquid phase and a gas phase. Now, if there is a phase change, there is a latent heat which is involved over here. And for that, to break that phase, you'll have to supply huge amount of energy. So when a hydrate is getting converted from a solid phase to gaseous phase or a liquid phase, it requires huge amount of energy to be supplied. And when you're trying to do just depressurization, that energy is not available. So when hydrates will dissociate, what would happen? It will take the energy from its surrounding area. So when you are trying to dissociate the hydrate, the temperature starts going down. So now the challenge is when you are over here and some hydrates actually dissociates, the temperature goes down. So when the temperature goes down, you see when your temperature goes down, you will go back into a stable zone. So the dissociation kinetics of depressurization is significantly small. And this is one challenge. The other way of exploiting some of these resources is to basically use an additive which basically changes the phase diagram itself. Now, instead of phase diagram being over here, the phase diagram has now shifted to an extreme condition. Now, if this phase diagram shifts to an extreme condition, you see the hydrates which were unstable because it was above the phase diagram. Now, the same hydrate has become unstable because now it is below the phase diagram. Sorry. So, what I was trying to say that this hydrate which was stable initially, which was above the phase diagram, since we have used certain additive, that has shifted the phase diagram over here, and the same hydrates are now unstable. So now if you add certain additives over there, the hydrates can be destabilized and a solid hydrate get converted into methane gas and water. So this is another way of basically exploiting these resources. So this particular slide basically tells you what are the different ways of exploiting this resource. Let's now come back to the reality. So what is the reality? What are the current status today? So there are different programs within Government of India, which is called National Gas Hydrate Program. The National Gas Hydrate Program 2, which started in 2015, multiple bore wells were drilled and were identified whether there are hydrates present over there or not. You see there is area A, area B, area C, area E. These are near Krishna Godavari Basin around Visakhapatnam and Kakinada area. So there were multiple bore wells which were drilled, and it was identified that most of these places have huge amount of hydrate under the seabed. Now the challenge for a chemical engineer like me is to identify a process by which you can basically dissociate this methane and produce methane out of this area. Now let's look into some challenges. So you saw the status, now let's look into the challenge. Now if you talk about the business only makes sense when you put certain amount of energy and you get certain amount of energy back out of it. Basically, when you talk about in money terms, you'll have to spend some amount of money and then you produce methane out of it. And if you cannot make more money, then there is no business sense out of it. Now let's look into some of the unconventional or conventional reservoirs and what is the well cost and what is the production rate over here. Now coal bed methane, which I'm sure most of you will be familiar with, the well cost for a coal bed methane is very inexpensive. It's like $1,000 into 1,000. So this is always multiplied by, so this is 1,000 units. The well cost is 1,000 units and the production rate is 500 units. So basically the well cost is low and the production rate is low. It basically makes a business sense. And this is why methane, coal bed methane is commercially viable. Now, when we talk about shale gas, Barnett and Woodford, you see the well cost is slightly higher. Instead of 1,000, now you say 3,000 to 7,000 units. But then this higher well cost is offset because the production rate is also high. Now, you instead of 500 units, you can produce around 2,000 units or 3,000 units. So this higher well cost is basically offset by high production rate. Now you go down to conventional Alaska fields where the well cost is even higher because it's in Alaska, it's deep sea. So you have 5,000 to 15,000 is the well cost. But again, this makes a business case because your production rate is high. So if you are investing more money, you can produce more gas out of it or more oil out of it. So your productivity is better. So it makes a business sense out of it. Now, conventional deep water reservoirs are even expensive, 50,000 to 100,000 units. But then the amount of gas which you get from conventional deep water reservoir or the amount of oil which you get from there is even higher. So still it makes sense. You see, this ratio is 1:1 over here. So it means still it makes business sense out of it. Now let's come down to gas hydrate. Now most of the gas hydrate data which is available right now is either pilot scale. There have been very few field trials over there and some modeling studies. Now if you look into the well cost over here, the well cost is in the ballpark figure of almost a deep conventional deep water reservoir, like around 20,000 or 50,000 over there. But then you see the productivity rate. It's 5,000 to 15,000, which is nowhere close to the productivity rate of conventional deep water reservoir. So there is a challenge. Your well cost is quite high, but the productivity rate is quite low. Now this does not make a business case actually. Now if you have to make a business case out of it, either you reduce the well cost or you increase the productivity rate. Now as a chemical engineer, what we do in our lab, we try to enhance the productivity rate from 5,000 to 15,000, we want to go to 50,000. Now if we can go to 50,000, then this starts making an economical sense. Because now you are investing a bit more higher money compared to your conventional Alaska field, but you are also getting more oil out of it actually. So this is the challenge which we basically tackle in our lab. So you see in our lab, we look at gas production rate. Now, as you see here, like any conventional oil field or gas field, you don't only produce pure gas, you also produce huge amount of water. And in this particular case, the hydration number itself is 6. So for every mole of methane gas which you produce, you also produce 6 moles of water. So the water production rate also has to be managed. Now, what are the operating pressure at which you can basically do this kind of studies? There will be hydrate or freezing control. As I was telling you that when hydrate dissociate, the temperature goes down, so everything will freeze and the gas production rate will reduce. So those kind of challenges. Then you have to also control the sand, because what we are talking about here, we are producing the gas in all the 3 phases. You have a gas, you have liquid water, and you have solid sand. So you have to manage all the 3 phases together. So this is a little tricky situation, and this is what we try to do. We try to do a process scale demonstration of these things. So now coming to this particular slide, I don't want to spend a lot of time over here because I see that I am running short of time. What I'm trying to say over here, that the entire research work is being done in collaboration with GAIL. They have interest in producing gas and distributing gas. So we do all the research work in collaboration with GAIL. So the funding comes from them, and we basically give them the technical support and the process know-how to basically look into this. So basically, when we started this work, we had a small lab scale setup. That was the phase 1 of this work. Basically, we first tried to quantify the decomposition kinetics of these hydrates. So basically, these are the lab setups where you basically have the similar kind of composition of sand and clay which is found under the seabed. You first form hydrates at the same condition which is found under the seabed, and then you basically study the dissociation kinetics by using your knowledge of chemical engineering and do some testing out of it to basically know the dissociation kinetics. So I will skip few slides over here and directly go into this particular slide. Obviously, when you form hydrate, you'll have to also see whether the hydrate which was existing in the nature and the hydrate which you have formed in hydrate in the lab, whether they match or not. So you see there is a very good match between what has been identified in the literature, which is recovered from the seabed, and what exactly actually you form in the hydrate. Now this is one of the slides which I'll spend a little bit more time before I move on to some more important slides. So what we did, we formed hydrate. Hydrate formation was not the study over here, because hydrate already exists under the seabed. When we form hydrate in the lab, we basically mimic the same conditions at which hydrate basically has formed in the environment. Now the challenge is that at what rate methane can be recovered. So we have to study the dissociation kinetics of this particular hydrate. Now in this particular slide, I will talk about this particular slide you see here. When we thermally stimulate this seabed or this particular hydrate in the lab, at 10 degrees centigrade, you see this is the productivity of methane from the hydrate which has already been present in the reactor. So at which time you see there is methane being produced at 10 degrees centigrade. Now, obviously, as if you remember the phase diagram, if you are at higher temperature, the dissociation of the hydrate will be more because you are further away from the phase diagram. I don't want to basically run through the slides, so I will again go back to the slides which I had shown you the phase diagram. It was little back, so I'll have to basically go back to the slide. So yeah, let's slow down. Yeah, now I have reached in the, can you see the phase diagram again in your window?
Yes, yes, we can see.
Yeah, so see the point, what I was trying to explain over here, I don't know, where is the mouse? Okay. Yeah, so you see this is the phase diagram. Now, say you are over here, that is 10 degrees centigrade, and you are over here, that is 25 degrees centigrade. So if you are closer from the phase diagram, you are just beyond the phase diagram. It means the dissociation kinetics will be much slower over here. But if you are over here, the dissociation kinetics will be much faster because much farther away from the phase diagram. But there is a challenge. The challenge is that if you are closer to the phase diagram, that is at 10 degrees centigrade, the rate at which methane can be produced is going to be slow. It means your productivity rate is going to be low, but the cost of production is going to be low because now you are thermally stimulating it only up to 10 degrees centigrade. Producing heating water to 10 degrees centigrade is low cost method compared to when you try to heat water to 25 degrees centigrade. So now you see the predicament. The challenge over here is that if you are trying to dissociate hydrate at higher temperature of 25 degrees centigrade, you are spending more energy to heat the water, but then you are also getting more methane gas produced out of it. But if you are trying to do the thermal stimulation only at 10 degrees centigrade, you spend lesser amount of energy, but you also get less amount of energy in any given point of time. Say in 40 minutes of thermal stimulation, you only get say 5% of your hydrate dissociated. Whereas if you dissociate at 25 degrees centigrade, you almost get 100% of your hydrate dissociated. So that's the challenge. And this is where we basically looked into different depressurization. I will not talk about today because it's little tricky. As I was telling you, depressurization basically does not give you enough amount of methane because it's a very slow process. So then we went back to our drawing board in a sense that we started designing molecules which can basically produce methane at the same rate as it produces at 25 degrees centigrade, but we only heat it at 10 degrees centigrade. So as I was telling you, if I use certain additives, the dissociation kinetics can be improved. So what we do is that we now produce methane at the same rate at what you get at 25 degrees centigrade, but at lower temperatures, so that your cost of production is low, but your productivity rate is high. I'm skipping some of the slides. This is one of the pilot plant setup which we worked with. So basically it's a continuous setup. I will show you a slightly bigger image over here where you see this is the reactor. You see this is the reactor where hydrates actually form. And then these are all the attachment where we basically study the dissociation kinetics of hydrate. You see this is a sand bed with water. It basically mimics the under the seabed. It's at high pressure. It can operate at 150 degrees centigrade, 150 bar and around 5 degrees centigrade. So you see then when the hydrate dissociates, you see bubbles of methane coming out of it. So basically we first synthesize the hydrate in this particular setup which you saw in the last slide. And then we study the dissociation kinetics and see how we can improve the dissociation kinetics in presence of some of our additives. How much time I have, Neeraj?
Just 1 minute, 1 or 2 minutes only now. Hello?
Just 1 or 2 minutes. I realized it. I am trying to move my slide. It's not moving because it seems that my desktop has gone a little slow. Anyway, I'll hopefully I'll just present one more slide, which I hope it goes there.
We are still in slide number 24.
I see that I'm also not able to move actually. Unfortunately, our ACs are not working because of this COVID situation, and the room is quite hot. We are in Chennai. So, looks like my desktop has got heated up a bit.
Okay.
There was one slide which I wanted to show because obviously I cannot discuss everything in half an hour or 45 minutes. Okay. See, but fine. I think this, so this particular slide you see over here, what we have basically achieved in this, you see, there are different additives which we have used where it's written A1, A2, A3, A4, A7 and all. What we have achieved over here is that if you try to dissociate hydrate at 293 Kelvin, this is pure water. Within 0.3 hours, you can only dissociate 20% your methane. But if I use one of my additive, say this green additive, I don't even need 0.3 hours. Within 0.1 hour, I can dissociate almost 90% of my methane. So what basically it boils down to, that if you are in a field where you have to thermally stimulate a field for say 0.1 hour, you get all your methane which is present over there. Whereas same field, when I just stimulate it with pure water, I have to wait for like almost 1 hour. So it means for 1 hour, I have to supply water at high temperature. Then only you will get certain amount of methane. In presence of some of my additives, obviously these all are patented additives by now. This joint patent between GAIL and us. So you know that in presence of these additives, you can basically reduce the cost of operation. You can enhance the production rate. And basically that takes you to my take-home message. And the take-home message is over here. So what basically we do depressurization initially, which does not cost you any money because thermal stimulation costs you money. You can just depressurize your well. So once you depressurize, you will get some methane. You see this methane is getting produced. But due to the depressurization, the temperature goes down. And once the temperature goes down, the methane dissociation will stop. And you see there is a flat line over there. Now here you can do a thermal stimulation. You do a small thermal stimulation by our method in presence of our additive, and then you can produce a large amount of methane. You have stimulated your well. Again, you can do depressurization. And then once it again saturates, you can do thermal stimulation all over again. So you can choose the temperature of thermal stimulation and choose the additive in each of these cycles based on the additives which we have designed. Certain additives might work at lower temperature, certain additives might work at higher temperature. So you can basically choose. So this was the take-home message. That's all from me. As I was already told you guys that the research was supported by GAIL. So my acknowledgement goes to GAIL. There are a lot of other work which we have done. I don't want to go. So right now we are working on this particular setup. This is a pilot plant setup, which is 15-liter reactor. We are trying to do many other things. You see, this is a complicated setup over here. You have multiple different pumps. Now you have an injection well. This is a production well. This is another horizontal production well. So you can basically inject different molecules. Either it could be water, it could be carbon dioxide and all. And you can produce methane. You can see whether it has to be horizontal well drilling or it has to be vertical well drilling. So all this is basically part of the work which we are currently doing. Again, along with GAIL, we have patented these things. So we, at the end, I acknowledge the funding support by GAIL and all the work which was done by the student, because I don't do anything. All the work was done by students. So the acknowledgement goes to the students. Thanks a lot for listening to me. I hope I have been able to explain you. If I am physically present in front of you, it becomes easier for me to explain. Presenting over a computer becomes a little difficult. This is why it takes a little more time.
Thank you. Thank you, Professor Rajneesh Kumar, and very interesting talk how to remove the methane from the hydrated methane. Okay, very nice, interesting. So now one question only, 1 or 2 questions from the attendees, please. Sure. Any attendees can give you their lighting also.
So I see there are 68 participants. Even 10% people ask, then there will be 7 questions.
Yeah.
Go ahead.
Yeah. So there's no need question from you. So can I ask one question from me?
Please go ahead.
Okay. If the methane is surrounded by water, so how many water can be coming together? And it means how many coordination number can be increased by pressure?
I didn't get you completely. Can you please
suppose the methane is surrounded by water molecules?
So basically, see, this methane is surrounded by water cages. Which
how many water cages?
Six molecules. So every molecule of methane is surrounded by 6 molecules of water.
6 molecules. But if you use pressure.
So when you are dissociating, you don't need pressure. You need to reduce the pressure. But when you are forming, you'll have to form. You need pressure, because then only these molecules will come and interact together. Pressure is mainly required because you are dealing with a gas and a liquid. If you are trying to interact a gas and a liquid and there is no chemical interaction between them, then you'll have to go to a higher pressure so that there is enough density between these gas and liquid so that they can interact suitably. If you are forming hydrate by 2 liquids, then you don't need pressure. You can form hydrate by a liquid called tetrahydrofuran in water. This hydrate forms at 4 degrees centigrade without atmospheric pressure. You don't need to go to any pressure. So the pressure is required because we are forming gas hydrate, nothing more than that.
Okay, nice. Thank you for your very nice presentation.
Thanks a lot. Thanks for giving me an opportunity to present my work.
Next floor. Yeah. Thank you. Yeah. So now the time is very limited, so I pick up. Can I pick up Professor Pulak Mukherjee?
Yeah, he's online.
He's there?
Yeah.
Online. So can I pick up? Okay. So so I just introduce his brief biodata. Actually, I already given his brief biodata, so he can start. Yeah, please. Yeah, he can start directly because I already given this one. Okay. So he's there.
Yeah, he is there. He is unmuting now.
Just can you call him? I don't know. He's unmuted.
Professor Pulak, can you kindly unmute your mic?
Yeah.
Hello.
Please. So you can proceed now.
Proceed.
Hello, can you see? Can you see my slide and hear?
Yes, we can see.
Yes.
Yeah. Thank you for inviting me in this seminar. And in fact, I can hear that you are having a lot of good discussions on this particular context. So I'll highlight some of the context on this natural product as drug, chemoprofiling, and evidence-based validation. On the in this mainly the major aspects on this when we talk evidence-based validation. As you can see nowadays, the things has happened that drugs from the nature and what are the drugs from our ancestors. Those are the drugs which are being explored, and a lot of things are happening during this COVID pandemic, where starting from politicians, bureaucrats, and everybody talking about science on plant drugs, medicinal plant as drug. And then when we talk on that particular context, you see that anywhere and everywhere, the molecules which were developed, they have come off from varied biological resources. This is our institute which is Autonomous Institute under Department of Biotechnology, the Institute of Bioresource and Sustainable Development, which has a mission on bioresource development and their sustainable use through biotechnological intervention for the socio-economic growth of the region, where we have 3 different other centers beside Imphal. One is in Mizoram, another one is Meghalaya, and then in Sikkim. And we have been working on this specifically the bioresource development. In fact, I joined this institute in February. Before I was in Jaideva University in Calcutta. And we have been, the major thing when we talk about the plant from the nature, this is the plant which are talking about from the traditional or ethnopharmacological perspectives. Now this ethnopharmacology, This is the root of any drug which is existing directly or indirectly. Think about aspirin, think about Taxol, think about artemisinin. Anything and everything has come up from that ethnopharmacological leads only. And when we talk about those leads, then only the different aspects of the development of the biomolecules come. And this ethnopharmacology terminology, it was evolved in 1967, but it has been nurtured in a very different way further for development of these drugs. So talking about, say, quinine or artemisinin or even Taxol or even aspirin, everything comes from this ethnopharmacological route. And that way we say that this is the integration of scientists together, where role of chemist is very, very vital. Then pharmacist, the doctor, and other all professionals are involved, where this ethnopharmacology and integrated medicine, that really led, that is a history, but that tell the future. And this is the situation what we are experiencing even today. So friends, when we talk about that development of drugs, then one thing we have to think on that integration of different approaches for drug development from Ayurveda, Indian system of medicine, or even traditional medicine. So this integration means integration of all fields together, starting from anthropologist, botanist, pharmacist, modern medicine doctor, Ayurvedic doctor, all section of chemist, chemical engineering, downstream processing, and so many other things. I'll show you some of those examples on this, like say, if you talk about the leads from Ayurveda or in traditional medicine, see that this is a plant which has given a lot of effects on this Boswellia serratus. That is the alpha boswellic acid, and this is a very potent anti-inflammatory drug developed from our traditional medicine itself. But point is that if we isolate boswellic acid and that make tablet on that, it not always work. So Boswellia serrata extract contains so many other compounds together, but boswellic acid is one of the bioactive compounds. And here the points come that this extract contains several other constituents which has its own perspectives of presence there, which is called the synergy and synergistic action. Similar, there is another example of Gymnema sylvestra. You know, this is one of the very well used plant which is used in diabetes, where gymnemic acid is one of the constituents. But gymnemic acid alone cannot reduce the effect as is required. So synergy is one of the component again here. We'll tell you some of those examples how we establish the synergy with the chemical or chemoprofiling in next few slides. The true is for ashwagandha, the very well used plant, Withenia somnifera. And when you, as you know, this Withenia somnifera has a lot of constituents, and these constituents together give the activity not only with withaferin A. Now, in this context, if you go through, that the point comes that when we have the medicine from our tradition or the medicinal plant, there is a need for their validation. And this validation is based on the evidences, because evidences was created long back by our ancestors. And those things we need to validate with modern days chemistry's perspective, like say, first is the selection of the specific plant material, and then comes the phytochemical evaluations, then phytochemistry specifically involved with the constituent present therein, and then their high throughput screening, effect on the biological study, the bioavailability, PK, PD study. Again, the chemistry is very much involved, that how they are interacting with the drug, what is the changes in the proteins taking place with the protein structure and all. And at the end, when you go on quality evaluation or validations of these medicines, then the same aspects come into account, that quality evaluation and validations of this Ayurvedic medicine is very, very vital. In this context, the major marker profiling is one of the major contexts, where we have two types of marker in plant. That is reflected by chemical fingerprinting. We can reflect that one. That phytomarker, which is present in the plant chemistry, is involved, and is biological active marker, where again biological activity need to be nurtured. The point is that when we put those biological activity and the chemistry together, then that is the ultimate aim of developing a drugs from the nature. Here is one example of, sorry. There is one example with that andrography speniculator, Kalmeg. This is a very well used plant. You see andrographolite is the component which is isolated, and then if you go on the high performance thin layer chromatography HPTLC study, we can very well compare andrographolites with other presence of other component in that plant extract, and we can very well know the content of andrographolite present therein. So this is the chemical standardization where lot much of chemistry is involved, starting from developing the solvent, detection of the compound, evaluation and their validations, and developing the technology for the analysis of the constituent present therein. Same is true for curcuma longa, you know. Curcumin is the constituents, and then with the extract, if you see, there are a lot of component present there, and how much of curcuminoids is present there, that is one of the major target we need to establish. Now, when we going with these perspectives, that chemical aspects need to be linked with the biological aspects, and these biological aspects, when we work on that, then the major thing is that that we have to know about the different pathophysiological conditions of the disease. Like showing you one example of Alzheimer's disease, where the neurotransmitter acetylcholine is broken down by acetylcholinesterase enzyme, and this amount of acetylcholine is less in the brain, so we cannot memorize the thing. So there is a deficit in the learning and memory process, and this is one of the pathophysiology that if we can have some inhibitor of that acetylcholinesterase which break down acetylcholine, that can really give us one perspectives on this in this context. And then in this context itself, that if we go through that, we'll be definitely making a very different contextual development, that here is some example on the food plant which are being used in Alzheimer's disease, and those things, these Alzheimer's conditions, that these molecules can inhibit that acetylcholinesterase enzyme. And here is another example of the Indian drugs gives Alzheimer's hope. What was, in fact, we work with King's College, and that was highlighted in a very different way. And then these perspectives was evolved in the context that where we have been working in this particular area for developing drugs which can inhibit the acetylcholinesterase enzyme. As you know, Northeast is the biodiversity hotspot, and the medicinal plant of Northeast India has a lot of potential, and there are, on this particular context, there are enough scope to work on that, and you are very much welcome to join with our team for working in this particular area for developing the drugs from the nature and for the ancestors. Now coming to the chemical perspective, specifically chemoprofiling, where metabolomics in medicinal plant research play a very vital role. And this metabolomics is sometimes targeted or sometimes untargeted metabolite identification. This targeted or untargeted secondary metabolite identification, quality control of medicinal plant, chemotaxonomy, and then that can help in identification or quantification of the adulterants as well. And at the end, we go on metabolite target analysis or metabolite profiling, which relates with the pharmacological or pharmacokinetic study. Now, when we do all these things, this chemoprofiling can help us in developing a particular constituent. Here is the example with Bacopa moneri, where bacoside is the constituent, but beside bacosides, there are a lot many components together. We need to develop the metabolomics, which can help for standardization of the herbal products and quality evaluations of these Ayurvedic formulations containing this particular plant. Another example, say like, as you know that with the LCMSM study, when you go on this particular Lupha acutangula, and then you see that there are a lot of constituents present therein, and this enzyme kinetic analysis of this particular extracts indicate the presence of phenolic compound, and from there we can bioactive compound, the phenolics can show the specific therapeutic activity. Another examples with the Mumotrica charoncea here, which again bioactive compound against pancreatic lipase. And then here again positive correlations between this phenolic content of these Mumotrica foods and pancreatic lipase inhibitor activity was established in a different study, and we did the LCMS study and know the chemical profile present therein, and then we can link that one. So friends, what is the need of the hour is that we should have a systematic approach for validation of this traditional medicine. This systematic approach relates with the activity which has been reported, and this is a document what was made with 21 countries people involvement, where we really want to validate the traditional medicines at large in a very, very contextual way. And then these things, again, if we go through that, we'll be making a, so like you take the example of this particular herb, Trigonella phonium, which is very well used in our food. And then this has a used in traditional hyperlipidemia, hyperglycemia, with presence of different compound. With LCMSM study, we have identified 13 compound. And this network pharmacological study showed the mechanism of actions, which I'll show you later. Here, if you go on this network with this combination synergy network, that this 13 compound have 23 target, and this target to the specific disease. And with this networking, we can have the hyperlipidemia network, which can be proven the traditional medicine, hyperglycemia network, insulin sensitivity network. To prove that this Trigonella phonia, rasam, the methi, which works, which is referred in Ayurveda and traditional medicines, or even it is very effective against lipidemia and glycemia as well. So validations of those particular contexts when we talk about, then there are evidences in the traditional use, and those traditional use evidences from tradition, we have a trend. And this trend is that we have to establish the efficacy and safety of those drugs, taking the chemical profiling into account and establish the effect of those particular drug in very different way. And these are some of the high cited publications from our group, which has really made some of this specific component here. I'd like to highlight here, this is on this metabolomic context, that one thing is very true, that we need to have established the quality control and evaluations of these drugs, the profile of quality control and evaluation. And this quality evaluation needs the chemical profiling of those drugs in a very, very different way. And this, when we are talking about these validations of quality control, then these specific aspects can be taken into account in a very differential context. Like, say, we talk about the content of the traditional system of medicines and harmonizations, the ethnopharmacology and ethnomedicine inspired drug development, quality evaluation of the herbal medicine, including the qualitative test, morphological test, extraction and downstream processing to get the bioactive phytocomponent. Then relates with the standardization profile like thin layer chromatography, high performance thin layer chromatography, liquid chromatography coupled with mass spectrometry, and so on. And then that relates with the bioassay guided isolation to know the chemical constituent which may have biological activity, and that can be relates with the plant metabolomics for the quality evaluation of the herbs, with the safety, their toxicity study, and at the end the quality assurance of the herbal drugs for the stability testing to be used as in the medical system. So for that, we need to have evaluation of the herbal drugs to a high extent. And this is one of the documents which we made with long effort. And what I believe that starting when we have been working in a specific context in that it is not that when we are working with the traditional medicine, we are working with the traditional medicines, we are working with something new. Rather, we are rediscovering the things which is established. And this rediscovery based on our ancestors' knowledge. So that knowledge need to be, this is we call reverse pharmacology. So like in a modern medicine, we get a molecule and then get its clinical study done. Here, of those components. And then if we talk in this particular system, there is like that, say now, as I told in the present scenario, we talk about that ethnopharmacology, the ancient people medicine. Now, in that ancient system, now the system has come that we have to make the things in a very, very different way. We are reimagining the things in the present scenario. As I told that everywhere we need science, scientific aptitude and all these things. So it is not the molecule only, it is the molecules together, it was the synergistic approach. What we are thinking in a very different way now, starting from immunity booster, immunomodulator, and so on. So on that context, and at IBSD, we have initiated a program, Phytopharma Mission Program, and in that we have been working for to develop or initiate a journey toward promotion of the medicinal plant used in the traditional medicines by reimagining the ancient context in the present scenario for chemical profiling and so on. And I just want to tell you that there is Society for Ethnopharmacology India, which has taken a lot of initiative in that. We had a specialist in this Journal of Ethnopharmacology, on which I am associated for quite a long time. And this international society again has joined with the International Society for Ethnopharmacology Switzerland with an IBSD jointly. We are organizing a weekly webinar in this particular area for developing the drugs from the nature, drugs from our ancestors. Again, another specialist with Journal of Ethnopharmacology on Ashwagandha has come, which we are developing, and some other in the pipeline, which we are trying to put our traditional resources with the chemical aspects in a better way for development of the bioresources at large. So friends, healing plants are the nature's gift for everyone. So let us promote those gifts and preserve those gifts for the future. And at the end, exploring those gifts for the betterment of the society is very much needed. And on that, we have been working, and we'd like to invite all of you to join in our initiative and let us do something in this particular area for exploring the bioresources, specifically the bioresources of the Northeast, with their chemical profiling, documentations, and development at large for the help of the betterment of the society at large to a high extent. Again, thank you very much for the invitation, and I'm really very much very sorry that I was not able to come up in that time. There are a lot of things, meeting and other things. Till another 2-3 is there. So again, I thank you very much for your patient hearing about the concept, what we want to put forward and which we are working with. Thank you.
Dr. Raghumani. Okay, thank you, Professor Mukherjee, for the kind talk and about the details of all the different biodiversity that we are available in Manipur. Okay, Dr. Raghumani, please continue.
Yes. So very thanks, Professor Prof. Mukherjee. Very interesting talk in the herbal medicine and how the healing. Very happy. So one question only we pick up because now time is limited. One question from the audience or attendees. So no question comes. So I thanks Professor Mukherjee for giving interesting talk on the herbal medicine, how the working in the medicine state. Okay, thank you. So next talk is Professor Jaideva Singh.
Someone is asking one question. I think
one question. Okay.
Please ask.
Yes, please.
Sir, can we use the methanolic extract materials for in vivo studies?
Yeah, one question from Asrata Nepram.
Still loudly, please. I'm not able to hear.
Yeah, we are not able to hear properly.
Yeah.
We are not able to hear.
Sir, can we use the methanolic extract materials for in vivo studies?
Methanol extracted.
Okay, good question. Very good. Yeah. Yes. You legally you cannot use. Okay. That's like methanol is a carcinogen. And you cannot use a methanol extract. You are supposed to use the hydroalcoholic extract. But if you are using this methanolic extract, then you have to ensure that the methanol has been removed, and that should be as a documentary proof with you that there is no trace of methanol. In that case, that can be, but methanolic extract usually not accepted. You have to use hydroalcohol, ethanol, water, or only ethanol, whatever. Okay.
So now there's no question now. I think that we continue the another speakers. Thanks, Professor Mukherjee, for your very interesting. Okay. So now the next the speaker is
okay. Thank you. Bye bye.
Jaideva Singh. So I just introduce him his brief, and he going to give talk in the this one AI based application and a benefit of the knowledge state. Okay, AI means this is the long form is the artificial intelligence. Okay, so now his brief biodata just already pick up. Professor Yunam Zainta received a master and PhD in computer science from the Dr. B.A. Maratha University, Maharashtra. I think this is belongs to the Aurangabad. He has a 17-year in management of the PhD and training and software industry in the multinational institute. Currently holding the post of director at the National Institute of Electronics and Information Technology, Guwahati. With the additional charge of Shillong, he has worked as a professor and head of the Department of Computer Science, including the QS top 300 universities such as the Schoenberg University of Technology and Misrata University, Nottingham, Trade University, UK, and Skyline University, Dubai. He also had the CMSS IT firms such as Kennedy and Canada, and for project from the previous Morris, USA. And he has published many review papers and has developed and taught courses of graduate and postgraduate students. He has produced many PhD students and tech students in the area of data warehouse and mining and cloud computing, data science, and digital image processing. With these few words, I inviting Professor Yunam Janta for his giving talk in the area of the AI-based application and its benefit for the Northeast state. Please.
Good day to all the participants and experts. And my sincere thanks to the team of Manipur Technical University and the Kanglei Khongyang Thijinyon group and the entire team of KHUMANG 2020. It is my privilege to share some of my expertise and some of the activities that we are doing right now here, who is a multidiscipline. I would like to request the KHUMANG team to share my PowerPoint because there is a connectivity issue with almost all the. I don't want to take the.
I will share. Yes,
yes. So some of the points that I'm planning to cover is some basic definition of AI and what AI, the artificial intelligence, can be used in different aspects of small states like Manipur or maybe the entire Northeast states. Because in AI can give a lot of opportunities of business, research, and you don't need to spend much amount for infrastructure development. And it is very nice to listen all the experts here, but most of the experiments that our experts, the former experts are talking about will be needing a lot of informations, a lot of tools and other resources. But I bring this AI-based application for the benefit of the candidates who are starting in their research in different area to use the AI-based applications so that they can minimize a lot of difficulties and other things. So please go to the next slide. And I'm very proud to say that from June 15 this year, India has been among one of the, you can see down, one of the AI-ready nation, including, in the level of Australia, Canada, and other things. So India has been working very much, doing a lot of homeworks to come to this level. And other small states like Manipur and the northeastern state also need to go to adopt a lot of AI activity here, which will have a lot of opportunities for the researcher as well as the startups. Next. This is one simple example of AI, the definition of AI, that AI can demonstrate several activities, which is going to help the interdisciplinary approaches. And also by using the AI activity, the machine, the dummy machine is going to learn from their experiences, and they are going to work in the way that human people are working. So AI does not need a lot of investment, few computers and some applications. So I'm going to explore some of the possibility maybe in another 25 minutes. Next. This is some of the essential AI application or the knowledge that you need to have. If somebody wants to go for an AI, there are a lot of online classes that need to have some idea on 300 hours of AI. Otherwise, you maybe end up with some definition of AI, but some of these online classes, many free online classes are there. So this is just I have given a definition where AI can be. helpful. Means AI definitions are there which can be helpful to your research area. Next. So first I come to the first area where I want to concentrate. Post COVID-19, everybody is expected to be digital literate. Digital literate means you need to know how to use the gadgets online, not only the gadget, the online also. So there are different ways of delivering classes. Everybody, whoever attending here is facing a lot of problem from the morning. So either you deliver online or you go for some other ways, different ways. The next way that of delivery is coming up is when the online things are not satisfied 100%, then people are going for blended mode. Blended mode means people are using some electronic gadget, also some offline and the online type of thing, mixing of this one. The third one is that this is a flipped classroom, which is very, very common, which is going on very, very fastly in European countries. So all the material has been given to the students in advance through online medium, and the student will discuss. You can see the rightmost corner, the flipped classroom. The teacher will be only assisting the students to solve their problem. The students will read them by themselves. You see the left side, this is a traditional way. The teacher is there, the students are listening to the teacher. Means in the flipped classroom, you will be provided a lot of activities to be done at your home by using gadgets. So using gadget, electronics thing, actually this is a business area because, please go to the next. This is the next business area because there are a lot of problems. So these problems has to be solved by the IT players. Some of the problems are about the poor connectivity. We know that you can see the first image. The teacher is using their, the mobile phone and relying. You can see the second line where the boys are listening, maybe through their TV, maybe through their reading room and other thing. The third one is some of the activity which is going on at Korea. So the poor connectivity is one problem. Another one is a hidden cost. So every parents, I also have 2 small boys. I also suffer. The material that is provided from their college and the schools, it takes a lot of huge data. For example, from morning to evening for 4 hours or 5 hours, 2 students are using the internet. Means in a one day, you know that 2 GB, 3 GB of the speed given, the free speed given by Jio or some other Airtel or something like that, that will be utilized. And there is a poor connectivity problem. Then the sense of the students, the reflection of the students also cannot be understood. In order to save some of the users of the internet, you mute yourself. Even during this entire presentation, I only become online now because I was also using my own thing. So this is a problem for all. What is the solution? The solution is we need to develop some app in order to incorporate the slow networks. So we need to use some UI UX facility where we need to understand the level of the user. For example, the level of the users are minor, like class 1 to class 10, something like that. The internet facility, the app application that you are making, it is not feasible, it's not suitable for that. You can see the GAM. There are GAM which is applicable for the youths. There are GAM which is applicable for the minors. So minor use different GAM than other thing. So the app application, those who are working in IT, electronics, robotics, and other things, they can take up this one so that, there are a lot of schools, colleges are there, they are having this problem. So in my institution also, the maximum percentage of attendance that I get so far is 51% only. So when I see this one, these were some of the problems. So what we are doing is we are making some app, which app will convert, which will facilitate the low network also to use. For example, I am sharing a video of 1 GB data, 1 gigabyte data. But when the boy from the other end, let's say that there are 60 students in my class, 60 GB data will be consumed. That's the loss of the estate. That's the loss of the network. Instead of this one, I can minimize the size of the video. I can minimize the voice. I can change the frequency. There are a lot of applications are there. When we explore something about the facility in UI UX facility, that all these facilities are available. The other option is the community radio. There are 2 types of community radio, like in Manipur also a lot of radio stations are coming up there. One radio is only on the radio where the students can relay their activities to their radio as well as TV and other thing. Other one is through the YouTube. Whatever the activities going on in their studio can be established by YouTube. And the maximum something like it goes from 5 lakhs to 15 lakhs. If you go for the totally licensed studio, it will come in 25 lakhs. 25 lakhs. So by 25 lakhs, you can start a lot of businesses. Same thing for the UI, UX also. Different application can be written based on the requirement of the schools. Lot of schools are there, a lot of colleges are there, not for Manipur, and this app can be also extended to the other part of India. Please go to the next. And this is one more facility that I put as a new business. A lot of activity as a research said that geography, 80% of the geography content is now AR, VR, virtual reality. So you cannot go to the Himalaya, but you can feel by seeing some video, which is going to be feel like you are in Himalaya. Maybe everybody have seen the 3D cinemas, so 3D cinema type of thing. Same thing, 74% of the entire lesson of histories are made out of the VR, natural sciences that we have discussed about, so many chemical reactions, hydrocarbon, nanotechnology, and all these things. You can see all the graphs down here, left more corner, the boys are watching some of their chemistry or the beats of the heart through AR, VR. And in the right side, almost right side, the chemistry reactions can be seen through VR. In the above side, the bones and the veins and the nerves, everything is trying to see through AR, VR. So student can feel. So using some apps, using some technology, we can develop a lot of AR, VR. Time to time, our IT ministry as well as through NALID as well as STPI, a lot of schemes are rolled out for the Northeastern. Now also there are a lot of calls for the startup programs in this one. So we engage one institution. For one institution, we develop a lot of AR, VR. There are a lot of emotional remote sensing and customer satisfaction level type of testing can also be done by using the AR, VR plus the AI technology. Please go to the next. Next is about one of the applications that I was involved from 2014, like KHUMANG group has explained about. I was working as an NRI for 15 years. By the time I come back, we were associating with IIT Bombay, and we have translated a lot of videos of computer as well as electronics and related things in Manipuri medium. If you go to this spokentutorial.org, you will come to know that a lot of Manipuri videos are there. 300 Manipuri videos are there. This has been converted, but when we have converted, we never think that this type of videos can be, this type of video can be affected by the COVID type of situation. So we used to go to every institution and we try to give the demo of this one. Now we cannot go. So there is a business that this type of already available videos can be re-edited by understanding the level of the user. I can see there is a small boy that I have given. Some of the videos are not suitable for some of the network. That can be met. And then, you know, from where, for example, 1 hour video. So video can have searching options. For example, 1 hour video, the boys want to see only some formula where the teacher has explained for 5 minutes. So we want to run only those portions the student want. So we don't need to go for downloading for entire 1 GB video. So those type of editing thing, those type of app application thing I mean here. And there are many applications, there are a lot of facilities are there. One about the progress of the student, the progress of the schools. So that I'm talking about number B, the dashboard preparation. So how many students has been registered, how many students has been given placement, how many experience has been given in some of the institutions. Those people who are going to involve in such type of app application, converting in the paper suitable form based on the gazette that used by the minors, this is also a business. Please go to the next. Now, real problem comes here, the examination system. Normally it happened, even the syllabus is not finished. I'm also a professor, I know. We conclude that the syllabus is almost finished. But when there is no syllabus, either the syllabus finished or not, the examination has to be taken place. So now because of the COVID or because of the distance matter now, the physical exam, there are a lot of problems are there for the exam, even for the service commission exams are also there. So a lot of problems are there. So new concepts of examinations are coming. One new concept that we have already been used is a proctor. So proctor is nothing an officer. It is going to be check whether the candidate has been giving properly or is that the correct candidate. I'm talking about online. So we are using a lot of webcam, CCTV camera, remote devices in order to maintain that that candidate is the genuine candidate. For example, some school from Imphal, they have some college from Imphal want to conduct the examination. They may have a lot of online facilities here and there. So by using this proctor examination. So for the proctor, there are applications are there. There are open source applications are there that has to be tweeted, that has to be. So this is a business idea also. Some example of the proctor is given. The same thing for giving classes also, you can see the upside, the first picture. The gesture of the picture is going to be represented by the robot, and the teacher's face is there. So this will take the students more seriously. Instead of only, you know, my voice is coming, my sound is coming, if I can move, how I move over here, it is also representing in a classroom or in some other format. Because nowadays, Alexa and other type of robots, all these learning things are coming, it's not that much expensive. Anybody can do. Correct. So next. So next to the proctor exam, there is an online open examination system is going on. Here also the similar type of thing, proctor facilities there. You can see the first picture. And second one I'm coming to, because of the time I have to quote sir. Second, the last one is about the job recruitment and skill assessment. In this skill assessment also, we know our students, a lot of the students are having problem for verification of their candidature, the documents and other things. So a lot of proctor type of things are used for the online recruitment, skill assessment, also verification of their physical documents. Next. So that is about the examination. There are a lot of facilities are there where a researcher has to see, the startup has to see during the time of delivery as well as the examination. The next one is about the agriculture. So the agriculture, we can see that a lot of activities can be done as a research. One thing that we can have is one entire farmer-centric agriculture system. So farmer-centric agriculture system may have such as like soil health data, which is based on the location. For example, somebody from Imphal is purchasing a land at Thauba. He should know what is the fertile situation of that land. Another one is the total of the crops, how many crops and the fertilizer. Based on the fertilizer and the crop, so on, the cloud, solar, cloud comes solar-based pumping system, drone-based pest control system, setting system with expert by the farmer. So some of these model is there. Very surely I will explain each of these one in 2 minutes. Next. The first one is a private map soil health card. Many times we are depending on the government. I'm also a government officer, still I am saying, it is not worth to depend everything on the government. For example, I want to do something, I want to cultivate something. If we wait for, you know, soil testing card, the soil condition of a farm, then, you know, my retirement time will come, nothing will be happen. That's why I'm suggesting that some private soil health card means private map soil data can be based by some group of researchers. And these type of things are proposed, or these type of things are exhibiting at Indira Gandhi Tribal University at Makhan, at MP, not here. And you can see the first photo. This is a digital soil testing card. In this digital soil testing card, what we can do is we can make some sampling. For example, 1 kilometer from here, another kilometer, so on. Each kilometer you can collect the sample soil and you can record in the website. You can see the right side, that's the infrastructure. Looking is very easy, but doing is not that much easy. Then the authority can check the need of the farmer, and also you can see the sample down, how many crops are applying here and there like that. So the advantage of such type of system will be a public, just like a railway network or BSNL or something like that. Every farmer is going to know where they are there. They have to have a search the longitude and the latitude of their place where they are right now, and they will simply Google in this portal, and they will come to know the content of the soil condition of the farms. Based on this soil content of their farm, they will not miss out. Definitely, they will grow the appropriate farm, and time to time, every 3 months or 4 months, the flood situation of these things can be upgraded. For example, you can see the flood condition in Assam is very worse because entire northeast is in the hilly area, but it is in just like inside a bowl. So many things has been under the water very frequently. That is why when we are making such type of agriculture map, maybe a private, the farmers are going to understand, they are going to get an alert before the flood coming, maybe 1 day, 2 days before, maybe next field is attacked by the these insects, then he will come to know, okay, my is the next target, the insect is going in this way. So a lot of researchers, a lot of startups are required in order to request the farmer. So what farmer will do, they may register by paying maybe 50 rupees or maybe 100 rupees. Even though every farmer in Manipur or entire Northeast or entire India give 100 rupees also, that will be a recurring business and a recurring facility for all mankind. Next is about the portal that I was discussing about. There will be a portal. This portal will cover what is a market, how many crops, how many fields are there which can be planted by crops. Left side is the genetic view, and the right side is the technical view. The different things can be given, that data collections, interpretation, and an application. In this one, the local authority as well as the farmer and the developers are going to do handshaking. The local authorities are going to analyze, and the local authority will come to know this much farmer has been registered in such portal, and they are planting this much. Maybe farmer options to upload the growth of their plant on weekly basis, so that a market, the e-market system can be ready for them. For example, let's say one of my family is going to get married after 1 month, then I will go to this portal and then I will engage with the farmer that after 1 month, this much fish or this much material, this much vegetable will be required from your farm, then dealing can be done online. So middleman is not required. The farmer also will be happy, the customer also, same thing, the state also. Then the requirement of the fertilizer and all these type of things can be highlighted in proper time. Next. And this is about the cloud cum solar based water pump. Many of our boys and the girls are doing this one, and other things are very synergetic, but the right side is the actual thing. There you need a mobile, and you need CSM modem and all these things. So such type of small sensing thing only for the testing type of things. So this will not cost more than, excluding mobile, this will not cost more than 15,000 rupees. So once this is tested, then by the click of one SMS or by sending one SMS or some missed call, the water condition of the farm can be known by the farmer, no need. And then the solar is automatically going to be coming from the solar. And there are a lot of subsidies given by the state as well as from the Ministry of New and Renewable Energy. As by my knowledge, if you want to go for this type of thing or the roof costing, 40% of the expenditure is given from the state electricity department or the concerned department, and 40% is coming from the new and the renewable energy. Only you have to spend 20%. Example of such thing, solar solar is going on at our one of the hospital at Kakchi, Jivan Hospital. So they are getting entire roof, and even some of our Nelly Center in Imphal also doing this one. Other things also, I can see a lot of things, and you can see in Kolkata airport, 20% of their energy is taken, the usage energy means the required energy is taken from the solar. So on, by using IoT devices, the mobile, solar, and other things, many startups, many researchers can take this one as an evergreen business for them, as well as helping the poor farmers. Next. And this is one sector in health card. Because of the time, I have cut short. In the health card, there are a lot of new opportunities are coming up by using the AI processes. Maybe the robots or the process can be for the better checking of this thing. Many gases are used. Everybody, all of us are using the gases in order to maintain, in order to check our oxygen consumption as well as the heartbeat on all type of beats. And by using this type of AI condition also, we can also connect by using some portal, the medical requirements, the imported medicines, and the link to the medical plants that we have been discussing. We have been heard from many speakers. Manipur has a lot of potential for the medical plants. Instead, it is imported through this national highway, bringing by using a lot of plane or train route and other thing. Better they plant this type of these things directly at Imphal itself or some other part of Northeast. It is you can see this one type of thing. Kadala and other organizations are already set up at Sikkim. So many things are exported from Sikkim also. This is one thing. And another one is AI-based, cloud-based healthcare monitoring system can be used. One of the university where I was working before, that's a Swinburne University. What they have developed is they have developed some a common temperature testing type of system. So they have provided this to each household. They ask the household to touch that one once in a day. So they said that I have 4 members in my house. My 4 members will be touching this thermal thing once in a day, or there is a specific timing. Then this will be converted. This will be recorded in a cloud. The state machinery will come to know in the house of Dr. Zenta, 4 people are there, their temperature is like this. Then by this one, we will come to know in what section, in what coordinate, what GPS, what coordinate system, or which portion of India or which portion of Manipur is having a high temperature. There's a projected that no high temperature may lead to the COVID or some other disease or something like that. By knowing all those activity, the authority can also take proper monitoring as well as advising the citizen using a common platform, something like radio and TV. Otherwise, there are some sections, there are some districts, there is no problem at all. So there is nothing feasible for annoying them in the public. So those type of segmenting other thing by using the AI and the cloud-based health monitoring system can be done. And also we can be started with this one with the community clubs over there. Then in this one, the KK team also can have some, thought on this one. And there are many facilities that we have, definitely we can talk on that. This next to the next. And this is one aspect that we see in the tourism, AI-based tourism. So here we are going to develop a lot of AR, VR, augmented reality, virtual reality. And we are also proposing digital tourism where the people are going to book or people are going to assess the these apps or the virtual reality slots by using their apps. From there, we will come to know the behavior. And you can see the first is about the Nupilal. And by looking this one, we will not know anything. But somebody is using virtual reality in the left side. A person is seeing that when he sees this Nupilal, maybe this may be posted in Imphal airport, maybe posted in some other places where the common publics are there, and they will see. So Nupilal happen like that. They will be attracted to go to the Nupilal unit. And same thing for Kangla, same thing for Lautak. Not need to go to Lautak. They will come to know maybe in 2-minute, 3-minute video. And those type of videos can be available in any of these sort. And we need a lot of people who can develop this type of AR, VR. And same thing for Shanghai, same thing for the Unity, same thing for other places. And right now we have a competition challenge for developing AR, VR application for Manipur through STPI. Those startups are going to be awarded with the seed money of 25 lakhs per idea. So Assam got IoT devices to develop application in IoT devices. Meghalaya got the animation, and the Manipur got AR, VR applications. So somebody is interested, either please contact me or the STPI unit of Manipur over there. So this AR, VR using digital tourism, this is also a very good business in order to develop. As we don't have much infrastructure, so by using 2-3 computers, some software, either is a licensed software or private software, our boys can do a lot of business. Next. This is one thing that many of the experts has agreed. This is about the AR in the waste management. And we have been authorized by our ministry to talk on this e-waste management system. And I'm bringing here the waste management, but we have did a lot of things on the e-waste management. There are a lot of activities, a lot of organizations are generating the waste material, the household and other things, and there is no over dumping ground. Because of that, the hell hazardous, all these materials are given. For example, you are throwing some hazardous material. The cow is eating the grass which is growing from the hazardous material. The milk of the cow is coming to your house and you are feeding to your boy, and your boy, the brain is going to be hampered. So this way there is an ecosystem. We need to control this waste management system. We try to develop some projects. We can mimic exactly like what is representing here by using the remote sensing as well as geo database system also. So geo database system mapping of this all these dustbins and where they are taking the pickup vans and the locality where it is going on, all the recording of all these things are very, very essential. Please go to the next. This is one. We plan in the dustbin some sensor that is called as a proximity sensor. This proximity sensor costs something like 100 rupees. This proximity sensor will report us, or we will ping and we will come to know what is the content level. For example, I am putting a dustbin at Kanchipur, and this dustbin is not filling for a month also. Actually, I am putting in the wrong place. The government may claim that I have posted 2 lakhs dustbin, but actually they are putting in the wrong place. But for example, in, let's say in Lamphel area, I'm putting this one, but it is filled in 5 minutes or 10 minutes. So it needs more dustbin. So how we are going to know? By incorporating this type of IoT, the Internet of Device or AI-enabled services, something like we put the proximity sensor to know. Then by pinking the proximity sensor devices, the people who are going to pick up, they will come to know. And by knowing this one, where is a van, where is this one, where is beans, what are the beans, and all these beans are going to be connected through network, then we will come to know, okay, this is the route that the pickup van has to go. Please go to the next. And this is how the pickup van is going to know. If there are some dustbin which is at Kanchipur, I have given the example in front of Manipur University. Because of the COVID, there is nothing. So what is the need of going there by wasting fuel? So instead, we will come to know from the proximity sensor, the message coming from the proximity sensor. So sensor is going to be incorporated in such a way that it will help us to know all this type of thing. And same thing, the authority who are working for town planning or other thing, they also will do a lot of clustering of the devices, optimization of the routes. It is not nice that people are going in office and the dustbin pickers are coming. It is their duty, but there should be some timing difference also. Maybe before 8 o'clock it should be finished. Maybe after the office, sometime, in the raining time, some passage of all these things are flowing here and that. It is making dirty as well as is spreading a lot of this thing also, diseases also. So the authority also will take place once the map, the location of these dustbins are digitized. The same thing, the dashboard can be given for different locality. For example, for one district, what is the knowledge of this is by the customers, and then cleanliness city. Government of India is taking a lot of actions in order to give award that the most cleanest city in India. This so type of thing. So by digitizing all this type of thing, by applying AI logic, this type of thing, all these things type of things are coming. So coming by this one, or bringing up to this level by a government sector is going to take a long time. I also working from last 4 years in NELIT. I also saying, but it is not practically happening because a lot of activities underneath things has to be happen. But a private body, a professor or a person who are interested to serve the citizen can take up this one as a challenge, and then many funding and other things can be done together and it can be performed. Next. And developing all these things, it does not fit to something called as a waterfall model or the spiral model that we were talking about software development. It has to be developed by using something called a Scrum development model. So this Scrum development model is a very vast thing. I am just bringing so that somebody wants to see this one. So I have to skip this one because it will take another half an hour. Please skip next one. And this is what AI like I say, government, India is also one of the leading in the AI and also recognized by world. And then AI for youth, from starting from class 6 onward, lot of government, it is rolling out to the government school now. We are also involved in doing all this type of activity. It is going to go to the every school, private or government, but for now it is going to this one. A lot of trainers are required, a lot of activities in order to know, in order to sense, in order to understand the psychology of the students. So a lot of many things are happening. Next. And this is where our ministry, the Ministry of Electronics and Information Technology, together with NELIT as well as the CDAC, is rolling out so many activities on 10 applications. Like I was talking about virtual reality, cloud computing, 3D printing, artificial intelligence, Internet of Things, big data analytics, robotics, cyber security, robotics. All these activities are going to be rolled out for the government staff right now, because time to time in the government people are not updating themselves. So how they are going to help the society? So this is already roll out for the government employees, those who are directly involved in the IT department. Also is going to roll out to every ministry, every section. Next. And this is one example that I am saying that we have BCA program, MSc program. The final year of our students are engaged in such type of activity. And the right side one is a very interesting thing. If somebody is interested for IoT type of thing, they're charging something like, is very nominal, 700 rupees. So for a week, you want to test what is a IoT, what is a big data, what is a cloud computing, you can test it. Correct. This is not for the advertisement. I am saying that it's available. If somebody is saying that they are offering for 40,000 rupees, 50,000 rupees AI or IoT, it is not worth. First you test it, then you will understand. Next. And this is some of the activity that we have in the left side, and the right side. You can see I was talking about the e-waste management. So far from last 3 years, NELIT is working for the e-waste, even for the Manipuri, all those pollution control department and the electricity department, all this direct target department has been trained for 3 months, 1 day or 3-day training. And by knowing all these things, the IIT Guwahati has launched their course on the MTech on the e-waste. So many activities are going on. Interested guys can contact us so that we can talk on this one, because it is believed that, you know, a mobile which is costing 1,000 rupees, at least 10,000 rupees, 1,000 rupees is made up of gold. So we need to know how to extract those gold and other things. So otherwise you will use acid, and you know the remaining of that one will be thrown to our river, which is cleaned by our chief minister at his base level. And you know there are some 2-3 these rivers in Manipur. We need to save that one, but the people are throwing. So in order to control those type of things, MTech programs are coming so that, you know, we can help the citizen in order to do this type of recycling also. Next. I think with this, I want to thank you. I just want to bring different application in different area where I can see the researchers as well as the startup can concentrate themselves by not spending much amount, much energy and other thing. And the rest of the activity, if somebody is interested in some specific thing, we have model, and we also have some understanding with different concerned ministry, and we can do that. Thank you.
Thanks, Professor Zenta. Very interesting talk in the artificial intelligence for the society benefit in the area of agriculture and the schools and dumping places, e-wastes. Very good. This interesting. So the today's attendees, I want to just 1 or 2 questions we pick up from the attendees. Please, 1 or 2 questions. I think today, I think everybody hungry. I think seems to be so.
Yes,
I think
yes, that's why I drive.
Yeah. But thanks for your very nice, very interesting how the COVID, after post-COVID, how to handle this situation. That very good, interesting actually. It is very relevant to our society, and I hope that is our particular for the Manipur can benefit from your talk, and very interesting because India in Manipur we are lacking behind, you know, how the management of the e-wastes and wastes and coming from the hospitals, how to management some it can artificial intelligence can help in many ways, right? So I think I'm proud of that you have given very interesting talk in this area. And with these talks, thanks for your giving talks. Okay. So now, with the conclusion of this today talks, I think this is 5 audit. Dr. Neeraj, this is audit 5 in talk.
Yeah. This concludes the first technical session number 1.
Can I conclude?
Yeah, you can conclude now.
So the first talk was Professor Kasuko Arigar, and he giving the very interesting set in how the supermolecular chemistry how works, and very I think hopefully in the near future his work will be using for the many ways, and many I hope that they may get Nobel Prize in the future also. Another Professor Gunados S. Okram from the AGC, the Consortium, and he's giving a nice talk about how the nanotechnology, how the revolution is similar to the Professor today talked about Rajmuhon Singh has given in similar kinds of the how this. And the Prof. Mukherjee also giving how the herbal medicine, how the useful to our society, and this is how helping to Northern state. And very thankful for his interesting talk. And as fourth talk was given by Professor Rajnish Kumar from IT Madras, and very interesting how the methane, how the hydrated, and how to recover, how to release, or how to store. And very interesting because that is now this is very important for the how the fuel in the future. And another was the last one is a Professor Vice-Chanceller Singh, and very interesting how the artificial intelligence how to utilize in the different area in the agriculture and schools and the post COVID this one, and also this e-wastes, and this is very interesting, and I hope that this will be. I think this only just closing this first section, technical session. Yeah.
Thank you, Dr. Raghumani from Baba Tombi Research Center for kindly chairing the first technical session. It was a wonderful session, and with this session, we will not take a session break, and we will just continue with the technical session number 2, which will be chaired by Dr. Brajakeshwar from IBSD, Manipur. Dr. Brajakeshwar, can you take the chair?
Yeah. Can you hear?
Yes, yes, you are audible.
Okay, thank you for inviting me to chair this session. So in this second session, we have 4 presenters. The first one is Professor L. Singh from Manipur University. Then second one is Professor Yadav from South Korea. Then next is Professor Iboyama from CFTRI Mysore. Then third is Professor Rohikanta Mittai from Cincinnati, USA. Among the 4 participants, I have 3 of them I have known personally, and they have created a niche out of in their respective fields. So the first speaker I have, I think they are online, Neeraj?
Yeah.
Them? Okay. The first speaker is Professor L. Wajid from Manipur University, and I read out his brief biodata. Professor Wajid done his BSc honors in chemistry from Guwahati University, MSc in organic chemistry from Nehu, Shillong, and then PhD from the same university. He also got a Humboldt Fellowship for 2 years in 1989, then Commonwealth Fellowship for 1 year in 1997-98. He has produced more than 17 research scholars and published more than 90 research papers. He has done a lot of research activities under different departments like CSIR, DST, ICMR, etc. He has done a lot of collaborative works with ICB Kolkata, CDRI, Lucknow, IIT Kanpur, etc. And he has also presented a lot of papers in various national and international conferences and seminars. Now, I would like to invite Professor Wajid Singh for his lecture, please. Professor. At the same time, I also would like to remind everyone that I am his 3rd PhD student. It's more than 17 years since I have completed my PhD. Professor Wajid, please.
Professor Warjit, please unmute the sound.
Can you hear now?
Yes, we can hear you.
So, shall I start now?
Yes. Can you go for full screen?
Screen ID I have given to you.
Yeah, F5 you can do.
Slideshow, huh?
Yeah, slideshow.
From beginning, huh?
Yes, yes, it's fine.
Can you see now? Okay.
Yes, yes, sir.
Okay, thank you, Dr. Kishore, for giving my brief introduction for this lecture. Actually, I'm so thankful to Dr. Maitram, Dr. Jaideva, and Dr. Swapana, all are my students. So I'm also thanks for inviting me for giving this lecture, KHUMANG 2020, okay. Actually, I'm giving a lecture on natural antioxidants, how you isolated from some medicinal plants and how they are characterized, these things. Before coming to this natural antioxidant characterizations, I will give you some highlights about the introductions, what is the natural antioxidants, what are the, how they inform like this, okay. So in the next slide, I'm giving just introductions. So we have in the last several years, we have not free radical chemistries giving harmful to our life, in our cell life, okay. We know that oxygen molecule, which are essential for human beings, sometimes for many forms of life. It is also responsible for the deterioration of organic molecules when exposed to air. That means what I want to say is that oxygen molecule is essential for life, but it can produce harmful effects to us also. So what is oxidation in daily life? Oxidation means generally, you can say decay in the layman, or in the terms of chemistry, okay. So in the layman, oxidation is a decay. We know in our environment, so many decaying takes place, like rusting of iron, metal, and rotting of meat. These are all happenings in the due to the presence of oxidations. So even in our human bodies also, just like rusting or rotting, we are also responsible for premature aging, wrinkling of skin, like this. So many cancers may be developed, so many diseases may be developed due to the oxidation of this reaction type, okay. So this oxidation takes place due to the overexposition of the free radicals to our bodies. So the presence of these free radicals, we need some antioxidant property supplements to face these free radicals. So oxidation in our daily life creates the needs of a powerful antioxidant. So I'm talking about these antioxidants in this field, okay. So in the presence of this oxidation or antioxidant, presence of this oxidation states, we have imbalance between the oxidation and antioxidants. So where antioxidants are more favorable for oxidation. So related to damage, if oxidation is more favorable, then we have oxidative stress, okay. So oxidative stress is characterized by the presence of unusually high concentration of toxic species like ROS, RNS, like this. So they are all depending on this presence of this antioxidant, means oxidative reactant or free radicals like that. So how it depends? So mostly we know that oxygen is a stable state in the ground state, and the excited you can have two types of excited states. First is excited single oxygen, another one is second excited single oxygen. But second one is, first excited one is more using is a more the one which is using this for deteriorating the oxidation takes place. So second oxidation exciting state is a bit, it has a bit short life, and it comes to the this thing. Second one, first one, first excited single oxygen. So we call this molecular singular oxygen. So this is the second one. Fast excited singular oxygen is more important, and it is the one which is the culprit for making the oxidation of our bodies also like this. So I'm doing here again, so repeating. So electronic excitation of molecular systems involving inversion takes place. Two types of excited states, and second excited state is singular state is still short-lived, so it goes to fast excited state. So fast excited state is the singular molecular oxygen that is involved in certain photooxidative, photodynamic, and biological processes. So SMO, I'm talking about SMO. SMO reacts with free radicals. So there's so many reactions with many free radicals can give damage and lives. So it can react with biological molecules. So many molecules that to find methionine, so like this. Many they can react with this SMO to give several diseases like this. So these are all. So even with the nucleic acids, also react with SMO, and so this SMO can be cleansed by using the natural antioxidants, and one of them is the carotenoids. Okay. So formation of free radicals, I have already talked this about the reactive oxygen species, ROS. So when does SMO react with these free radicals, so oxidative damage takes place in plants. So I'm talking about mostly in plants, not in the marine world. Okay. So this type of reaction may occur directly or may be promoted by enzyme catalysts normally present in the plant cell, such as enzyme epoxygenase. So this permit, so it is a free radical reactions. We have free radical mechanism. We have initiation of termination like this. So many free takes place a reaction with the SMO react with free radicals, undergo free radical mechanisms. So free radicals are here. Free radicals are also not all are harmful. Okay, some are very good to health also. Without the free radicals, we cannot survive also. But excess of however, the presence of this excess of this free radical increases in abnormal level, then our danger begins. So with the presence of free radicals in excess will give the danger begins. So in our normal body functions, free radicals are byproducts of specific oxidation reactions. So excess of this highly active species can initiate chain reaction, like initiation, propagation, and termination like this. So if not controlled, if these are not controlled, then many diseases can be produced. So experimental evidence suggests that free radicals and ROS have been implicated in more than 100 diseases, including malaria, AIDS, diabetes, cancer, etc. So that's why to check the oxidation of our bodies, to give many dangerous diseases, so we can antioxidants. So antioxidant can protect human body from free radicals and ROS effects. So we need antioxidants. So let's see what are antioxidants, how it comes from. So I'm giving about the introduction about antioxidants, how they start like this. So these are the major molecules, ROS reactive oxygen species like superoxide, hydrogen peroxide, hydrogen radical, nitric oxide. These are all the radicals which react with oxygens. They produce more harmful to our effect to the proteins, to our bodies like this. So I'm giving briefly okay. Then, so the antioxidants scavenge our free radicals and consequently a very suitable nutritional and supplements. Antioxidants are supplements of the body, plants available from plants. They are very special because they are very raw in protecting the body for protecting the body from the formation of very dangerous substances. So they protect for the formation of free radicals. So the term antioxidants are almost impossible to define. There are so many terms are here for definitions are here, but yeah, this is a very in simple way. Antioxidant means anti to the oxidation. Okay, so that means an agent that prevents oxidation. Antioxidant activity essential for life to counteract the strongly oxidizing environment in which we live. So we have nowadays we are also using synthetic antioxidants like DHA, direct hydroxyadisol, PHT, direct hydroxytoluene. So I'm giving structure so you can have two assembly type. So they are very harmful. They also get damage to the liver damage or carcinogenesis. Okay, so the synthetic antioxidants can have also some side effects. So that's why we need natural antioxidants now. So that's why coming to natural antioxidants. So I'm giving introduction how this natural antioxidants are much better than synthetic natural antioxidants. So many as France produce a lot of antioxidants to control oxidative stress, so like fruits, vegetables, roots, leaves, and seeds. And many phytochemicals are coming from France. They are used from antioxidants, but they have also different properties. So natural antioxidants are compounds obtained from plants. They are phytochemicals which are obtained from plants. So in humans, phytochemicals enhance the body's own healing power. So phytochemicals are necessary. Phytochemical means chemicals obtained from plants. They are all necessary for producing the antioxidant. Okay, so I'm giving here some phytochemical. So all plants produce chemical compounds, we call phytochemical, as part of the metabolic activities. So there are two types of phytochemicals: the primary metabolites, secondary metabolites. So we already know this thing. So in the case, we have two types of natural antioxidants. First one is enzymatic group, like, for example, like superoxide dismutase, SOD, and another one is in the enzymatic group, like carotenoids. They are all of them from plants. Non-enzymatic groups are obtained from plants. I'm giving some few examples of the natural antioxidants, so like ascorbic acid, vitamin C. So here also structure is there. This is also non-enzymatic and antioxidant. Okay, they are available from plants. So here I'm giving some more here. The vitamin E. So many examples are here. So here, alpha-tocopherol is more important, better than other tocopherols. So many are here. So vitamin E is also another antioxidants derived from plants. And the flavonoids are here many compounds having phenolic compounds. So like quercetin. So they have quercetin have phenolic compounds which are here. Quercetin. So they are all of flavonoids. These flavonoids are showing highly antioxidants. So they are available naturally. So in our laboratory, also in my groups, we have isolated many flavonoids and having high antioxidants. So I will highlight this thing in this today's talk. So here the time is a bit limited. I will give only 3-4 plants only. Okay. So flavonoids I will cover 2, 3, and we have phenolic acids. So these are also available from plants like sweet potatoes, obtained from quinic acids are obtained from sweet potatoes, and chlorogenic acids are obtained from other plant extract. Okay, so I'm giving some examples only. Another one is carotenoids. Carotenoids having long chains conjugated system of double bonds. So they are obtained from carrots and lycopenes, obtained from tomato, etc. These are all color compounds because they have longer chains of conjugated double bonds. So they give bright color, red, orange color like this. So they are all good antioxidants for passing the oxidation of these our bodies. So they are good as a supplement for the body. So there are the many methods for measuring the antioxidant activities of the plant from the plants. So many methods are employed. So we have, I'm giving a few ones. So we are using mostly in the DP-based method, and other also we use. So here we can use this. So next, I think I've so next, there are many methods are here. I think I have a problem here. Okay. The next slides are even from some medicine plants. So how medicine plants can be derived from Manipur, and how they are extracted, and how they are isolated, and these things, and then how they are characterized, the structure of the compounds by using the different plants. So here we use for the determination structure, you can use ultraviolet, UV, IR, NMR, mass spectra. So, but here, mostly UV are not necessary. As shape analyzer, UV are not necessary, but NMR, IR are must. So identification of some of the natural antioxidants isolated from some medicinal plants are now I'm highlighting to this talk. This is a collection of work we have done for the last 20 years in our laboratory. So I'm giving some plants here, how antioxidants are isolated and characterized. So here, most important is the isolation and characterization of bioactive compounds. This means antioxidants. So steps involved are first, we have to collect the plant materials, which I have showing the medicinal plants value. Then we have collected by then they have to be preparation for extraction. Preparation means we have to dry it, crush it to make the powder on extraction type. Then extracted. Second, next step is extraction using different solvents, because we can extract by using the hot extract or cold extract, depending on the nature of the plants, how the plants are used necessarily, whether they are used by just in the cold state or by boiling or decoction like this. So depending on the nature of the plants used, so we use different type of extraction techniques like hot extraction or cold extraction. Then we got different types of extracts like crude extracts, like say, if you extract with a petrol method, we got a petrol method extract, chloroform extract, or methanol extract, or water extract. So many extracts, crude extracts are available. These crude extracts can undergo pharmacological screening, antibiological, antibacterial, or say biological activity are tested, antioxidants are also tested. And then in these crude extracts, and again, phytochemical screening also takes place by using whether the sterols are present, terpenoids are present, like this. So we have different types of phytochemical screening takes place. So now which foods, say like solvent, say like methanol extract or chloroform extract, are must having the high biological activity or high antioxidant activity, or then we use, suppose some extract like food extract like chloroform extract has the highest activity of antioxidant, then we select that chloroform extract of the plant and we screen the chloroform extract for phytochemical, whether terpenoids are present or sterols are present like that. So we use this crude extract. So let's say chloroform extract has the highest activity of antioxidant. Then separation takes place after getting the highest activity of the crude extract. So let's say chloroform extract, and separation takes place, takes place by the column chromatography or TLC. So many techniques are there, SPLC, MS technique like this. So we did a separation takes place by column. Okay, then we got from the crude products, we got the pure compounds are obtained. Many pure compounds can be obtained. Many some might be very few milligram, or some might be good amount also. So that these pure compounds are, again, we do the pharmacological activity, let's say like in this case we have antioxidant activity of the compounds. So pure compounds, we do the antioxidant activity, and then pure compounds screen for phytochemical screening means whether steroid is present or terpenoids is present like that. And finally, identification and characterization is done through the compounds by doing many spectral performance takes place. So these are steps. So these are long steps. The most important part is the separation and fractionation of the biological extract. The column part is very important. If the column is not present, then we can increase the polarity of the column very fastly. So we have to use slow and steady methods. Otherwise, we have to repeat again columns. So it is very difficult to work this type of natural product in Manipur because of this so many disturbances. But even in COVID also 19 also very difficult. So yeah. Anyway, I will come to some other plants we have, how we have used. So here I have only talked about flavonoids. So I selected having glycosides. So here is a glycone, fat. Okay, then dealing with a carbohydrate, we call it glycosides. Okay, Similar here also another flavonoids. There is this is quercetin type linked with another glycosides. So these are, so they are all, these two are isolated. This is like quercetin types, but here no double bond here. So these are new types of compound. So we have isolated this one. So these two compounds I will highlight today. So how this is identified, how characterized these two flavonoids. These two flavonoids are so high antioxidant activity, which are isolated from plants. So here we have small extensifolia, we call POM B. So this is the roots of the plant, the leaves. This is from this plant, small extensifolia, we identify these flavonoids and having high intensity oxidant compound is isolated from this lensifolite from the plant. So here we name the lensifolite from this plant. So the flavonoid is isolated, and this one. So this one earlier one, this flavonoid is a glucoside flavonoid isolated from this plant. So how it is characterized in this, I will highlight this thing from the isolated from this plant. So here we took the IR we have taken. I am not including here IR. So you see whether the IR doesn't give any much information, but carbon peaks are here. So we took the NMR, and then from the NMR is a photo NMR first, photo NMR take place. So in here, photo NMR gives each peak of the photo NMR, say hydrogen atoms. So they have signal here. So like, suppose this is here, so 1.2, nearly 1.2. So you share one peak here, this is CH3 peak. This is from the higher field, so this is one peak. There's only one peak in the CH3 range. So this is CH3 here, 1.2. So this is CH3 from the glucose type, this is carbohydrate person, glucoside persons. And other peaks also here, so many peaks. So we have 4.27, 5.11, 4.05, 3.55, 3.33. So these points, these peaks are highlighted from here only. So and here also 6.87 hydrogen. So this is hydrogen. They are giving the aromatic regions. So they are here. So I'll give the expansion form of this one. Okay. Expanded form of this one. This is the methyl groups 1.2. It becomes double at here because of the presence of a hydrogen atom here. There's one hydrogen atom, 3.555. So this double at. So here this methyl groups have double at. So it gives around 1.2, we say. So this is history. And this 3.55, it gives around, we have 2.55. This is like this. So this is mostly a quarter type of multiple type, because here is coupling with this one as well as this hydrogen. So this is why it looks like a multiple type of pair. So that is, we can see. Another one is 5.11, which is a carbon nanomeric compound, anomeric carbon atom has a hydrogen atom here, 5.11. So this will, next slide, expand from. So like this, so many around, say 1 to 4, I'm giving this one, 1 to 4.5. So here, when you are 4.05, 3.55, 3.33, these are all giving like this, 3.65. This, so these two are giving very good. Otherwise, in quercetin, there will be double bond. So these two are giving in the NMRs, it shows that there is a new compound like this. So another expansion from 4 to 8. So here, these are aromatic regions. So here, these are aromatic compound, 5.92, 5.91. They are all shown here, 5.91, 5.92, and this 6.99, 6.99 here, 97.6. So these are all coming to singlet because of there is no coupling carbon hydrogen atom. So they are singlet, 6.97 is double at like this. There are multiple form types. We have coupling this thing, okay. So like this, we have isolated this NMR source, photo NMR source, the protons, how they have presence of hydrogen atom. So each peak of the hydrogen atom gives each peak, okay. So this photo NMR gives the hydrogen atoms are characterized by this photo NMR. So you know we have carbon NMR, 13C NMR. So the number of hydrogen carbon atoms presence. So here all the carbon peaks, carbon atoms, so the peaks. So here all there are so many peaks are here. So each peak corresponds to one carbon atom. So here 17.9 So here one carbon atom here, this CH3. So this is CH3 are in the upfield and they are downfield. The downfield is, so one here, 195.9. This is a carbon, one carbon peak, okay, CO peak. So we know this thing by experiment or experience, but where this low field carbon will come, high field CH3 will come like this. Then CH will come here, then CH2 will come here, CH will come like this. These aromatic regions. So all these peaks are shown here. Okay, I'm giving shown all the peaks. So yes, expanded formulas I'm giving here, 7260. So here also gives. So suppose 70.17 here, this peak here, and 70.5 like this. Okay, they are all covered regions here, and this is our aromatic regions 116. So 116. So like this, and 147, 147 is like this here, peak here. This peak corresponds to carbon atom. So here carbon atom corresponds to all peaks are showing by this carbon atoms. Okay. So here I'm giving all those peaks, delta values of these carbon atoms. So these are all the expanded form of the carbon NMR of the lentifolite. It's isolated from this flavonoids having high antioxidants, isolated from formalin B. So it is used for many, as a drug also by many people, might be used for kidney problems, noon tower like this. Okay, so these are might be due to this compound. So we can do many, we can promote it as a drug, then we can have commercialize also like this. So the another one, COSY, proton-proton interaction takes place. So this is another technique. So we are showing proton-proton NMR, COSY could be this proton. And so another we have SMQC like proton and carbon like that. So by this also how correlation takes place between hydrogen atom or another hydrogen atom like this. So this way. And this is the mass spectrum of the lentifolonide. So here this peak of the position takes place. And now 450. So here 451 is mass M+1. So this is AB positive fast atomic bombardment mass spectrum. So the positive means +1, negative means -1. So here molecular mass means molecular ion peak is 450. So M+1, 451. And this one due to the presence of sodium, I like this. So other places are due to this, but it's like this metal ion or matrax like this. So from this study of this compound confirmed by mass spectrum, so we like this. So another one, so I'm saying this is compared with the antioxidant activity of compound. So this compound gives highest one is Darjeeling tea, Assam tea, and other liquid output products are here. So if you show that compound, so highest peak like this, so antioxidant. So another one is another plant, we have this one. These are we call langtride. So you also isolated another flavonoid glycosides from langtride. Langtride, now it is very, earlier it was during our childhood, it was available very plenty, but now it is very difficult to find. And so it is almost extinct. So from this compound, from the leaves of the plants, so we got isolate another flavonoids, glycosides. So this is, I want to get the characterize how it is characterized also. I want to show this also. So here also proton NMR gives expanded from this one. So each of the peaks like earlier one. So here these two are aromatic regions, 7.5, 7.53, 7.55 like this, and this is one proton here, one CH3 methyl here, so it gives around 1 point like that here. So like this, so this CH2 here, another 2.5. So many, only one CH2 here, other are CH and CH3. So like this, so you can have the expanded form, and also the second CNM also like earlier one. This gives all the corresponding carbon peaks here. Say here carbon here 18.6, CH3 18.6 here, and then other peaks are also available here. So I'm giving here all the corresponding peaks. Here 178.12 is due to the presence of this carbon. Okay, here. So this correspond to, and other ones CH2 76.8 here. So CH2 peaks are here. So we can like this we can characterize each carbon atom will give the peak in the carbon NMR, and hydrogen also in the proton NMR will give protons, hydrogen atoms, and carbon NMR will give signals of carbon like this. So this way I have access. Another technique here, similarly, we have depth techniques. Here depth means we use this this up one is negative, we get down one, or positive initial like that. So here in the positive side, up one are giving the CH3 and CH peaks, and down one is CH2 peaks. So by using the depth 135, we can say that the only one CH2 here. There's only one CH2, 67.8. So like this, we can say that 67.8 is due to the presence of only one CH2 here. And this is 18.56 or 18.6. So this is due to the presence of CH3. This is a high field. So this is 18.6. Like this, and others are CH peaks. These are CH peaks, CH2 peaks, and CH2 peaks. So like using good techniques, we can see this one. Okay. 90 shows the only CH peaks are shown by depth 90. These are also like this. Okay. So these are all CH peaks, no CH3, no CH2. Okay. So by using these techniques, by using these NMR techniques, we can have now the carbon atoms, but then in the flavonoids, these compounds. So this way characterized from this one. So these compounds are having so high antioxidant activity. Okay. So now another ones. Okay, I'm giving you some flavonoids in the two flavonoids are isolated. So I'm giving here two for this talk. And similarly, we have isolated some terpenoids from the different plants, which show high antioxidants. These terpenoids also show high antioxidant, high antimicrobial, and sometimes cytotoxicity or anti-cancer activity are shown. And these two compounds, here is isolated, here is the new compound, and these are the down, but how we isolated from this one. So this one I'm giving some from Zingiberacea family, characterization of terpenoids isolated from fermentation plants of Zingiberacea family, like say Acacia, Acacia. So like this here, you call Manipur, you call Jaimu. So here we isolated a compound showing high antioxidant activity. So here I show how it is characterized like this also. So here isolation of this antioxidant compound takes place. So here procedure of the isolation, so Acacia, first rhizome compounds are extracted using various solvents such as petrol ether, prof, methane, water like this. DLC was done, and first petroleum extract shows 30 major compounds, and TLC proform shows 25, methane shows 20, and major 15 from water extract like this. So each extract is done by biological activity, which one is highest one. So we found that highest activity is compared to proform extract. So proform extract shows highest activity. Okay. So here proform extract shows highest activity, so the presence of the amount. But then we go the proform extract was done the phytochemical screening, then we saw that the presence are present. So finally, we choose that proform extract is a good, showing the highest activity of antioxidant activity as well as the bioactive activity. So we choose this proform extract for further reactions. So we did a column chromatography, isolation of the compounds takes place, separation of the compounds takes place. Okay. So we did some volatile compounds are also extracted by GCMS, and then we found compounds are there, which are showing by non-compounds only by essential oils. Okay. So here we have isolated many compounds, nearly 11 compounds isolated. So I will give only one compound showing the highest antioxidant activity. I will give the second. So here IR shows the presence of this carbonyl peak here. So here is carbonyl. So here and the others are CH carbonyl peak like this. So IR gives the functional compound, and NMR shows like this. All peaks CH3, or CH3. So R3 are here. So 3 peaks are here, so like this. So I'll give the expanded form. And the 13 CNMR, these peaks are here because my time is limited, so I'm just giving, okay. So here, peaks are here, 135, and this is 1.2, 1.2 here, and 1.61. This is 1.3, 1.25 here, 1.3, and another one is 2.12, this one 2.1, 1.6 here, 1.61, another one is 3, 1, 2, 3. This is around 2.8. So we have 3 pixels here, then another pixel K. So this pixel already identified. Now this is certain chain number, we have 3 peaks, 15.14, this is 15.14, and 10.29, 10.29, and another one is 15.742, like these 3 peaks are here. So like, so these are the 1.192 is the to the presence of this carbon peak. So each carbon atoms shows peaks here. So number of carbon atoms corresponds to the number of carbon presence in the compound. Okay, each peak corresponds to 1 carbon atom. So in this way, we identify the compounds by using the proton NMR and carbon NMR. So these are isolated from Percomatesia. So these are 2D NMR, the correlation between proton-proton correlation takes place. So using this technique also used. So this is mass spectrometer. So here shows the M+1 molecular mass, molecular ion peak is M+1. This is a positive, okay. Then like all the peaks are corresponding like this. Then another one, so YANGO, we have isolated this YANGO. Many compounds isolated the Zingibecia family, Percomatesia. So this is I'll show this one. Also another characterized, we have the earlier one essential oils are isolated, many from this by distinct distillation. So now we have isolated 12 compounds. So this is only one very active, this compound, so high activity. So I will give the structural utilization. So here also similarly we have proton NMR, so the number of hydrogen atoms up to 1.27 methyl groups, 2, 3, 4, so many are here. Okay, so many peaks are here, 1, 2, 3, so are giving here. So like this, we isolated and multiplied, how is giving like this, so I'll give it here. This another one is 13 NMR, the proton like this, 7.7, 20 like this. So all are high peak because of the conjugated with double bond, 7.7 like this. So this carbon atom corresponds to signal of this double NMR. Okay. So like this, we have characterized the presence of these terpenoids in the Percomatesia. So like this highest activity source, this shows the highest activity. Others also shows, but this one shows highest activity, antioxidant activity. This is why we got another one. Say Hibamana, we use it for this anti-diabetic compound. So another we have isolated a new compound from this plant, from the list of the plant. This is one. Other compounds are having no double bond here, but we have isolated double bond. Style groups are here. So this is unknown compound isolated like this. So here I'm skipping this thing. Okay. So here the IR, and so this is a bit higher than the carbon peak. This is the presence of ester groups like this, and the proton NMR. So many peaks are here. So by expansion of this one, you can see the by using the technique, expansion technique, then we can see the proton NMR of these compounds. Okay. So these are 13 NMR. So many peaks we can expand this. I'm not including here because of the long lengthy talk. So we have depth technique 135, 90, 45 like this. So from this also we have as now the presence of this, how many methyl groups are here, how many methyl groups are here, how many methyl groups are here, how many are methane are here. So like this you can see. And that Koji also we have, I'm only out of this one. So this is a mass spectrum of the. So we know isolated epomifera, so we got a pomiferate because of this stir, and these are unknown compounds, so like this. So this is the way many compounds isolated in our laboratory and having high antioxidant, high antimicrobial activity, and many people are using. So this is about today's talk. I'm giving you so the groups, in our groups. So our groups working together for the last 20 years. My research scholars have produced 17 and more are around 7 are working, and they are my research scholars and Swapana here, her daughter here, here. So we're having my birthday party to combine together. Every year we used to get together during my party, but this year I don't know, we should have. Okay. We are all having the last one in the University Guest House. We have another gathering. Okay, thank you very much. Okay, thank you.
Thank you, sir, for your nice lecture. We have very much learned from lecture. At the same time, I'm also very much happy that you have shown a lot of nice and clean spectra from the natural product, because isolation of natural products in pure form is a very, very difficult one. So now is the time for question and answer session. If any of the audience have any questions.
No, please.
Hello. If any audience have any questions. Okay, since the audience is not having any questions in their mind, or if they have in their mind, they can send to the concerned conveners and co-conveners or to the Professor Warjit in the future, so that they can get whatever they want. So I would like to thank Professor Warjit.
They can ask, they can consult me in the department or something.
Yeah, sure. Thank you, sir. So I would like to thank Professor Warjit for his nice lecture from the Manipur Technical University and the KKT side. And we have our next presenter, Professor Hemraj M. Yadav. I think he's here, right?
Yeah, he's here.
Okay. So Professor Hemraj M. Yadav is presently affiliated to Donggu University, Seoul as an associate professor since 2017. He received his master's degree in applied chemistry from Shivaji University, Kolhapur, India in 2009, and PhD in chemistry in 2014 from D.Y. Patel University, Kolhapur, India. He was a postdoctoral research fellow at University of Seoul in South Korea. He has industrial working experience as an R&D chemist at Clean Science and Technology Private Limited, Pune. As an co-author and author, he has contributed more than 65 international journal publications and 3 book chapters. He has presented more than 32 national and international research papers in conference. He served as guest editor for a special issue in Catalysts and Polymers. He is a member of Asian Research Network Korea. Korean research interests include heterogeneous photocatalysis, nanomaterials, solar and environmental chemistry, etc. Professor Hemraj, please.
Thank you for your introduction. Let me share my slides.
Yeah, okay.
Yeah, thank you.
Yeah, fine.
Am I audible?
Yes.
Yeah, okay, thank you. So today I would like to talk about nanomaterials for environment, energy, and biomedical applications. And my talk will be divided into 2 parts. First part is basics of nanomaterials. I will give some glimpse of basic characteristics of nanomaterials and research work which I did based on synthesis of various materials for photocatalysis purpose, antibacterial purpose, drug delivery application, as well as energy storage applications, I think in the form of supercapacitor. So, so everybody knows what is nano, and nano is Greek word, which means dropped or very, very small. It is not like nano carb. We know that Professor Ariga already told about nano cars race in the morning session. So we are talking about this nano materials. So everybody knows what is nano. So nanomaterials or materials are having average grain size less than 100 nanometer, or materials with dimension which is less than 100 nanometer in the range or less, we call it as nanomaterial. And these materials are emerging materials, as we know that now we are facing corona a pandemic issue, and we know that the size of coronavirus is around 70 to 80 nanometer in the range. So based upon this size length scale, we can classify different materials broadly in chemistry. And we know that atomic scale, nanoscale, and molecular scale, we can classify these materials. And we know that Professor Penman, in his talk, he coined this concept of there are plenty of rooms at the bottom in 1959. After that, 1974, the term nanotechnology was coined by Professor Norio Taniguchi. And later on, we know that in 2001, our Government of India initiated Nano Mission. And we know that Professor Penman, he talked about there are plenty of rooms at the bottom, and the principle to make nanoscale machines that arrange the atoms in way which we want, and we can do it by chemical synthesis or mechanical manipulation methods. So we know that nanoscience is the study of phenomena on manipulation of materials at nanoscale, and where we know that the properties of nanomaterials and bulk materials are different. And by using this nanotechnology, we can design and characterize several materials, and with controlling their size, shape, and properties. So there are two broad approaches to design or to prepare these nanomaterials, that is top-down approach and bottom-up approach. So basically, when we start cut away material to make it small, or we can build up material atom by atom or molecule by molecule by using chemical physical methods. So these broadly two classes of synthesis of nanomaterials. And we know that based upon nanoscale cluster size of material, we can classify it in different classes, that is clusters, solid state cluster, microcrystals, or bulk particles. So we know that there are different materials that various properties of these materials are different from bulk materials. So if bulk material is opaque, and if we make it nanoscale material, it becomes transparent. So optical properties, structural properties, electrical properties, magnetic properties, and catalytic properties, these properties are changing drastically. If material is inert, it becomes catalyst at nanoscale. If it is soft, it becomes hard. And if it is plastic, it becomes elastic. So depending on size of that material, these properties are changing. So we know that, and based upon these properties, surface area to volume ratio is also important. And when we go down to nano level, this surface area to volume ratio is also increasing. And these are the key factors to understanding the nano properties, that is surface area to volume ratio, quantum mechanical model, quantum confinement, and surface plasmon resonance effect. So we know that if we take example, that is here we can see that here is one cube, and if you divide this cube 8 times, which is having total surface atoms around 1352. If you divide 3 times, we can see number of surface atom is going to more than double. And again, if you divide 8 times, the number of surface atoms is more than triple. So if you make nanomaterial, its surface area is going to increase. And this is only valid for the size between 1 to 100 nanometer. And we know that this particle size and atom in bulk on surface, here you can see that if particle size is increasing, that the number of atoms on this surface, they are actually surface items are decreasing, but while in case of bulk material, it is increasing inversely proportional. So if you take simple 1 by 1 cube, and if we cut into 42 times, so we can make it nano level, and we can spread that cubes on a football ground. So we can imagine how much large surface area we can cover with this small cube. So this is just a nanoscale high ratio of surface area to volume example. And there are some quantum mechanical models which are related with classical sense of color caused by particle which absorbs light, and most of the surfaces based upon surface morphology also light scattering, and which reflected by material, and depending on that we can get different colors based upon the properties of surface. So so this is not a new science. Everybody knows that already. Previous talk, some professor talk about that. This is ancient science. We are using Ayurvedic bhasmas, and which are already nanoparticles which can heal our body. And we know that this is ancient science. So we know that gold nanoparticles, when we make gold nanoparticles, its color is different depending upon its size. When we make gold nanoparticle, it looks deep red color solution. But in bulk case, we know that color is different. So similarly, we know that some Damascus steel or sword, which is having high flexibility and very hard properties due to carbon nanotubes incorporated in that material. Similarly, there are other examples available in nature, which we know that the lotus effect. The lotus effect is super hydrophilicity, water loving, or super hydrophobic nature of materials, water hitting material. That is, this property we can use to make surfaces clean or self-cleaning surfaces. So similarly, peacock example, this is the color observed from pigment at their surface with structure. So different structures, they are reflecting different colors. So this is based due to the nanomorphology. We know gecko is an example which is having high van der Waals forces of attraction and repulsion. Based upon this, we can also develop nano tapes and adhesives. Similarly, there are other examples: water ciders, water purifiers, some magnetic bacteria, and colored fishes, sea rats, etc. So we know that today's world is facing some problems. That is, most important problem is health, energy, water, and food. So we know that the total global market of these photocatalyst or supercapacitor or medical devices is around 4.5 to 3.5 and 612 billion. It will reach by 2020, and particularly for biomaterials, it will be 150 billion by 2021. So such a huge market for this health sector and energy sector, we can see global market demand. And so in order to address this issue, we have contributed some research, and we have selected some nanomaterials. Initially, we have selected titanium dioxide as a simple nanomaterial, which is available in most of the our regular tablets. If you take any tablet, you can find titanium dioxide in that tablet. And this is used in various purposes in industry as a pigment also. And this titanium dioxide is a ubiquitous component of the universe and can be used in solar cell, photovoltaic sensor, bactericidal, electrochemical, biomedical devices, and hydrogen storage purposes also. So we know that this is a very important material and having industrial applications. But considering its importance, this is a semiconducting material with having energy band gap around 3.2 to 3 electron volt, and it has some excellent physiochemical properties, and it is environmental benign materials, so it is used in tablets and pigments, and it have high stability towards photocorrosion. Though it is an very important good materials, it has some limitations. That is, this titanium dioxide is having a UV confinement. So it is a semiconductor material with 3.2 electron hole band gap, and its energy confinement in the UV region. And when charge carriers are generated, they recombine within very few seconds. So in order to overcome these limitations, there are various strategies we have applied. We can implant metal ions in this, or we can dope metal ions in titanium dioxide, and so we can add electron donors, some addition of carbonate salts, noble metals, or we can sensitize this material with dye molecules, and we can use it in solar cell also. We can make a hybrid and composite, and we can use it in various applications. So we are going to see that applications one by one. And here is the first example of titanium dioxide for chemical transformations. We have modified TiO2 nanoparticles, and we used initially for chemical transformation reactions. Then we also used it for self-cleaning and photocatalysis purposes also. So we have modified this TiO2 with iron nanoparticles, and we doped a different percentage of mole percent of iron in TiO2, and we found that this doping can enhance its optical properties, and we found that the doping optimum quantity of transition metals into TiO2, which tune its optical property, and we can make visible light active TiO2. So we characterize that material, and we tested that material for photocatalytic degradation of rhodamine dye, which is commonly available as a pollutant in industrial effluent. And these dyes are very harmful. So we can degrade these dyes using this photocatalysis technology. And when we irradiate light along with this photocatalysis, these dyes are degrading. And we found that this metal modified TiO2, which is very good material for treating these industrial waste influents or dyes. So another example, that is we can make composites of this TiO2 with materials, carbonate materials like graphene, and we can use that materials to clean air. So we can use this photocatalytic property to degrade benzene gas, and we have synthesized composite of these TiO2 nanoparticles with graphene oxides by hydrothermal method, and we characterize that material with XRD, TM, Raman, and visibility spectra. And we came to know that when we add different concentration of graphene in this TiO2, we can see that this material is also shifting its optical absorption, and this material can be used to degrade pollutants like benzene gas. So we have developed this reactor, and in this Teflon bag we put benzene gas, and we irradiated this under regular tungsten lamp, and with presence of this modified catalyst. So we observed that within few minutes this photocatalysis is degrading benzene gas, and we monitored this reaction using GC. And you can see here in schematic here, when we irradiate light, it generates electrons and hole, and this generates superoxide species, and that species are causing reduction of these organic compounds in presence of moisture. So we can see here the different concentration of graphene in TiO2, which enhances the photocatalytic degradation of benzene gas. And we can say that this composite of TiO2 with graphene is suitable for degradation of benzene gas, which is very harmful. And another application of these TiO2 nanoparticles and other SiO2 nanoparticles we have tested for self-cleaning and photocatalytic coatings. So the main aim of this work was to develop photocatalytic self-cleaning glasses. We know that there are some airports in Japan, they have some glasses which is self-cleaning. So no manpower is required to clean that glasses. So they can automatically clean dirt from that surfaces. So in order to develop such coatings or such paints, we can use these titanium dioxide nanoparticles and we can utilize their photocatalytic property. So we can make material as a self-cleaning, and we can also develop some paints which are self-cleaning paints. Already some commercial paints are available in the market. So we have developed this coating by simple sol-gel technique, and we optimize some buffer layers and coatings of TiO2. We characterize this material with sophisticated techniques, and we found that when we irradiate UV light, we can see here contact angle measurement of this TiO2 coated material. When we irradiate UV light, it becomes hydrophilic in nature. So within few minutes, initially it is hydrophobic in nature. So if we irradiate light, that materials become hydrophilic in nature and it can clean its surface itself. So these TiO2 coatings can be used as a self-cleaning and transparent material as well as anti-reflective coatings. And so we transferred this technology to one Korean company, Auto Industry Company Limited, Korea, and we developed some technology for automobile industry. So we know that sometimes there is a fogging of problem due to headlights and glasses of automobile vehicles. So in order to develop such anti-fogging coatings, we have used this TiO2 technology and we transferred that technology to Korean company. And here you can see that initially we tested some polycarbonate substrate, because mainly headlights of a vehicle, they are made up of polycarbonate substrates. And this can be coated with this TiO2 and various some additives we have added, and we found that we can make optical transparency, we can maintain optical transparency as well as hydrophilicity, because in high humidity condition, that surface itself becomes wet and it is not fogging, so it improves visibility. So these materials we developed for auto industry, and similar coatings we can apply for helmets and glasses, so which can be helpful for anti-fogging, and there is no any watermark at low temperature, and it is having very high hydrophilicity. So there are some other challenges which we address, and these self-cleaning materials we developed for automobile industry. Then another part of the research, that is, we know that bacteria, these bacteria are, some bacteria are very harmful and which causes some diseases. So in order to develop some antibacterial materials, we use these TiO2 nanoparticles which are modified with different dopants. That is, we modified with copper, nickel and iron also, and we tested these materials for antibacterial purposes. So initially we modified this TiO2 with copper, and we found that these copper modified TiO2 nanoparticles are also shifting its optical properties, and they are they are showing visible light absorption. And so here we used these TiO2 nanoparticles for the killing of bacteria like E. coli, that is gram-negative bacteria. And you can see here these incorporation of these copper containing TiO2 nanoparticles along with bacterial solution, and if we irradiate with light, so they are killing bacteria cells, and you can see here in SEM image, that is bacteria destruction of bacteria say membranes, you can see. And so these metal modified copper doped TiO2 nanoparticles are showing visible light antibacterial activity. And if you compare the pure TiO2 without doping, it can be only active in UV light. But if you modify this TiO2 with metal dopant, it can be tuned into visible light, and it can show visible light activity towards this bacteria species. And these type of materials can be useful for making self-disinfectants coatings on various healthcare sectors such as hospitals and toilets and elevators. So we can apply these coatings to make surface free from bacteria. And we can see here the antibacterial property of these copper modified TiO2 nanoparticles. Then another dopant material, that is nickel. We also tested effect of nickel, or what is effect of nickel. And similar like copper, we found that nickel is also helpful in tuning the optical properties of TiO2 nanoparticles. And we characterize this material with several characterization technique. And we tested different bacterial species, gram positive as well as gram negative. And we found that these nickel containing TiO2 nanoparticles, which are also showing visible light photocatalytic activity. And similarly, we tested iron containing nanoparticles for antibacterial purposes also. And here you can see that we already tested iron containing nanoparticle for photocatalysis purpose, also for dye degradation. And here we tested it for antibacterial purpose. And in presence of visible light, both kind of gram positive and gram negative bacteria species can be inactivated with the help of these metal modified TiO2 nanoparticles under visible light irradiation. And here we studied some kinetic parameters, that is effect of light intensity and effect of catalyst concentration. And we optimized some parameters for catalyst dose and effect of light. At minimum light intensity, we can get maximum deactivation of bacteria using these metal modified TiO2 nanoparticles. So we have developed this nickel, copper, iron doped TiO2 nanoparticles, and these are very good photocatalytic antibacterial materials under visible light conditions. So similarly, we focused some drug delivery application of these TiO2 nanostructures with our collaborators, friends, and we used this light induced drug release property for to target some drugs in the cancer cells. So we developed here some TiO2 nanocoral like structures by simple hydrothermal method. You can see morphology of these TiO2 nanocorals, and these nanocorals, here you can see SEM and TM morphology of these nanocorals. And these nanocorals we used for cancer cells. And here you can see the MPG modified TiO2 nanocorals. We modified with doxorubicin, and we used this for drug delivery purposes in presence of light. So here, when we irradiate light on that material, it will release that drug to the particular site, and it will generate ROS species. And that ultimately also we can attach drug molecules, and that drug will release on particular site, and it will kill the cancerous cells. So for this drug delivery purpose, we tested TiO2 nanocorals as well as TiO2 nanoparticles. So different morphology we tested, and TiO2 modified with PEG. So these, and with we also studied some kinetic parameters like its concentration and effect of concentration and how it is really releasing drug. So we attached doxorubicin, and we functionalized this with MPEG, and we found that these TiO2 nanocoral structures are showing higher drug release efficiency than TiO2 nanoparticles because of their surface area and high light activity. So you can see here some DUX release experiment that we also carried out effect of pH. On different pH we tested how much drug is releasing, and depending on time, how UV light irradiation, how much drug is released. So we can see that within few minutes of irradiations, it is releasing drug to cancer cells, and we have tested dead and live cancer cells. So here we have also tested the cell viability in UV light, because UV light is harmful to biological cells, and it may damage some cells. So we have compared that one also, that is UV light activity towards cells and activity of our material towards cells, and we compared both activities, and we found that our material in presence of UV light is giving better drug release activity towards anti-cancer effect. So these are waste generations. So we have modified these TiO2 nanocoral structures, functionalized with MPG, and we use this for drug release under UV light irradiation. And these nanocoral structures can load higher amount of drug, that is chemotherapeutic cargo drugs, than compared to nanoparticles. So, and we can modulate this UV light emission according to the need, or anti-cancer effect can be controlled by using light intensity. So similarly, we have tested another nanomaterial, that is silica nanoparticle supraassemblies for targeted delivery. And here we developed some silica supraassemblies and nanoporous structure of silica. And this silica nanoporous structure is synthesized by using hydrothermal method. And these silica pores we used to similar purpose like drug delivery purposes. And here we functionalize these silica nanostructures and by conjugating anti-cancer cytochrome C enzyme and dual function anti-cancer aptamers. And we conjugated these the conjugated cargoes we have monitored using UV and fluorescence spectroscopy, and chemoresistance cancer cells we have tested for anti-cancer purposes. And this is pH responsive therapy and intracellular theranostic cargo delivery we achieved. And we found that these pH responsive silica and nanostructures can be effective for anti-chemoresistance cancer cells. So another study that is we developed some materials for biosensors, because we know that sensors are very important, and in case of detection of glucose, we need some sensors that is enzyme free. And because enzymes are very costly, and in order to make some enzyme free sensors, we have developed first time some copper nanoparticles on glass substrate. We have coated copper nanoparticle on glass substrate. Generally for sensing purposes, people are using glassy carbon electrode or conductive materials like FTO, ITO, and these are conducting materials, and then they are coating some another materials on that conducting electrode, and they are using for sensing applications. But here we are first time deposited and copper nanoparticles which are conducting on non-conducting glass substrate, and we used these nanoparticles for glucose sensing application. And here you can see the we deposited these copper nanoparticles by chemical reduction method, simple chemical reduction method. And these you can see here same image cross section, here glass substrate, and around 500 nanometer of copper nanoparticles are deposited on that glass surface, and we characterize with the SEM and EDS, EDX. And we use this glass which is coated with copper nanoparticles for glucose sensing purposes by using cyclic voltammogram. And you can see here cyclic tomograph of this copper nanoparticle deposited glass in presence of alkali solution, and its typical behavior of copper, which showing redox behavior. And this redox behavior property, we can see that if we add 1 millimole, 3 millimole, 5 mole different concentration of glucose in that solution, then CV current is increasing, and this can be useful for detection of glucose in the analyte. So also we know that these metallic copper nanoparticles are highly active catalyst material. So we also tested its catalytic reactions towards the reduction of 4-nitrophenol to 4-aminophenol, and this reaction is monitored by using UV visible spectroscopy. And you can see here in presence of borate, sodium borohydrate ions, we can generate this reaction. We can monitor this reaction, and within few minutes, less than 10 minutes, it degrading 4-nitrophenol. It's reducing 4-nitrophenol to 4-aminophenol, and you can see here peak of 4-aminophenol. And this reaction, simple reaction, can be monitored by using UV visible spectroscopy. So this is multi-purpose application of copper nanoparticle coated glass for sensor as well as catalytic reduction reaction. And these catalytic reduction reactions are useful in industrial applications in pharma also. So this simple one-pot chemical reduction method we developed for deposition of copper on glass, and here we characterize this material with various techniques, and we can see that the amperometric analysis shows sensitivity around 154 microampere per centimeter square millimole for glucose detection, and with the limit of detection of glucose is 2.4 micromole. So these are showing good acceptable limit of detection. Then another part of this talk is energy storage materials, and currently we are working on supercapacitors and electrochemical supercapacitors. So everybody knows that supercapacitors and these are similar like battery materials, and which can be classified and depending upon their charge storage mechanism, that is EDLC or pseudocapacitive materials. So carbon materials, these are pseudocapacitor materials. Some metal oxides also they are showing some redox behavior. So based upon their charge storage mechanism, these materials are classified. And we know that some these supercapacitors are having high energy density, high power density, as well as high capacitance and long life cycles. So these supercapacitor technology is useful in various automobile technology also, and there are different kind of symmetric and asymmetric supercapacitors, and these are useful in electric vehicles. So I will not go into this detail. I will go directly to research. And here we have developed some copper oxide and manganese oxide nanostructures for supercapacitor application. And you can see here the nanostructures of this copper oxide and manganese oxide. This is prepared by using simple CLR method, that is successive ionic layered absorption and reaction method. And in this we optimized the ratio of copper in manganese oxide, and we found that the 3% copper oxide content is showing better supercapacitor performance, and around 500 Faraday per gram at 5 millivolt in 3 molar KOH solution, in alkaline solution it is showing. So you can see here that these copper oxide and manganese oxide nanostructures flex like morphology, and these materials are very good showing capacitive properties. So another research, that is we have developed some nickel graphene nanoplatelets And this is a binder-free supercapacitor material. And here we adopted to take synthesis steps. That is, first we coated graphene nanoplatelets on carbon fiber, and then we electrodeposited nickel on this graphene nanoplatelet coated on carbon fiber. So we know that nickel oxide is having large surface area, high pseudocapacitive behavior, and its theoretical capacity is very high. And uh, we know that similarly graphene is also having high surface area, high electrical conductivity, and electrochemical double layer capacitance behavior, EDLC behavior of graphene is well known, and it is having also high mechanical strength. So there are various synthesis methods to make these materials or composite of these materials. So chemical precipitation, electrodeposition, sol gel, microwave, solvothermal. So we here used electrodeposition method, and we know that there are several reports available on use of this combination of graphene and metal oxides. So mostly what people do, they use some binders. So that binders are generally non-conductive, and which reduces electrical conductivity, also decreases mechanical stability, and it will ultimately result in poor catalytic activity. So in order to overcome these limitations, we here attempted alternative technique, that is a simple binder free technique to coat nickel and graphene together on carbon fiber, and with improved adhesion mechanical property, and this material can be used in electrochemical energy storage application. So this is a simple alternative technique with some advantages like simple, this is a very simple technique with low cost and short time, binder free, without any polymer or binder we can prepare these electrodes, and it is environmental benign, of course. And we know that there are several materials which are reported that nickel oxide and graphene or RGO, these are materials showing some capacitance, and generally people
Professor
use glassy
Yadav,
carbon electrode.
you have 1 minute more. 1 minute more.
Yeah, this is last. Just I am finishing.
Okay,
Only
okay.
2 slides are remaining.
Thank
Yeah. So people already used glassy carbon nickel foam, metal foils, but we are here used a carbon fiber sheet, and we deposited nickel and graphene on that. And we can see here that the carbon fiber structure, this is graphene coated carbon fiber, and nickel and graphene, nickel nanoparticle coated graphene carbon fiber. So we characterize this with different techniques. We found that the particle size is around 30 nanometer, and we can see here electrochemical properties. Of course, here you can see carbon fiber is not showing any capacitance or any redox behavior, but if we use here nickel graphene composite, which is showing high redox behavior, and this redox behavior can be applicable for capacitance storage purposes of charge. And we found that this nickel graphene composite showing higher capacitance compared to the nickel carbon fiber, and we compared its capacitance property of these both two electrodes. And this is simple technique, and we found that around 485 Faraday per gram capacitance can be achieved at 1 ampere per gram using this material, and which is higher than the nickel carbon fiber. And so now I would like to thank you all my research collaborators from various institutes, University of Oxford, Shivaji University, some chemical companies, University of Seoul, my colleagues, and some other King Faisal University. And I would like to acknowledge some institutes like Jaideva Patel University, Shivaji University, NRF South Korea, KIST South Korea, Irish Research Council Ireland, University of Limerick, University of Seoul, and Dong University for their financial support to carrying out this research work. And I would like to specially thank Dr. Ragumani sir, BRC, and organizing committee of this, and all members and participants of KHUMANG for inviting me and attending this conference. Thank you.
Thank you, Professor Hemraj, for your nice lecture. We have learned a lot of from you. Now is the time for question and answer session. I will allow only one question from the audience.
Yeah.
Any question from the audience?
Yes, there is one question I would like to ask.
Okay.
Yeah, Professor.
Yeah, Nimrod asked.
Yeah.
Audible.
So it was a nice talk. However, I have some questions, but the organizer is allowing me to ask only one question. I would like to ask about your antibacterial activity, about the functional surfaces that you have prepared. That I could see only there is no particular structural destruction because you have using light, and at a particular time your bacterial destruction is getting scattered.
Yeah.
And so the thing is that I would like to know the influence of the photon energy that you are supplying on the functional surfaces.
Actually, we are using simple visible light tube lights, that is TL5, TL6 tube lights, and you know that this is in the visible range, and based upon simple visible light, that TiO2 particle can generate ROS species, and that ROS species which are highly oxidizing in nature, and that can kill, that can attack on bacteria cell membrane, and it damage cell membrane, and some material inside that cell membrane is leakage, and that's why the destruction of bacteria is occurred.
But visible structural destruction in your electron micrographic images are very less, because all the biological membrane or surface biological membrane are intact after some time maybe.
Yeah, but you can saw my other slides, in which I show some plates in which we incubated material at different interval of time. We collected that sample and we incubated, and we found that bacteria is not still alive in that solution. So bacteria is not growing on agar plate. So this is SEM is just supporting information along with the agar plates.
If the organizer allow, I will also ask a very fast question.
Okay, one more last question.
Yeah.
Sure. In your last presentation, you were talking about the carbon fiber in energy related work. Carbon fiber, where you are decorating your carbon fiber using graphene nanoparticles, if I suppose it is correct.
Yeah, we used graphene nanoplatelets and carbon fiber, that is commercial carbon fiber available.
Okay.
We used that is as a substrate, and we coated that graphene nanoplatelet and nickel nanoparticle composite on that carbon fiber.
Okay, in order to enhance the physical capacity.
Right.
Okay, Nimrod, thank you. And we also would like to thank Professor Hemraj Yadav from the Seoul for giving a nice lecture. And in the future also, we'd like to invite you for any incoming conference, maybe after the COVID-19, maybe physically. That would be good for everyone to meet in person. Thank you again. So our next presenter is Professor Imphal Singh from CFTRI. I think he's here, right?
Yes.
Professor Imphal Singh, he joined CFTRI as a scientist in 1990, and at present he is the chief scientist and head department of traditional food and sensory science, CSIR, CFTRI Mysore. He has completed his BTech in food sciences in 1987, MSc Food Technology in 1989, PhD in Food Technology 2004. He is also recipient of many awards. Among them, he got Indo-France Fellowship Award in 1995-96 in Montefiore, France, under U Project on Mango. He has received various awards like N.N. Mohon Memorial Award, then Best Consultancy Award in 2006. Then he was also responsible for the pilot-scale food processing unit in Litan, Manipur. And he is a Academy of Science and Innovation research. He has guided many PhD students, and he also got Dr. Mahadivya Award in 2016 for contribution to the development of food processing industries in the country by All India Food Preservers Association. He has given more than 70 lectures in national and international universities, institutes, etc. Professor Boyama, please.
Good afternoon.
Good afternoon.
Am I audible?
Yes, sir.
Yeah.
So I'll just start. I'll share my slide.
Yes.
Have you seen this one?
We didn't see anything.
Okay. One minute. Just
okay.
I'll just share it.
Okay.
Share the screen. Now?
Yes, it is coming there.
Yes, sir.
Okay, so this is the title, Entrepreneurship Development in the area of food processing, particularly in Manipur. So you know that the entrepreneurship is what is the idea. First, I want to do something, so I have to get a goal. So for that, I need so many steps are there: collaboration, development, support, financing. So all the continuous change system of the idea to goal to get this is all the system which we call the entrepreneurship development.
Excuse me, Professor, can you go on full screen?
Full screen?
F5 or full screen.
This is full screen only from my side.
It is still the window we are seeing.
Window only of 1 minute.
Okay, go to show slide.
You can press F5 also.
F5. Okay?
Okay, yeah, it's coming.
Yeah, so this is the one I told you. I have an idea to get the goal. So what are the system coming, collaboration, development, support, financing, all the system is under the development of the entrepreneurs. So today's lecture, so I will dedicate it to the young Manipuri budding entrepreneurs who like to come into the food processing. The opportunity what we have in Manipur, that one I just want to convey this message. So you know the food processing, it is a, 1 minute. The food processing can be defined as transformation from the raw material to the finished product. So for what purpose? The energy, taste, appearance, safety, storability, whatever distribution. So nothing. Put the raw material left side, and right side you will get the finished product. So this is the food process. This everybody doing at home. Everybody at home, you buy the raw material and convert it to the food process product. So this is the what? This is converting to the industry scale. This is a what? So now that's why the food processing is a big business, because everybody needs the food. Whoever may be doctor, engineer, anybody in the world, they need the food. So that's why everybody needs the food. That's why from the commercial point of view, it is a big business. So business means what? Profit. So there is one more processing, more money. So this is the definition of the food processing. What is the advantage of food processing? Let us see the very simple example. You buy a one maize, so there is a 5 rupees or 10 rupees you are getting there. So you just fire it, you make it, and 20 rupees you are getting. Then finally you compound, you make it 200. The food processing is nothing, is a value addition. Value addition means more gain, more money to business. The business means what? Profit. So this is a simple definition of the food processing. You can see that when you want to start a food industry, when you want to set a when you want to do the open the kitchen, so what you require is the primary producer, is the raw materials. Whatever raw material may be plant sources, animal sources, or fish sources. So like I said, and now you require food process. Yes, you require one person, one group to process that raw material. So finally, what is the retailer? So there is a one selling of the products into the market. For that, the returns will come, and this will be distributed till the farmer stage. So this is the complete cycle of the food processing sector. If you miss one from this, you cannot run the industry. So that's why the to run the industry, to start to success one entrepreneurship in the food processing, so we should think of the three things. Primary product, raw material, whether we have enough raw material or not. Then technology, the processing, how to do that. And marketing is another. So these three things are required for the food process. So that's you. Then which one you want to select, the key segments of the food processing, whether you want milk processing, fruits and vegetables, meat processing, package, soft drink, grains, so whatever you see in the supermarket, it is a processed product. You can start there, depending upon the three sectors I told you. You have the raw material, you have a technology, you have market. If you should remember these three things, then you can select this choice, whether you in the edible oil, bakery product, confectionery, bakery products, even the mineral water. You see the blooming in every part of the country. So the mineral waters. And then another one coming is very high protein foods are coming very fast in the healthy market. Let us see food processing. When you start up food industries, you can see that these are all the stakeholders: farmers, supplier, transport, retailer, manufacturer, consumer, and waste management. These are all the stakeholders. They all be benefited when you start a food industry. It's a sustainable food processing industry. You can see that why we want the processed product. You can see here demands of the processing product in the market. The first is the increasing spend on the health food. Everybody wants the healthy food. They need that. As organic foods are coming up, very costly one. And the healthy food, protein foods, baby foods, all costly. Increasing spend on health methods. Increasing nuclear families. Earlier, joint family was. Now the small families is a major one. Demand for a functional food. They need some food which do something for the health. Whether it's a cure, it is good maintaining the diabetes, it is curing some of the diseases, or is giving more vitamins. All these functional foods are there. Organized retail and private level, lot of supermarket, lot of malls are coming up, lot of market networks are coming up. And it is easy to buy the processed products. Changing the demographic, rise in the industry, a lot of money is coming now. Husband and wife are earning money now. They have a lot of money now. So they are changing the system. To increase the urbanization, from all the village people are coming to the urban area. So they want to be in the city. So all this one, the requirement of the processed products are coming up in the market. So why I am telling this one? So those entrepreneurs who want to start the food processing, so there is a market, there is a lot of demand in this. So their dreams will be successful. So now you can see from point about the employment generation. See here, 1% growth in the food process. You can generate direct employment with 5 lakhs rupees. 5 lakhs people can be employed. And indirectly 50 lakhs. What is the indirectly? The person who's taking my product from my farm to the market by auto rickshaw. The auto rickshaw driver is my indirect. The person who's selling my product in the market is my indirect. The farmer who supplies my product, my raw material, is the indirect. So that's why when you increase in 1% growth in food processing, you will have that. Am I audible? Am I audible?
Yes, we can hear it.
Yeah, no, okay. So major players in this one is, you can see here, the lists are there, numbers, some of the I have listed here, Dabur, ITC, Nestle, Rani Wilman, Gujarat Cooperative Milk, MTR, Parle Agro, Parle Product, Cargill, Column, Mother's Dairy, all these things are playing in the Indian market. So let us come to the Manipur, whether we can do this processing in Manipur. Let us see, last thing I have to see is whether the raw materials are available or not. So whether all the raw materials can be cultivated here and grown in the area. So let us see Manipur at a glance. One is agroclimatic condition and favorable for growing of agricultural horticulture, including spices, plantation crops, then opportunity for processing of the surplus produce, and then potential for setting up the food processing unit, then scope for domestic and export market. And finally, the nutrition and economic sourcing. So you can see that Manipur is having all these opportunities to grow our this raw material. Let's just select, for example, what are the cereals growing in Manipur? One is the rice. These are rice-eater people. The paddy rice and this thing. Among the rice now is really coming up very fast in the market, in the health market, black rice. It is recently we got the black rice gets a GI tag. So then they come to the wheat. Maize is another crops available in Manipur. So these are the raw material we have grown in Manipur. So this one now we start thinking of this one, the value addition, the process. Then come to the Manipur pulses. You have the moong dal, the mothbil dal, urd dal, cowpeas, bengal gram, the masoor, then dry field peas. We can the tur dal, there's a pigeon pea, rice bean, that is a sakwai. Then the Hawaii movie, there's the broad beans. These are grown in Manipur. Next, come to the oilseeds. What we have the oilseed, you can see here, the mustard, the rapeseed, then the twining, the sunflower seed, sesame, castor. So these are the oilseed grown in the state. First, we have to categorize what are the raw material available in the spices. You can see here is that Manipur is famous for the spices, particularly ginger, turmeric, and the chili, the king chili. These are more major, and cinnamon, tejpata, and sugarcane. So these are the spices and the plantation products grown in Manipur. Then the scopes of the organic spices. So this is what we all growing in the natural. So this we call the organic spices. And organic spices markets are big in the international market. So like the spices among the, again the methi, coriander, cumin, seed, then chili, garlic, and the red chili, these are the major. And the umoro, that is the major spices grown in Manipur. Among the fruits you can see here, we have a lot of fruits. But only we have to quantify that one, how much we have grown that one. It is a feasible process. The major one is a pineapple. Then we have the wild apple, guava, banana, orange, and amla, and papaya. So these are the fruits which have grown in Indian Manipur soil. And Manipur, again, another some of the peculiar. The Manipur, the famous is for the passion fruit, the plum, the jackfruit, and pears. Pears is very important, and the lemon, kanchi lemon. Then we have the hairi. So these are all some of the wild, what we can say, the fruits available in the state. And the karambola is the star fruit, in a zone. So this is the one more. So these are major fruits which grown in the Manipur. Then vegetables, among the vegetables, most of the vegetables available in the other country also available here in the state. We have the vegetable, again specific vegetable, you can see here some of the squash, bamboo shoot, these are having, and you can see some of the karonakavi, that depend on futaro, all these things, yongsak, and carrot, this one. So these are some of these unique raw materials available in the state. So that's we have to. This another problem is most of these vegetables, fruits are perishable in nature. They spoil very fast, and they are around 30 to 40% of the produce are lost. That we call the post-harvest loss. So it has to be minimized only through the processing. So that's why you can see here in the meat processing, you can say fish is a Manipur is a fish eater. Even we eat the fish, still we call the vegetarian. So the chicken, pork, egg, these are a major this one. Now you can see after seeing all the raw materials, you can see here Manipur a great opportunity for the investor in agriculture. Come to the now, when you have the raw material, what CFTR role? CFTR, Central Food Technology and Research Institute. So let's put two slides. I will show you that. What is the CFTR is? We have a premier R&D institute in food science and technology under the CSIR, Council of Scientific Industry Research. We have 17 R&D departments, supporting department affiliated to universities, many universities. We have ISO 9000 and 14000 and enable accredited. We have doing R&D, consultancy, technology transfer, testing, analysis, and from the SRD point of view, MSc Food Technology course is there. PhD, ACSR PhD program, integrated PhD, short courses, and commerce programs are all their activities, main activities in the CFTR. And you can see here, The food processing involves all the sectors of the use. You may be chemical engineer, and you may be the microbiologist, you are biotechnologist, food microbiologist, all are under this R&D area. We can have the different sectors: translational research, the food microbiology, biochemistry, molecular nutrition, plant biotechnology, liquid science, and the technology development. We develop a technology, more than 4,400 technology we develop: grain science, fruit and vegetable, corn milling, spices, meat, marine, protein chemistry, traditional food, sensory science. Among engineers, all of the mechanical engineers are coming up, and chemical engineers, these are, and technology scale, food engineering, food package. And the quality, in the food safety point of view, the food safety and quality control, food protectants and pesticide control. So you can see here, the CF-III is a house having all type of the degree where scientific courses are inside. So the support departments we have, this human resource, planning, design, and navigation. We have developed a lot of equipments, food processing equipments, and we have a resource center in Mumbai, Hyderabad, Lucknow. And one is shortly coming in the Imphal also. So we can say the CF-III one stop for food processing, food science, and technology. What is the role of CF-III? You can see here in this consumer asking something to eat, to ask in CF-III. CF-III developed a technology. The technology developed is the transfer to entrepreneurs. The entrepreneurs will set up the industry, and they produce in the mass production and meet the requirement by the consumer. So this is the cycle of the CF-III. So asking to CF-III, develop a technology, transfer in entrepreneurs, and set up the industries, and this running. Like in this way, we have, you can select any one of them. You have a micro, cutting, medium, large scale. You want to set up this industry. You can select all the ranges of this, the food process. You can remember this Amul, the milk powder, everybody knows. So that technology is developed by CF-III and transferred to the Amul, the Gujarat, Anand. So you can see that millions of children are surviving because of the Amul powder. So that technology is developed from CF-III. So like this, we have given a lot of, you can see the more than 400 technology developed, the 4,500 licenses. And among this, let us say, opportunity in grain processing. What are the grain processing we can do is rice. What are the things rice we can make it? The most of the rice available in the world, in India, there's a parboiled rice, the technology from CF-III. The parboiled rice is not coming up in the Manipur. We can do something in the Manipur so that the food, the rice can be stored longer period without losing any nutritive value of the rice. The curing of the rice, also methods of reducing breakage of rice. The breakage of rice, how to reduce the breakage of rice. And the rice flake, vermicelli, convenient products are available in CF-III. One can think of doing this value-added product. Another specialty fruit are rice with slow carbohydrate digestion. So diabetes people say that don't eat the rice. And here we say this type of rice, whatever, raw rice with slow carbohydrate digestibility, this rice can be given to the diabetes because of the sugar level will be maintained, will not be released very fast. The quick cooking rice and ready to cook rice. So many products from the rice we can team up for the entrepreneurs in Manipur. Then next to the maize. What are the maize we can make it? Cold flake, everybody buying and as a breakfast. The cold flake is the most raw material going out from northeast. You can make the flakes, seminola flour, roti flour, gobi manchuri, you are making the gobi manchuri. The flour you are making is nothing, is a maize flour. Noodles we can make it, the extruded products are top products. So nowadays most of the products is available with the wheat product. Many people doesn't want the wheat because it's having the gluten. So gluten has a problem for the people who are gluten sensitive people. So that's why many people are asking the gluten-free products. So that the one maize is the one commodity can be replaced in the wheat product. We can support for the diabetes people. We develop the products because the low GI is having a lot of protein and can keep over 6 months. We can keep this ready to cook, and the ready to eat one also we can make it from the the grain process. The technology is already transferred to many industries. Then for the wheat product, you can see the lot of the biscuit now coming up, the whole wheat flour, cardamom flavor, onion flavor, high fiber, low sodium, therapeutic bread, sugar-free breads are coming in the market. These technologies are already ready for them, and many industries are taking up them. And bread also nowadays, ordinary breads nobody wants now. The people want high fiber bread, the ragi, bajra, sugar-free one, all this stuff. Another one I told you, the high protein biscuit. Because the Indian growing, school going Indian, they want this. The gluten-free baking products are coming in the market. You can see the gluten-free products. They are similar to the existing bakery products that can be used for the product for the specialty for gluten-free. Then food processing, the pulse processing, we have the peasant, it is a tur dal, the green dal, black gram, so Bengal gram dal is grown in Manipur. They can be processed into different form in that one. In whole pulses or split form, dehugs, flour, like a besan, like that, pulp pulses, that ground, all this thing we can make it. The product can be ready for them. Another one, you can say oil seed products. You can say whatever oil seed we grow it, we extract the oil. After that, the cakes are there. From that, this other product we can make it. The protein isolate and hydrolyze is a very, very common, very, very profitable products. They can be fortified with the biscuit, high protein biscuit, high protein bread. Like that. We can make it. So like this, we can make it from the groundnut butter. This is a very peanut butter. This is a very famous product. It can be used as a byproduct from the oilseed industries, oil industry. So now emerging the spice and plantation, we the fasting is turmeric. Yes, turmeric. Now it is in the present situation, it's the COVID-19. The turmeric demand is very high, and the people know that it's having the immunity power, this one, and it is having this antioxidant properties and all this. Turmeric powder, turmeric oil, turmeric oleoresin, the color, the curcumin. These are all these technologies are ready and available in this one. So one can think of doing this entrepreneurship in this area. So let me just see another, what we can see here. Another one we have, you have a black pepper. So black pepper, you can see the product, what we have listed here. So these are the products can be taken after. Only the question is, do you have the enough raw material for processing? It's a big cardamom, so we don't much grow in the cardamom, but very, very popular in the Sikkim and district. So there's most of the cardamom coming from the north. This ginger, we have a lot of gingers, and you can see the products are available in the market, and most of the ginger going out from Manipur and prepare somewhere and bringing back to Manipur and selling again as a processed product. So why don't you start doing the same thing in the same place? So this is the one we have unlimited numbers of products we can make. You can see the chili, we have a chili, we have a lot of chilies available, particularly in this our chili, the king chili, like Morog and this thing, and you can make this product, you can see. Capsaicin is the one, the bioactive compounds, is the most demanded in the international market. This one and sugarcane, we grow sugarcane, and now people are getting the sugarcane on the roadside and drinking on the glass and this thing, unhygienic way. So now we can think of making in the bottles, in Tetra Pak, and it can be sold. At least 3 months we can keep in the room temperature without any chemical and preservative. So that's why any time we'll get the sugarcane juice you can have. And for jaundice people, the first food is the sugarcane juice and the Bengal gram chana, so they will maintain their health condition. So this is the one value-added product from tamarind. Yes, tamarind is we are growing, but if we don't grow, we are getting a lot of things from Myanmar and this thing. If you have the raw material, why don't you make this product? You can make even the seed that you can make a powder. It can be have a lot of values in different chapati making in the Ayurvedic products and this thing. And dry powders as well, ginger powder, and even juices also you can make. In different products you can make from the tamarind. So this is the technology. We are meat eaters, so we have a lot of meat available, particularly chicken and pork is available, and mutton things. We can make different products. You can see the chicken wafer. So people are talking about the potato wafer. Why don't you make a chicken wafer and can fry and eat it? And a very good source of protein. And because the complete protein is chicken pickles, and this you can see here different products you can see. Another one is we are fish eater. The fish scales are throwing out. Why don't you make the fish skin can be converted to gelatin? The gelatin can be produced, and this gelatin is using without gelatin, no bakery product, no ice cream without gelatin. Gelatin is the main ingredient in many thickening agent in any restaurant and hotel and this. So why don't you convert this waste into wealth? It is another opportunity to start the entrepreneurship. See here, what the protein content is, how much you see here. The skin is a 19% protein is there, and we are shortage of protein. We are throwing this protein as waste. We can recover that one. So we have the emerging, another one, the big raw material, what we have thinking is the raw material, the pineapple. Yes, you can see, you have a pineapple. During the lockdown, you can see that you have heard in Manipur, a lot of pineapples are lying there without selling that one. Because that we can, why don't you that we can convert into products and keep it. You can see that. We have given the technology to Manipur, like Myra and this thing, we have given the technology from KHUMANG, and they are running a big business in the pineapple process. You can see the many products you can make from the pineapple. Then come to your amla, the high crude, then you can see the very good source of vitamin C. And now you can see the COVID time, vitamin C is the main. And sometimes you may not get the vitamin C tablet in the pharmacy. Even now you can say that if you have an amla, you can replace it. You can make products, and amla powder, amla tea, and you can make vegetable. So all this one low cost technologies is available. And in cashew nut, we don't have a cashew nut, but we can grow a cashew nut. We have a cashew nut, the cashew apple, the pulp, the red portion. This is the water after harvesting the cashew nut. These are waste, and mostly in the Goa they are using penny. It is famous for the penny drinks and this thing. So we also can make it going. Grapes we don't grow bust, but it's now growing, coming up. It's very good for the heart patient and this thing. So we can dehydrate. We are buying from the outside with rising kismis, we call that. So we have the mango. So we don't grow much mango, but some of the mango we grow is good for the pickles making. We can make the pickle chutney, and we can do that one. We have an orange, it's a very good sort of now. This Tamilong orange, all this very popular one. So when you have in the season, you will get it. After the season, you won't get it. So why don't you preserve that in the different form, and it can be exported or it can be marketed. So these are opportunity if we have the order. The pomegranate we grow, and we have guava, we growing that one. Very good source of the pectin, and good for the dietary fiber, and very good for the vitamin C. So that can be okay. And we have a lemon, so Kansi lemon and this thing, we are famous, even though we are trying for the GI tag, all these things. So they can make a different product. Now the lime juice is very popular nowadays in this COVID time. So now we have the jamun, this we grow, is widely growing in the Manipur and this thing, and it's a good source of the antioxidant, the anthocyanin percent is there. So good for the diabetes people. And if you have this one, the products are ready and can do the business and make good marketing in this system. So watermelon now growing fast in Manipur now, and people already looking for the red color, the size that what the eating that one. The other one, whatever is skin that what we have removed and throwing the white wash, we can convert into the candy and this thing we can make it. One Nagaland student came to me, KHUMANG and worked with me. We have developed this product for the watermelon rinse to the candy we are making. A very good taste and a very, very profitable business. We have a jackfruit now. We grow in Manipur the jackfruit. Now the jackfruit is demanded throughout the world, USA, the UK, Canada, all this things are demanding the jackfruit in the frozen form. And we have the jackfruit, and why don't we try that? We can make a different product from the jackfruit. Lychee, we are not growing much now. We start growing now. Most of the horticulture departments are trying to give the lychee growing in the Manipur in different varieties. Karambola, we are using for the cleaning the utensil and all these things. And this is very good source of the vitamin C and minerals and these things, so they can be converted into passion fruit is famous for in Manipur, and is a very good source of this the carotenoid, the vitamin A and this thing, and good for the diabetes people, all this. So now is a very good source. Now another one is growing. It is not growing in Meghalaya. Is growing. Is slowly coming to Manipur. There's a pokum is a one very good source of the anthocyanin, and it is anti-aging. Because of particular hydroxycitric acid is there. So that's why it is as used as the anti-aging. And some of the film actors, so they used to make injection on the face to keep their face younger. So there is the clinical done practice done. So these are products I have developed. This one we transferred this technology to 2-3 companies, and a very good source of the I told you cooling effect. This one, and recently we have made some sport drink from here, energy drink and sport drink from this cocoa beverage. The custard apple is a cancer fighting. The only problem facing is you can't heat it. You're heating the bitterness there, but without heating, we develop the products. You can see here, and we transfer this technology to this one. And we have this sitapol, we call the sitapol at home Manipur. We can do this. Papaya, we have the papaya, and every part of the papaya you can use it. Tutti fruities, papaya nectar, papaya papain, meat tenderizer. That's why in Manipur, when you cook the very is meat, you are putting the papaya, then you will get the texture, the very soft texture, because they have a papain enzyme. And very by mistake, don't eat the papaya seed, the papaya skin, so you will have a bleeding on the tongue because the papain enzyme is a very proteolytic enzyme. So that they can be converted. And in Maharashtra, only the latex, the latex that when you cut that one, the milk come out, they are collecting and selling and doing a big business on that. And in the pharmaceutical industry, selling. Tomato, you can see that without tomato ketchup, you can't get any bhaji or bora, anything, whatever it is, noodles. You have a lot of demands. Banana product, we have a lot of bananas, but we don't use this banana in different way. And we can give, simply we are selling the banana essence, and a lot of losses is there, a lot of post-harvest losses. Why don't you convert into the different product? Let's clarify juice with the banana wine, banana chips, and even the banana stem juices, you can use them. Avocado is coming up very fast in Manipur, and a very good source of the particular one fatty acid present that one. So there's a fatty acid oil is very famous for that one, and that's how it's demanding for the world. Then the carbonated beverages, whatever synthetic beverage, there's no nutrients are there. There you can get around 20% juices in the carbon. And the fruit wine, any fruit you take out in Manipur, it can be converted to wine. And this will be popular. You see, France is famous for the grapes wine. And why don't we try to wine orange wine, pineapple wine, even the jackfruit wines, we can develop that one, process it, in scale up that one, and market that one. And the cut vegetables, so those people, those want to, be difficult to buy a raw material, so they don't have time for processing, cleaning all these things, and the ready mess are coming. Big basket, the technology, what they are having is from CFPR. So like the dehydrated vegetable, we have a sunshine is there, we have a dehydrator we can pick up, and solar dryer, so many things coming up that one. We can dry and keep in there. And all our forefathers doing that. In the rainy and the sunny time, they just keep in dry, and when the rainy season, they open and eat it. The same traditional way we can think of it. And this is the one raw cost solar drying system of the tomato. So I have developed this one, and this is a very good. And nowadays, any soup you can instant soup they require, whatever you require, tomato powder you require. It can be done by solar drying. And you can the osmo air dry is a very good demanded product in the one like a pineapple, like a jackfruit. It can be osmo air dry. This is the one beetroot you can see here. Very good source of the betanin is a bioactive compound. Very good for the menstruant. The women who have menstruant problem is a cup on infection. It can be cured. This is one carrot juice, a good source of the vitamin beta carotene. Everybody knows that can be used product in many combinations. We can do that and make it. The mushroom, yes, India, Manipur is producing a lot of mushroom. Now the mushroom is demanded throughout the world because it can give the vitamin D. And vitamin D is very important for the absorption of calcium. So this is a link between them. So that calcium is rich in the milk. The milk is giving to the baby for building up your tooth and teeth or the bones and this thing. But that's why we used to, we want vitamin D. In our time and other time, all time, we don't know vitamin D. But the parents know that one. They keep the baby outside in sunshine for a few minutes. So that the vitamin D is making from the ultraviolet ray and striking on the body and cholesterol converted into the vitamin D. All these things systems are already there. But nowadays people don't have time to expose their children to it. Now the best thing is to supplement the food with the mushroom. The mushroom will give you the vitamin D and whatever the stick. Then bamboo shoot, yeah, Manipur is a very good bamboo shoot, and we made a fermented bamboo shoot in the market. Now is a lot of contamination, lot of unwanted, unhygienic things are coming. So it is a risk for the health. So we can think of making the scientific or production of the So potatoes, we know the different potatoes coming in, the French potato, all these shapes are coming. Tapioca, this is the Omangra. So what we have, we can make a lot of products. So these are all the opportunities available for the people. That's why the young entrepreneurs, the budding graduated people, so they can start thinking of doing it. And for details, you can see that. Visit www.cftra.com, and you can see the technology database. You have a technology database. You have out of all technologies available in CFTRI will be available here. You can see that, and click in the east one, and you will have an idea about how much investment is required. And another one is a free technology. We have even around 15 technology we are free. So you can register your email with your email. You can download and you can start that. If you have any problem, ring to CFTRI, and we can help you for the access. So the free technologies are also available, so that one can start their own business. So entrepreneurship now all the entrepreneurship, just 2-3 slides, I'll finish. So entrepreneurship now comes. So now I have all the opportunity given. One wants to start the business. So what is entrepreneurship? One is simply that. Do you have a secret dream to start your own business? Sometimes people think, I will do my own work, my own business. You start thinking that. Now, another one, do you see a market opportunity that has been overlooked by others? Some of the market opportunity here, nobody has seen, but you have seen. Then you start that one. So that is called nothing, entrepreneurship. So an enterprise is created by entrepreneurs. Yes, enterprise. The process of creation is called. I told you, I need something. I have a goal, determination to get the goal. So I have a process. So the process of creation is called entrepreneurship. So entrepreneurship is a process or action of entrepreneur who is a person always in search of something new, exploit such ideas into gainful opportunity by accepting the risks and the uncertainty of the enterprise. These are the last two words. Is the word the entrepreneurs always have afraid of this one. Accepting the risks and uncertainty. If suppose I produce a 20,000 packet, who will buy? This is the one risk. Whether my product will be demanded or not. And uncertainty with the enterprises. All these things is the one. So we can see here some advantage of entrepreneurship. So you are the one, your boss. So you have your company, you are the boss. Enjoy the profit from your efforts. Sense of pride in your business. And flexibility in your work. You can change the work. Everybody got a Sunday. And you can give Monday also. Like you can take decision your own. So you are the one. Only the disadvantages are here. We need to put in low hours. Employee may go home, but you have to work harder. You need money to start. You have to keep up with government rules and regulations. Your FSSI, pollution control law, all these things you have to take care of that. May have to mark the hard decision. Hiring, firing, we lose the money. But this is what the entrepreneurs is between this, the success and the failures. And this is what we have. Who is entrepreneur? Yes, entrepreneur is a person who organizes and manages a business undertaking, take the risk for the profit. You can see the diagram on the right side. All these are graduated people. Graduated going to the employee. They want to be the employee. They want to work with under somebody. They don't want to take the risk. Only a few people will come out as an entrepreneur. So he has to have a lot of characters. You have to have a lot of properties, you can say, to have that. So this is the what we have. Person conduct their own business is definition given by all the big entrepreneurs. And organize or economic venture, one who owns, organize, manage, assume the risks of the business. It's in this like they have given that one. The qualities of entrepreneurs, you can see read out here. Initiative, white knowledge, willingness to assume risks, open mind and optimistic outlook, adaptability, self-confidence, leadership quality is the very important one. The orientation towards hard work, simply thinking, vision or anything without doing is no meaning. You have to work hard. This is one role of entrepreneurs. I only told you here the roles we have. So that's why we have, this is the system, MSME already have given the 8 steps to become an entrepreneur. That's why one has to go through all the system, then only he will be successful entrepreneur. Project selection, which one I have to do? I have to want the bamboo pickles? Yes. Technology is available? Yes. But machinery is available? Yes. All tick mark. And the arranging finance, who is giving finance? Myself or yourself or from bank? You are going to. You need development, say you have to develop that this one. Filling the entrepreneurs memorandum, whatever entrepreneurs, you have to do all the terms and conditions, you have to give for submission to your registration. The approval has to come. Then clearance coming from the old sectors, from the lands, from the soil, from the waters, pollution, all clearance. Then you have quality certification. Yes, it is the FSSI given, it is given the ECMA, so all has to be. The 8 steps is required to enterprise. Then only that your product will be in the market. So if you don't build your dream, someone will hire you to help you. Yeah, this is what is Ambani has told her. So don't wait. Don't be going as an employer. Come into this, come this side as entrepreneur. Otherwise, your knowledge will be used by someone, and you become employee. And you decide that you want to become employee or you want to become employee. So this is the entrepreneur's development CFTRI, whatever the CFTRI have developed that one. We have an International School of Milling Technologies course, 11-month course we have. And the short-term training program, 5 days programs are running. A lot of Manipuri students, Manipuri entrepreneurs undergone training program from CFTRI. They have done a good job in the good process design. And the skill development program, we have a 5 weeks program. And the collaboration with the different states. And the internship, 2 to 6-month internship, we are conducting. The farmers program, the farmers who produce the produce. They don't know what they are making, what other people are doing from their produce. So that the farmers will be doing. And we are doing a lot of virtual classes we are doing. And the entrepreneurship, creative candidates, placement, all this we are having. So now CSR, CFTRI is a one-step center for food processing solution. Build your service forever. So this is the animation what I have given you. You are in the left side. You want to be here in the CCR. You want to cross this one. The gap is there. The whole CFTRI team will come and support you and make you forward. This is the what. So thank you very much for sincerely listening.
Thank you, sir, Professor Iboyama, for the nice talk, which is very much relevant here in this COVID-19 situation. I would personally like to request you to come back to Manipur, sir, after your retirement.
Oh, not before retirement.
Oh, then establish a company or something.
Yeah. Resource center in Manipur.
Okay.
I want to help all the entrepreneurs because the food is the only source in Manipur that we can do it. Others are all coming from outside.
Yeah. Everything is there. Everything is coming.
Every house having the food because a small garden we have. Now that system also got. So we have our own food. How to go out from here from Manipur, that we are right.
Okay, sir. Thank you. I would like to have one question from the audience. Any question from the audience, please?
I have one.
Okay.
In this processed food, the preservatives are not used or used?
The preservative, some of the we are not using. We have a technology, we have a difference without preservative, with preservative. But the classification of the food preservation is one is a preservation by chemical, one is a preservation by heat, preservation by fermentation, like different products are there. So wherever the preservation by chemical is also regulated by the FSSI. And they have already done the toxicology analysis, everything. So they already found out that this dosage is the limit of the dosage for that human body can tolerate that. If the person putting more than that one is a risk.
Yeah. So
some of the chemicals are still analyzing ban it. For example, somebody already told about the antioxidant, BIC and BIST. So BIC is going on, BIST is banned.
Yeah.
So like that, this is going on, and whatever the dosage given, we have categorized by the government, and this is safe for the consumption.
But whatsoever preservative it is used, it is injurious to health, in general.
No, but if you taking the more than what the limit is there, you are injurious. Otherwise, some of the as a natural preservative. The citric acid is a natural preservative. We can't call it is a chemical preservative. We have two types of preservative: class 1 preservative, class 2 preservative. In the class 1 preservative, your sugar, vinegar, and then salt and the spices. These are all preservative. So they are classified class 1. We don't need to classify dangerous for the health. The class 2 is the only one, it is limited. And in Manipur, so many people, they don't bother about that. What they're putting more and more and is a health risk. Now FSSI initially come into the system. So now they start making, taking the sample and analyzing and find out the file. So these things are some of the food without chemical we cannot preserve.
Yeah. Okay. Thank you.
Thank you, sir. Is there any other question the audience want to ask to Professor?
Yeah, I want to ask one question here.
Okay,
thank you.
Only one question, please. Thank you.
Yes. Thank you, Tamo Ibayama, for very nice talk.
Okay.
I have one question. Like you have discussed lots of opportunities about the, for the different possibilities of starting this various food processing industry there. But what are the challenges that one should, face while they are going to start up this, thing? What are the challenges? Though you have mentioned lots of opportunities, but what are the challenges that one will be facing it when you want to start up?
Yes. One is the challenge is your raw material. Whether you have the what is that? King chili. Morocco is a very famous. Is telling. Okay, now can you give 2 tons of Morocco? Nobody will give it.
Right.
We don't have.
I want 2 trucks of sahau. I want to get every day. And you give, nobody give. People are talking, but only when the processable challenge coming raw material.
Okay, raw material is the main concern.
Raw material challenge. Another one is your electricity, the power.
Yeah, thank you.
Okay.
And water.
Okay.
If you have these 3, you can do everything.
Thank you, Tamo.
Okay.
Okay, thank you, Tamo, for the nice lecture. We have another lecture from Professor Ruhikanta Mitei. Right now he is in Cincinnati. I thought he won't come up in this lecture series, but anyway, he comes up. Professor Ruhikanta has been researching for more than 30 years and been working in Cincinnati General Hospital since 2004. He was working on Fanconi anemia, Bloom syndrome, and cancer, etc. He has already discovered 2 genes, 3 new genes, FA genes, BLM binding proteins, including FNCB, FNCL, and FNCM genes. And he has published more than good number of papers. Some of the papers he published includes Nature Genetics, Molecular Cell, Genes, Development, Protein, Structure, Functions, Biomimetics, Human Molecular Genetics, Cancer Cell, etc. So I would like to request Professor Ruhikanta to give his lectures. Please, Professor.
Hi, everyone. First, might have got really jam-packed the whole day, right? Probably I'm the last speaker, right?
Yes.
So I want to thank you, all the organizers and participants for your kind attention and giving me this opportunity to share some of my work. Let's see, let me start the screen. Which one was that? I already opened it. Let me see what is happening. Yeah. Share screen, but the full screen is not coming. Let me see. Okay, can you see the full screen now?
Yes, it is coming now.
Okay, but it's not moving. Okay, looks like it's moving. How about going out? I was doing in the PDF format so that PowerPoint jump out in once in a while. All right, so today I'm going to talk about some of my original works
on a genetic disease called Fanconi anemia. Generally, biochemistry is a dry subject, and at the end of the long session is going to be a little tough, guys, okay? But I'm trying to get it as simple as possible. As I understand, most of the audience are not really trained as a biochemist, right? So also I'll talk about a journey through which I have taken for the past 20, 30 years, luck, hard work, all that matters in one's career. That's what I want to say. Hard work is definitely given, very important, but sometimes luck also, timing, in a way, luck and timing, they're all combined together. So let's see. So this is the place I work. There are more than 400 faculty members. I was recruited here in 2004 as an assistant professor. This is one of the top children's hospitals in the world. One thing about Western countries, people spend a lot of money on their kids. As you know, in the Western world, all parents don't stay together with the young family group. So most of the hospitals are very profitable if it is children's hospital, okay? There's a lot of good children's hospital in the US. Okay, let me start. So grown up doing PhD in Indian Institute of Science in Bangalore, the whole idea was, let me start my timer. Idea of doing research was like, okay, the government, probably someone will provide all the facilities, all the funding, salary, equipments, right? That's not true, okay? If you want to do a research of some kind, somebody has to provide the funding, right? Somebody has to provide labor, reagents. So that's where the issue is. When you open up in the big world, want to study something, someone need to provide you infrastructure, money, grant, for example. That's how today I'm a researcher in Fanconi anemia because of a family in Oregon. Their children was suffering from a very rare genetic disease called Fanconi anemia. At that time, nobody knew what was that disease, very rare orphan disease. And this family was David Formeyer, happens to be a big shot in Oregon State in US. He was a Vice-Chancellor of Oregon University and the Attorney General also. So he started a foundation called Fanconi Foundation. Okay, he collect his big shot friends and other philanthropists collecting monies to do research, and they start funding small labs to start working on Fanconi anemia. Today, a lot of people are working in Fanconi anemia, including myself, because of that family. If they didn't start this foundation, I may be doing something else. So something like this philanthropist work, even though all their children died, they keep continuing doing this foundation. Unfortunately, the founder, David, died a few years ago, but still the foundation going very strong, okay? That's all I want to give you a message. It's not like you're given everything free. So somebody has to really start. If you want to study an orphan disease or something, pick up something from a ground, from a seashore, nobody wants to fund you. So you have to have a rationale why you need that funding. So that's the key here. Okay, so it comes to this disease, okay? This is a very, I should say, rare genetic disease, genetic disease meaning from parents to offspring, relatives. So you have a situation where kids are not forming a lot of blood cells, their bloods are very anemic, and you have a lot of bone deformities, okay? Then developmental problems, they don't talk very much, and their bone do not have a lot of blood, and their genes are fragmented, and they develop cancer in the later years, okay? So this disease was discovered long ago in 1927 by a Swiss pediatrician. His name was Fanconi. After that, so many studies has been carried out. What people found out that their genes are very fragile. When you just look under the microscope, you see the healthy. Can you see my mouse moving here? Hello?
Yes.
Yes.
Okay. So this is the healthy chromosome under the microscope. Here you see all broken, okay? What happens is when you have this kind of situation in the gene, then cells try to correct it. Then what happens? They randomly join ends to end. That's all non-homologous end joining. Then the whole system is crashed out. So if the two genes together, not supposed to get together because they are broken in the middle, then that cell carrying that particular broken DNA cannot continue. That's how they crash out, okay? Just like this, no blood. And this is a wild type, okay? So I'll skip some of the slides. So what happened is this disease is caused by mutation in two chromosomes. Human being has two copies of each gene except the X chromosomes. So both of the genes has to be mutated to have this problem, okay? So either father is the carrier, mother is the carrier, but mother, father don't have disease. But one of the offspring are 25% have a chance to get a disease, okay? But if one of the mother or father has already the disease, the chance is very high. But thing is a part of the evolution. If the mother or father has the disease, probably they don't have an offspring, okay? The kids with the Fanconi anemia generally don't produce offspring. So that's how the evolution works. It's wiped out from the population, right? So most of the thing we find is mother, father fine, but the children has the disease, okay? Because mother, father has disease, they cannot be father. They cannot be mother, okay? That's how the evolution works. So there are several genes involved in this. So I don't know, these things always popped up. So, there is a term called complementation groups, meaning if you have a complex enzyme, there are so many subunits involved. So if any one of the enzymes is mutated, the function of the whole system is collapsed. So everyone, A, B, C, will generate the same disease. Like in a pathway of enzyme kinetics, every subunit plays an important role. So if one of them is mutated, it goes to Fanconi anemia. So another one is mutated, goes to Fanconi anemia. So those are called complementation groups. So we have a lot of genes so far, 22, 23, all involved in Fanconi anemia. So this called A, B, C, D, E, F, up to like ST now, okay? But most of the common ones, so every gene mutation do not give you Fanconi anemia. Out of the 20s, only few of them are very common, meaning A, C, and G comprises of 80% of all the Fanconi anemia patients in the world. So most of them are represented by only 3 mutations in 3 genes, okay? But there are very rare ones. Maybe why? Because some of those genes, when mutated, the organism cannot tolerate, meaning the child cannot be born. So these 3 genes, A, C, G, may be more tolerant, the child can be born, then later on have the disease. But if the genes are really essential, the child is not born. So that's how the presentation is, okay? So as the name says, the bone marrow failure is the #1 cause of death. If they live long enough with the transplantation and modern therapeutic regimes, then they develop cancer. So that's the unfortunate part of this disease, I'll tell you. As the technology progresses, a lot of methods how to transplant them from the siblings. If you have a diseased person or you have a healthy brother, sister, you can put their bone marrow to the children and they wipe out the old one, the diseased one, put the fresh one from the brother, sister. they can survive quite a bit. But thing is, only the blood system has been corrected. Let's say you have a disease, right, because of the mutation. Now, mutation is all your body, not only in the blood. But the blood is something like every 20 days or 120 days, it has to refresh, rapidly dividing organ, right? So that's why the effect is in the blood. Bone marrow system has to come up with the new blood every 120 days. So that's why a lot of pressure on the blood system. Now, by using a sibling donor, you do the bone marrow transplant. Now your blood system is good for a while. But thing is, that bad gene is there in the neck, in the head, in the other organs. So people found out they got cancer in the later age, okay? That's what very unfortunate thing about this disease. This is the mortality. They don't survive very good, okay? Most of them died about 15 years. So I'm coming to the mechanism part of this. So what these proteins are doing, in fact, thing is, when you have a gene mutated, cause a disease, right? Then when you look at the protein and look at the primary structure and see what these things are doing. So when you look at the protein, you have a bioinformatics information, right? Is it an enzyme? Is it a DNA binding protein? Or is it a membrane protein, right? Based on the structural motifs you find in the gene. But unfortunately, these proteins do not have much of a signature motive to tell you what these proteins must be doing in the cell. That was the difficulty in the beginning. Okay, only thing it was known was there is one gene called FANG-D2. D2, you can just say D2 is one of the genes involved in Fanconi anemia, could modify. See here, this is the protein gel. So when you modify it from one band, it becomes two bands, okay? So is the ubiquitination. Ubiquitin is about 7 kD protein, about 70 amino acids, roughly. Added to the protein is a modified. So ubiquitin moiety is added to the proteins. That's how it becomes two bands. One is the original one is a modified one, the ubiquitination, okay? So that happens. Then if that does not happen, you have this all kinds of disease problem, okay? So what the ubiquitination is called is ubiquitin ligation, right? Ubiquitination. So then people believe, okay, all this protein involved in this complex, I'm going to talk about very quickly, is seems to be a ubiquitin ligase. You know, it does add ubiquitin to the proteins. If not happening because of the mutation of any one of these, then you have the disease, okay? So I come in, then I also want to, I don't know how much time I have, but you know, to learn science, you always appreciate how people did science a long time ago. That's how the technology we have today is not there 10 years ago. But science was doing very good that time also. So how people did when this kind of technology, next gen sequencing, just you can do a lot of things now, like mass spectrometry, like in sub-nanogram quantity, you can do mass spec. Now you can sequence the whole genome by $300, right? It was $1 billion project, the whole human genome project. So it has gone so fast in past 10 years, but before that, also people do research, right? So this one was in 1994, I think. Before at that time, I was just started my PhD. Okay. So what did you do at that time? So you have a person who has Fanconi anemia. You don't know what is going on with that gene, and you don't even know what gene it is. But only you know is this person do not have blood in their system, and their cells are very fragile, DNAs are very fragmented, and there is a chemical compound called mitomycin C, generally used for chemotherapeutic agents that kills the cells, right? So when you put the mitomycin C to the cells, they are sensitive, whereas the normal cells, they can grow. So you can always calculate how much you put to kill the Fanconi cells, but not kill the wild type cells, right? You can have a concentration there. That must denote that time, okay? So that time there was a technology called cDNA library, where people take out all the mRNA. So from the genes, it translates to mRNA, right? Then you make to cDNA. Then that makes to protein, right? So people make isolate RNA from the human genome, a whole cell, make library out of it, randomly make protein out of it, like 20,000, maybe 35,000 proteins made out of it with the cDNA put into the plasmid and throw to the cells. Okay? If you are lucky, one of those genes in that library coming out of the human cell may have the protein which is mutated in this gene. Then somehow this plasmid will go to the cell, that particular cell where the gene is mutated, then they grow into mitomycin C. So now what happens if this gene goes inside? This was the negative cell, now this gene go inside. Luckily, this particular gene has to be in the library to begin with. We don't know how many chances are there, very rare chance, right? This particular gene has to be there in the library so that it goes to the cell, then it get correction. Now this cell can grow in mitomycin C. Over time, this will grow out. Then, you know, this is the humanly made library, you know, other part of this gene. So you can PCR out. You can amplify by PCR and see what is the flanking side. That's how you can use, you can have the information what is in this red. So that's how they can clone, they can identify the gene, they can discover, oh, this gene is the one mutated, okay? That's how they discover all of the 4 genes out of many patients of Fanconi anemia. See, but very tedious, very what you call, you need really clean hand, very tedious, meticulous hand is required for this. Okay, you cannot just simply get out of this by putting genes into the cells. It has to be really calculated single cell processing. So they have done this in the past in 1994. Okay, now you just give the whole DNA to a company and they will sequence and give you what are the mutations. Okay, so that's the technology difference. But that time also they managed to clone these genes. Okay, then comes my role in this. Okay, so 4 genes already discovered when I came into the picture. So I went to NIH for my postdoctoral studies after my PhD in Indian Institute of Science. He was a very famous, my boss, is Wei Dong Wang. He's a very famous biochemist, mostly work in transcription. All the transcription papers are very famous biochemists like Roger Kornberg, that kind of Nobel laureates. So they are very good in it. So I was working on histone proteins, sperm proteins in India. So I want to continue DNA protein interactions, right? DNA binding proteins, how they modulate DNA structure, how they unwind stuff, transcription, translation stuff. So I arrived there and he asked me, why don't you work in a different aspect of protein chemistry, of protein biochemistry, you know? Too many people are working in transcription. Unless you are best of the best, it's going to be very difficult to compete, okay? Either you are best of the best or you work somewhere, nobody's working it or nobody wants to work. That's how you get success, right? That's what he advised me. So you use the tools you have as a biochemist, but use that tool to do some other things except transcription, DNA polymerase stuff, okay? So he got an idea, okay, now you have a disease, genetic disease. This is the gene, protein product generally. Then generally in the cell, proteins do not go alone. They always interact with other proteins to work together most of the time, okay? Almost most of the time. So they always form complexes or interacts with other proteins, okay? So now let's say you have a disease gene and you isolate the complex, if any, okay? We don't know is complex or not, okay? When you start a project, you don't know is there going to be a complex or not, okay? That's where the luck comes in. So then you isolate this complex. Now let's say you have these proteins other than this disease gene, then hopefully these other genes or proteins you found, maybe another disease gene, or maybe it involves in the disease, it helps to perform the function of that disease protein. That's how you uncover disease mechanism, right? So that's how he suggested to work on this, okay? Mechanism of disease, maybe new gene. Okay, here is the cartoons. Let's say this is a big fish, right? Components, 1, 2, 3, 4 components, right? This is a unit of a function of a complex in the Fanconi anemia, for example, right? So we try to isolate this whole complex by preparing one antibody, high specific antibody. So antibody is one of the best gift of nature, right? Antibody can recognize anything available so far in the world, right? So you can generate the antibody against a particular disease protein, what you want to work for, and use that antibody to pull down each interacting protein from the cell, from a human cell. Maybe nuclear extract, cytosolic extract, chromatin extract, based on what protein might be residing in the cell, right? So you develop a very high specific antibody, then pull down this antibody from the cell. By doing so, you may pull down the whole thing, okay? Then you identify these proteins. Again, when I started working on this, the identification of the proteins from a gel. So you run a gel, right? Polyacrylamide gel, and separate them in the gel based on their sizes. Big size protein move very slow, small size protein move very fast, okay? Then you cut them each protein, and the mass spectrometry analysis was carried out. Again, I say, at that time when I started working on that, mass spectrometry was very highly developed. Before that, it was not. When I was not in India, it was not that good. You cannot identify a protein in the nanogram quantity, okay? So see, the technology complements my work, or in the same time, like simultaneous. Otherwise, I should have been succeeded on this, okay? So let's say you have a protein on a gel, okay? So here, so these are the proteins I was talking about, right? This protein, the top one is the heavy one, big ones. As you go down, is the smaller ones, okay? So what I did was, so you develop a high specific antibody against the Bloom syndrome. I was talking about Bloom syndrome is another cancer-prone disease, is a DNA helicase, okay? That's how I started working on it. So he asked me to work on the Bloom syndrome helicase. It's a DNA unwinding protein. So it can unwind 2 strands of DNA, okay? DNA always exists mostly as a double-stranded, right? This enzyme can unwind them. For the DNA to replicate or transcribe, the DNA has to be unwinded. So that's the enzyme, very interesting enzyme. So he asked me to work on that, and I told him, but I heard this enzyme is very famous and a lot of people have already worked out. A lot of publications have been done. In a Manipuri language, all the easy one has been discovered. What do I do now? I mean, looks like this project is completely worked out. So he looked at me and saying, Ruhi, don't worry, it depends who did it, how much, the project was, how details the project was. So don't believe what other people has discovered unless you do it yourself. So there may be so many other things yet to be discovered. That's what the advice was. So, okay, go ahead. So I pulled this Bloom protein down from the whole cell, okay? This is coming down from the whole cell containing about 30,000 proteins. So this is the gel where, so we develop antibodies, right? You inject a piece of protein we make the piece of protein in bacteria by recombinant DNA technology and inject that protein to the rabbit. So we take the serum out before you inject the protein. That's called, we call it pre-immune. So this denote this pre-immune serum do not have any reaction to our protein. So when you use the pre-immune, we don't see any protein coming down. So these thick two proteins are light chain and heavy chain of the immunoglobulin gene protein. So antibody has two bands, two subunits, right? Light chain, heavy chain, okay? So these are the antibody protein, okay? So now on top of it, you see several proteins, right? Those are the protein coming down by our antibody binds to this protein. You see here, this protein is one of the thickest one. Thick means more protein, right? Thick staining on the gel meaning more amount. Light one is less amount, okay, generally. So then we cut these proteins, right, and give for mass spectrometry analysis, say, thinking which one was the proteins we want to work for, right? So they discover or identify these proteins from the gel. So these days, guys, you can do research without even doing anything, okay? Today's research scenario, you just sit in the lab and you can send this sample to one company to do your job, and you can even crystallize your proteins, and someone will solve your crystal structure. And you just sit in the lab and just phone calls, but you need money. So the way the research is done is in a negative way is not very good. The students don't learn much, but the way it is, everybody is more worried about their product, right? The result. So, you know, when I started doing PhD in India, first thing our boss asks is, why you add that solution? Like when you make the plasmid DNA out of the bacteria, right? You add solution number 1, 2, 3. Then question is why, what the solution number 1 do, right? Then 2 does, 3 does, right? Why you add this solution? We have to know the mechanism. Now, you just buy the kit from the company, right? Okay, just follow the protocol, spin it down, you have the DNA. Who cares? So that the way it is going is not in a good way, but what it is what it is going on, okay? In a way it's not good, but people want the result. People don't want you to understand. They just want the result, okay? That's the negative part of this very rapidly growing science. People don't have time to understand, okay? They just want your hand, pair of hand, do the thing and get the result out, okay? That's something unfortunate part of this modern research. It goes very fast, but people just don't learn much. When you have a trouble, you cannot troubleshoot. That's where the problem is, okay? Anyway, continuing my, so they identify these proteins from the gel, okay? I have done a lot of stuff, I will just skip. So if you have 2 proteins, right, bind each other, so you pull down using one protein, then you see something, right? Then you have used the other part, for example, here you see, this is the protein I use as a bait to pull down. Okay, now you get this protein, right? Now I use antibody against it and pull down. Here you see, this one is more than this now. Always the antibody direct binder will bring more down, will bring down more proteins. You see here, this one is more here, but when you use another antibody, Bloom, this has more protein. You see, when I use the Bloom antibody, you have more here. When I use the Fanconi antibody, I get more protein here. So that's how you see. So to prove that they are in the same complex, you have, that's called reciprocal immunoprecipitation in the scientific term. So if 2 proteins A and B binds together, when you pull down A, B should be there. And when at the same time, when you pull down B, A also should be there. That's called reciprocal immunoprecipitation. That's how you have to prove that these 2 proteins forms a complex in the cell, okay? Now you see, look at this, a crowded slide, but you see all the proteins already known previously bind to Bloom is there in the complex when we did the mass spec. meaning what we're doing is correct one. So we pulled down the protein and we found out most of the people already discovered, meaning we are on the right track, right? But important is, in addition to already known, we have so many unknown. See, that's where you lead the research. Okay, so you already found out that people already discovered, thinking that, okay, this might be the correct one. Now you also have so many unknowns in this, meaning whatever you find is already discovered, some of them, is most likely that the unknown ones are the undiscovered ones, which is part of the complex. That's the whole crux of the project, right? Then we did more and more detailed studies. And as I said, see, in this Fanconi complex, you remember, Fanconi was a very rare disease. Proteins are hard to pull down from the cell. It's believed that they form a complex, do the ubiquitination, right? Let's see here. In this complex I purified, okay? We already have this Fang A, Fang C, Fang Z, Fang E, Fang F. Those are already discovered, okay? By other people, by the cDNA stuff. Remember I was talking about. Immediately, these red ones has to be part of the same complex that people did not look at, could not be found previously, right? That's how my roles in this disease comes in play, okay? So one by one, one by one, these genes turn out to be Fanconi genes, you know? So to do a research, I say collaboration is very important. So what happens is when you have something like this, you alone cannot do this job. So what happens is in the world, basically in the Western world, in the Europe, there is a very strong Fanconi anemia repository program. If you have a Fanconi anemia disease, you don't know what gene it is mutated in you, they collect cells from you, blood from you basically, and make cells out of it and store it in the library. So if anybody is working on the project, they can access to the cell. That's how the whole collaboration takes place. So we find 4 proteins in the cell, which is new one, novel ones, nobody has talked about. So we want to see whether these genes are the Fanconi anemia genes because they form the same complex as the earlier discovered genes, right? So that's how we figure out. So one of the, I will skip about the RNAi stuff, okay? So this protein we find with the 43 KD protein has a ubiquitin ligase activity. See, you see here, so ubiquitin ligase is a 3 enzyme complex, right? E1, E2, E3. Okay, all that put together, you have a ubiquitination of a protein, like multi-ubiquitination. Here you can see the later. If you have one of them, no, not happening, or mutate the enzyme. So ubiquitin ligase are generally zinc finger enzymes, okay? So one of the proteins we found was a 43 KD protein, has a zinc finger domain. We thought maybe this is the enzyme everybody's talking about, but they never discovered yet. See, I remember in the beginning of the slide, I say this supposedly has a ubiquitin ligase complex because it ubiquitinates one protein down the stream. But in that complex previous slide I saw, there is no ubiquitin ligase enzyme there. Okay, all the non-4 proteins do not have any signature functional motifs in the gene. Now we have a new gene with the ubiquitin ligase enzyme motif. And we prove that indeed this enzyme function as a ubiquitin ligase by in vitro ubiquitination, okay? So now we find a patient cell line. These cell lines are the cell lines derived from the patient. So this is one of the most important reagents when you do human disease research. If you have access to cells coming out of the diseased person, that's the most valuable reagent you can ever have. Without that, you cannot continue your research in a successful way, right? So we got a cell line derived from a person where this protein is missing. Basically, most likely this is the patient in which our protein is mutated, okay? So after doing the genomic analysis, It has got biallelic mutation. It has got mutation in both the genes, or both the copies, okay? Question is, okay, now you got a protein, looks like it's got mutated in a cell line. Question is, if you put that gene back, can you correct the phenotype? That's called complementation. So if you cannot do that, you cannot claim it's a disease gene. So you have a cell, right? Now you put your gene back. See, this protein was missing in this cell line you see here. So this is the protein we call 43kT protein. Just forget about the name, okay? So when we put back the gene, you get this ubiquitination. I was talking about 2 bands. Then when you mutate that enzyme from cysteine to alanine, it loses the enzymatic activity, okay? So now you kill the enzyme. Now, even though this protein is present as a mutant, you cannot ubiquitinate it. At the same time, the correction of the mitomycin C I was talking about cannot be corrected by the mutant. So basically, it proves 2 things. This 43kT protein I discovered is a Fanconi anemia gene, is it enzyme, and it has a ubiquitin ligase activity. So that's how I landed up with the ubiquitin ligase gene on this complex, okay? So this was published in Nature Genetics with the news and views, and with a lot of interest in the Fanconi anemia field. Nobody could believe a biochemistry can discover a gene by doing biochemical work. Most of the time those days you want to discover or clone a gene is a genetics, like positional cloning stuff. But starting from the biochemical approach, you can actually discover genes, okay? Because the technology at that time was very advanced. Like that we—
Sir, you have another 5 minutes, sir.
Yeah, I will try to get it done, okay?
Okay,
so,
okay, thank you.
So like that, so you remember I had like 4 proteins in that gel. So one by one, so this is another interesting gene. So that was the FANG-L, okay? The 143kT protein I discovered was the FANG-L. So this one is the FANG-B. So interestingly, as I said, human has 2 copies of each gene except the X gene, right? So this FANG-B gene happens to map in the X chromosome, okay? So basically, boys have only 1. Girls has 2 genes, right? 2 copies. So immediately we start looking at the boys. All the cells collecting from the boys, looking at it, because most likely 1 mutation is much more potentially having chance than 2 mutation in the 2 copies, right? So like that, we got two cell, and now we got like 100 patients now. See, this is the contaminating cross-reacting band. See, you see here. These 2 cells coming from the boys are missing this protein. And upon genetic analysis, we also found the actual germline mutation. So it's not that easy to find a gene, right? This mutation we find has to go map to the parents, okay? It's called germline mutation. So some mutation can be somatic mutation. This mutation may not be in the parents. Somehow it acquired during the embryogenesis, okay? Maybe out of nowhere it got mutation. That's called somatic mutation. But if gene mutation is mapped to the parents, that is basically germline mutation. That's how we discovered. So that gene, then we also discover one of the most talked about gene called FANG-M. That's the big one, 250, with the helicase activity. This is the one we discover in cover page of Nature Genetics with the helicase picture in it. So like that, I'll just skip a lot of the genetics data here. Those are how we analyze the mutation of a disease gene with the Fanconi anemia example. And we do a lot of purification with we also collaborate with the crystal structure stuff. In a structure, you can see which part of the protein is bind to the DNA. Then we make mutation based on the structure. Then you see these are the DNA protein complexes. You see the oligos, right? Then binds to DNA, you had a complex here. That's called gel-ship assays, right? When you mutate that particular amino acid, touch the DNA, you don't bind them. So structure function studies, okay? Since I don't have a lot of time, it's a hard to understand subject. Let me skip this and just touch about a few words on this. So we have this technology to purify complexes. Now, what we do is we take the protein and put in the mice, okay? So we generate mice using this ISA flag tag, generate a transgenic mice. And that mouse has all our tags in all over the tissues, right? Testes, the lung, spleen, everywhere. So we can purify complexes now, not only from the cell line, from the tissue collected from the mouse. So then we can do all biochemistry throughout the organs, different organs, liver, testes. So that's how we can do now. We are doing this one. Now, so these are the gels coming from embryos, testes, spleen, all kinds of stuff. So some proteins form different complexes in different organs, okay, based on their functions. So that's how I'm coming to. So these things, I'll skip it. And just go to acknowledgement where I want to say some few words about work done. So only thing I want to say here, being in academics is only rewarding thing is people citing my work. So far, I have discovered quite a bit of genes, and more than 4,000 citation has been generated throughout the world by other scientists. So that's the rewarding thing doing the science. People found our work to be duplicated, and found to be true. That's the really enjoying thing about science. People can reproduce our work and cite it 4,000 times. So here, one of my earlier postdoc, Thiam Ram Singh, now in biotechnology department, Manipur University. Abdullah Ali, he's from Hyderabad. He's now in Cornell University. Arun Pradhan is in Iowa. Lokesh Bhushan went back to India in a company. Nanautsha Sharma is also in ISBD in Tagel. And my wife is also helped as a technician in my lab and other lab techs. And my collaborator from Amsterdam, and Patrick Sung from Yale, and Arlene from Rockefeller, and Widong Wang is my mentor, and another collaborator from Oregon, and Kissing Pang is my collaborator in Children's Hospital. And funding by NIH, Fanconi Research, and Ohio Cancer Research, American Society Hematology, and Department of Defense, without which research is not possible here. All right, thank you guys. I'd like to answer some questions. Yeah. It's hard to speak, in a very short time. Anyway, thank you.
Yeah, it's right, sir. Thank you, sir. Hello, thank you, sir, for your nice lecture. Sure. Yeah, any one or two questions from the audience?
Probably people are tired now by the end of the day.
Yeah, it seems. Yeah, actually, I also don't know much about this Fanconi anemia. Still, I have done a collaborative project with Dr. Ram Singh on the Fanconi anemia, where I do all the chemistry thing. He does all those Fanconi anemia thing. Anyway, project is finished, and then we also submitted for a patent, not related directly to the Fanconi anemia, but other cancer-related thing. Thank you, sir, for your nice lecture.
All right, thank you guys. Okay.
Neeraj?
Yeah, so Dr. Brajakesh can wind up this technical session.
Okay. In this technical session number 2, we have 4 presenters. The first one is Professor Warjit, where he talked about the antioxidants and its related effect and its isolation from the natural product, which is a very tough one. Then we have another second lecture by Professor Yadav from South Korea, where he talks on nanomaterials, its application in the coatings, cars, then so many other things. Then we have Professor Iboyama from CFTRI, where he talked about food technology, how food can be preserved, how food can be kept for the future use. And then we have Professor Rohikanta Sharma, where just now he just finished his lecture, where he has given a good, very nice lecture on Fanconi anemia. Thank you, everybody from the MTU as well as KKT, and we wish you all the best. Thank you. Neeraj, please.
Thank you, Dr. Brajakeso, for sharing the technical session number 2. It was a well chaired session. So after this technical session number 2, we will move forward with our scheduled program. Now we will be having our oral presentation. In KHUMANG 2020, we have 34 abstracts submitted for oral presentation, and we have collected the video format from them. All the video presentation will be reviewed by 5-member selection committee. The 5-member selection committee comprises of Dr. Longjam Jaideva Singh, Director KKT, Dr. Swapana Manipur Technical University, Imphal, Dr. M. Neeraj Luang, myself from NCL, Dr. Ragumani from DARC, Dr. Professor Kiran Sharma from Kolhapur. The winner will be awarded as Young Scientist Award with a citation and a ₹5,000 as a cash reward. The winner will be given a chance to publish their full paper in Kanglei International Edition. Today on day 1, oral presentation 1 to oral presentation 20 will be presented in a video format. And on day 2, the remaining oral presentation from 21 to 34 will be presented. So now I will be sharing the complete compiled video of the oral presentation. Okay, I have muted all the participants in this session, and I'll be playing this video continuously for all the oral presentation. So let's see.
And came to present my research work entitled Imaging Flexible and Ultra-Sensitive Toxic Gases based on carbon nanotube conducting polymer nanocomposites. Before going to my research topic, I will give you a brief introduction regarding my topic.
Sir, voice is not coming, sir. Hello.
sensor, and in particular we have deposited pollination by the encoding method. This figure shows the efficient images of pollen showing the interconnected fiber spongy network. This type of morphology is very beneficiary because it requires micron surface area and which gives the maximum size for the absorption of gas releases. For this gas friction, that type of morphology is more important. It's a TN image of pani shows the morphology and showing the average diameter around 45 nanometers. This figure shows the XPS level spectra of pneumonia, and this spectra into two peaks representing 399.32 electron volt and at 400.94 electron volt representing imine and amine units in this internalized sort of pani. So we also confirm this internalized sort nature of pani by FTR and also FT-Raman. So then we have developed sensor devices and tested its gas sensing performance. This figure shows the sensing behavior of this pani using sensor, its sensitivity, maximum sensitivity observed is 2.7%. And because B shows the gas response, gas velocity increases with increasing the gas concentration from variation from 20 ppm to 200 ppm. And this because the represents the linear behavior of this polymer sensor. The response response recovery representing gas, there is a change in concentration from 20 ppm to 200 ppm. There is a decrease in the response time, also increasing the recovery time as there is a large number of gases at on the surface of the pani. This selectivity histogram represents that the pollen prepared pollen sensor is highly selective towards the electric gas only. And figure F represents the stability curve for pani sensor showing this 87% acceptable stability for this sensor around 45 days. To enhance, to increase the sensitivity, we have incorporated the carbon nanotube in that polymer network. So to enhance this gas sensitivity, this figure shows the schematic representation of polymerization of CNG pani changes, and this photograph shows the actual extruder setup for the synthesis of CNG pani changes. This schematic flow chart for the synthesis of CNG pani pani nanocomposite shown in this figure, and this FTR spectra represents the benzoid and cunite vibrations at 1471 centimeter inverse and 1560 centimeter inverse, representing the number of pani, and the enhanced intensity represents the strong interaction between the CNG and pani. This appearing image of CNG pani representing the fibrous pointing network representing nanofibrous structure, which gives you more absorption site for the gases. The close inspection of this image, like the TN image, shows the TN is graphed by pani, seeing carbon and tangents between the multiple layer of polyethylene. Now, this slide shows the gas sensing performance of CNG pani nanocomposite. This figure shows the enhanced gas sensing performance as compared to pure pani. The gas sensitivity increases with increasing the gas concentration as there is a large number of gas molecules available on the surface of this composite sensing material. This response recovery curve represents that the response time gets decreased with increasing the gas concentration, and recovery time gets increased increases with increasing the gas concentration. this selectivity is represents that is selective nature or highly selective behavior of PNG panel sensors towards this NH3 gas. And this schematic representation of ammonia absorption and electron transfer in the PNG panel nanocomposite and corresponding band diagram we have shown in this figure. When you incorporate the PNG in that polymer, it provides the conducting channel for the catalyst. That's why we got the enhanced sensitivity in case of PNG panel nanocomposite synthesis as compared to pure panel. Similar way, we have also synthesized the PNG PTY polypyrrole nanocomposite synthesis by the CVD method, which is figure 2. This is a photograph of PTY in PNG panel synthesis. And this same image of PTY shows the cauliflower-like structure having the globular granular present on the surface of this PTY. In case of PNG PTY nanocomposite, interconnected small granular structure observed in case of PNG PTY nanocomposite. The close observation for this PNG panel nanocomposite shown in image is one can see that this coaxial structure of this PNG panel network, and PNG is situated at the central part, and this PTY polymer is grafted on that PNG. So this inside that PNG provides the conducting channel. That's why we got the enhanced result in case of PNG PTY nanocomposite, and PNG PTY nanocomposite sensor is highly selective towards the NO2 gas. So this gas behavior nuclear PNG gas indicates the sensing higher sensing response towards the NO2 gas. We have this led to the successful development of gas sensing devices based on this PNG PANI and PNG PANI nanocomposite material. So also we have fabricated the wireless security alarm system, which gives the early detection alarm to when there is a leakage of gas. Also we have deposited engines on the large scale on the flexible plastic surface, which gives the transparent and flexible nature of this sensors, and also we have developed the wireless alert system based on this flexible sensors. Also, first time we have developed a security alert system, which gives you directly the SMS alert on your mobile when the gas process is released of that. So you will immediately get the notification on your mobile. This first time we have developed such type of wireless security alert system. So these are some conclusions. We have developed the flexible and transparent gas sensor and security alert system using the PNG PANI nanocomposite. The nanocomposite based PNG PANI and PNG PTY can act as the best suitable candidate for the selective and threshold detection of NH3 and NO2 gas at temperature with a fast response and high sensitivity. Now, these are references. I would like to acknowledge DRDO for financial support to carry out this research work. Thank you one and all.
From the Department of Chemistry. Hello everyone, good afternoon. My name is Harim from the Department of Chemistry. Today the topic of my presentation is synthesis of functionalized benzo-F2-isochromanes via novel-nasal condensation and evaluation of their antimicrobial activities. These are the outlines of my presentation. Now I'm going to talk about it. Introduction. Chromanes are polycyclic organic compounds which have been constructed from the fusion of benzene ring to heterocyclic pyran ring. They have the ability to have non-covalent interaction with various active sites in organisms. They exhibit biological and pharmacological activities. They also use as additive in food, perfumes, cosmetic, optical brighteners, and disperse fluorescent and laser dyes. These are some examples of naturally occurring coumarin derivatives. Reported synthetic methods of chromanes. Next, move to the present work result and discussion. In our present work, we applied the non-nasal condensation reaction. And we used to starting material that is beta-hydroxide esters and ketene acetals. The synthetic method of two starting material is shown in this scheme 1. After the synthesis of two starting material, we have synthesized 3-benzoyl 2H-benzoyl bromine 2-thione from beta-ketone esters and 2H-benzoyl bromine 2-on from alpha-oxoketene acetals. 3-benzoyl 2H-benzoyl bromine 2-thiones can be obtained by treating beta-ketone esters and 2-hydroxynaphthaldehyde in presence of piperidine ethanol under reflux condition. The another target compound 2H-benzoyl bromine 2-on can be obtained by reacting alpha-oxoketene acetals with 2-hydroxynaphthaldehyde in presence of piperidine in ethanol under reflux condition. By replacing this AR and AR1 with these groups, we can synthesize various bromine derivatives. This is the optimized reaction conditions of the bromine synthesis. In the preliminary reaction, 2.5 millimoles of beta-ketone ester, 2.5 millimoles of 2-hydroxy-1-naphthaldehyde and 0.2 millimoles of piperidine were chosen as the model of the reaction. The reaction mixture was reflux for 10 to 15 minutes in ethanol at 95 degrees Celsius. We obtained the compound with 93% yield. When we decrease the catalytic loading 0.1 millimoles, the yield decreases. In aqueous medium, the reaction provides no product. And in absence of catalyst, the reaction provides no product. We also tested the base-like triethylamine in THF or DMF. The reaction provides only 40% yield of the product. We also carried out the reaction in various metal salt, that is copper chloride, aluminum chloride. We could isolate the product, however, the reaction took longer time. Thus, we optimized the reaction condition was established by refluxing 2.5 millimoles of beta-ketone esters, 2.5 millimoles of 2-hydroxy-1-naphthaldehyde in presence of 0.2 millimoles of piperidine in ethanol at 95 degrees C for 15 minutes. With the above optimized reaction condition, we synthesize three benzoyl 2H-benzoyl bromine 2-thione derivatives and 2H-benzoyl 2-on benzoyl bromine 2-on derivatives. The structure of all the newly synthesized compounds were determined by spectral and analytical data. This is a plausible mechanism for synthesis of the bromine compounds. And next, move to the spectra of the compound. This is the spectra, particular spectra, protonumeric spectrum of the particular compound 3A. This indicates the presence of the 12 protons in this compound, and the peak at 8.946 ppm indicates, corresponds to the peak proton, corresponds to proton in the 500, and the remaining peaks corresponds to the aromatic proton of the carbon compounds. This is the carbon-13 NMR spectrum of the compound 3A. The peak at 192.73 corresponds to carbon oxidable bond or adjustment to the double bond. And pH 192.10 corresponds to the peak of carbon oxidable bond S, and the remaining peaks are the carbons of the remaining carbon compounds. And this is the proton NMR spectrum of the compound 5A, carbon NMR spectrum of the compound 5F. Next, move to the evaluation of biological activities of the newly synthesized compounds. Two bacterial, namely Streptococcus aureus and Escherichia coli, and two fungal species, that is Convener lunata and Fusarium moliniforme, were used for the study. The antimicrobial activity of the compound was compared with the standard antibiotic streptomycin and fungicide fluconazole. This is the antifungal screening by poison food technique of the compound. Stock solution of the tested compound were prepared in acetone, and each compound was added to the model sterile potato dextrose agar, made them in conical flux separately to get the final concentration 100, 200, 500 microgram per ml respectively. Then the two solutions mixed vigorously, and 25 ml of the PDTA containing compound is poured into 90 ml Petri plate and solidified. After solidification, the plate were inoculated separately with mycelial disc 9 mm of the taste fungus. Then this is the Petri plate of the mycelial disc of the taste fungus. This is the positive control, PDTA containing only fluconazole, and this is the negative control Petri plate without any chemical compound. All the tests were performed in triplicate. Then the Petri plate were incubated at 37 degrees Celsius in BOD incubator till the mycelial growth in the control reached the maximum growth. After 5 days, measure the colony diameter. We measure the colony diameter in comparison with the control, and the average was taken as final reading. And this is the antifungal activity of the compounds against Lunata. And the different color shows the different concentration of the compounds. Here, significant mycelial growth inhibition of 90% and above was found for compound 3E, 3F, 3Z, 5D against the fungus C. lunata. Compound 3Z had very efficient antifungal activity. And this is the antifungal activity of the compound against F. moliniforme. Here the compound 3A, 3E, 3F, and the 5E show significant antifungal activity against F. moliniforme. 100% mycelium inhibition on F. moliniforme was shown by the compound 5E. And next, move to the antimicrobial screening by agar-well diffusion methods of the compounds. In the step 1, 2 to 3 identical colonies are picked up from the plate and transferred to the broth. The tube is incubated for the bacterial growth. And then in step 3, a cotton swab tip in the inoculum suspension is swabbed over an entire surface of the agar to give the long culture. Then 9 mm diameter the well are made. After that, diluted stock solution of the test compound is pipetted into the well and level well and incubated at 37 degrees Celsius for 24 hours. Then the antimicrobial activity was assessed by measuring the diameter of the inhibition zone around the well. This is the graph of antibacterial activity of the compounds. Here, compound 3C, 3E, 3F, and the 5D show efficient antibacterial activity against the E. coli and Staphylococcus aureus. at 500 microgram per ml. Compound 5 is show the highest spectral activity. Then we conclude that special synthesis of different benzoate chromin derivative in ethanol is demonstrated by was uses diffusion catalyst. The result of the microscopic screening of the organic compounds lead to the conclusion that compound 3G5D5A are promising antimicrobial drugs candidates. I acknowledge my supervisor, Professor Imphal Singh. Thank you. Good evening, everyone. My topic is the photoluminescence studies of the European dog calcium molybdenum tungsten phosphor. We already know that the alkaline earth tungsten and the molybdenum have the more application because of the potential application in the visual display solid state light. The photoluminescence properties of the material can be enhanced by the doping of the lanthanide ion. Among the lanthanide ions, European is the commonly dominant as its intense and the narrow emission line extending from the red to the near infrared. The phosphor based on the mid molybdenum tungsten exhibits the promising spectroscopic property. The European dog calcium molybdenum tungsten compound are the promising candidate as the red engine phosphorus for the white light engine diet. Here is the synthesis part. First, I synthesis the pure calcium tungsten, and then the European low calcium tungsten, and then the different concentration of the molybdenum. Here is the result and the discussion. Here is the XRD study, and then XRD study. From the XRD study, it is found that all the diffraction patterns can be indexed to the standard diffraction data of the tetragonal set of the pure calcium tungsten with a reference number 010772234. No extra peaks were observed due to the absence of the impurities. The substitution of the calcium by the European led to the reduction in the unit cell volume as the European ion is slightly lower than the lower ionic radii than the calcium. And also there is no shift in the addition of the molybdenum during the synthesis, as it indicated that the molybdenum does not affect the crystal phase of the synthesis material, as the tungsten and the molybdenum have the similar ionic radii. And here is the lattice parameter, calculated lattice parameter of the sample in the photoluminescence study. Here is the excitation and the emission spectra of the unlocked calcium tungsten. The excitation spectra of the unlocked calcium tungsten shows the broad excitation peak in the range of the 230 to 320 nanometer, with the maximum at the 270, which is due to the transfer from the 2p oxygen into its one of the anti-5d orbital tungsten orbital. According to the molecular orbital theory, the excitation at 270 is due to the ground state to excitation state. It is the only electric transition of the tungsten in its EG symmetry. Then after the excitation at 270, the pure tungsten exhibits the broad emission band in the 400 to 600 nanometer regions with a maximum at the 450. And here is the excitation spectra and the emission spectra of the sample with the different concentration of the molybdenum. The excitation spectra is recorded with the emission monitor at the 618 for the broad excitation with a maximum at the 273, along with the low intense peak at the 362, 382, and the 394 nanometer. And for the 273 nanometer, it is related to the fast transfer from the first lattice, whereas the strongest peak at the 394 is due to the European ion transition. The subpeaks of the samples are in gels with the increasing molybdenum ion that is receptive to the longer wavelength. This is due to the increasing the molybdenum iron concentration. Molybdenum iron concentration, more tungsten ions are substituted by the molybdenum iron, and average difference between the molybdenum groups would be decreases, and the electron delocalizes among the molybdenum group increases and leads to the red cell. And in the emission spectra, all the emission spectra shows the prominent peak at the 591 and the 618 nanometer, corresponding to the magnetic dipole and the electric dipole transistor respectively. Under the 273 nanometer excitation, the emission spectra increases sharply with increasing the increases with the molybdenum ion increases, and the which is related to the emission from the host lattice. And whereas in the 394 excitation, the emission intensity increases with the molybdenum ion, and this is maximum at 0.05, and then the emission intensity decreases. When the molybdenum ion were introduced into the lattice, more the tungsten groups were substituted by the molybdenum ion, and the energy absorbed by the molybdenum ion increasing. So the energy can be trapped by the europium ion. This leads to the increases in the emission intensity. Though more energy is absorbed by the molybdenum ion, then the energy trapped by the europium ion trapped by the europium ion may decrease. As a result, the integral emission intensity decreases with increasing the molybdenum ion. And here is the decay curve at the excitation at the 394 nanometer and the 273 nanometer. For the, and here is the lifetime values of the decay. For the 273 nanometer, it follows the non-exponential pathway, and for the direct excitation, that is the 394 and 94 excitation, it follows the mono-exponential pathway. And there is the conclusion. It is concluded that the europium top calcium molybdenum tungsten phosphor were synthesis using the hydrothermal method. XRG study reveals that the crystalline phase of the sample and the existing tetragonal phase, and the photoluminescence study reveals that the emission peaks of the europium at 618 nanometer under the 273 nanometer excitation, emission intensity increases sharply with increase of the molybdenum ion doping concentration, but in the case of the 394 excitation, the emission intensity increases and it reaches maximum value when the x equal to 0.05 and emission intensity starts to decline. The decay comes follows the non-exponential decay in the 273 nanometer excitation and the mono-exponential pathway for the 394 excitation. Thank you.
Good afternoon, everyone. Myself, Dr. Jaideva Singh. I am presenting a paper on synthesis, characterization, and use of molybdenum in dual mode colorimetric and spectrophotometric fluoride determination in water sample. Actually, fluoride may cause fluorosis, dental fluorosis, and skeletal fluorosis. Thus, detection and removal of fluoride in water is very important. Actually, permissible limit in drinking water of fluoride is only 1 ppm. Some conventional methods for fluoride detections are unselective electrode and beam methodology. In case of unselective electrode, it is lanthanum. It is concentration electrode. And in case of UV methodology, what is used is zirconium alizarin complex. Zirconium alizarin complex when treated with fluoride, it forms very stable complex. Thus, absorption changes and measurement possible. And some common methods for fluoride removal are absorption, Arnoldson method, absorption method. In case of Namgonda method, generally alum and lime are used for removal. In our method, we use phosphomolybdenum blue for colorimetric estimation of fluoride. This method, phosphomolybdenum blue absorbs in the range in between 500 to 1000 nanometer, and the maximum is about 750 nanometer. When more and more fluoride is added, absorption of phosphomolybdenum blue increases, thus quantification is possible. Preparation of solid phosphomolybdenum blue. Phosphomolybdenum blue is synthesized using ammonium heptamolybdate, and it was diffused by hydrating. It was collected by filtration, and the solid was heated to obtain dry product. Generally, it can be reduced by some other chemicals like solid phosphomolybdenum blue and molybdenum oxides are characterized by XRD and IR. XRD study shows that ammonium molybdenum oxide phosphate hydrate was found and NO3 was found when heated so supercharged 650 degrees centigrade. And the IR study shows that hot heating phosphate removed from the system. Same study shows that very small nanoparticles were formed, and these nanoparticles agglomerate to form larger particles and sediment shows its crystalline nature. I studied real properties of these solid compounds, phosphomolybdenum blue and molybdenum oxide. It is seen that when it is excited with the different wavelength, it is seen that it generally emits at around 430 nanometers. The deep blue color of phosphomolybdenum blue is due to ultraviolet molybdenum hydroxide electronic transition. And illumination study will get those colors into 40 transition in this DD transition cover, and we get maximum emission from 370 nanometer radiation. Conclusion: in this work, we have developed a very simple, fast and rapid method, colorimetric method.
I am Govt of Singh, respected Vice-Chanceller of Manipur Technical University, respected speakers, organizing committee and participants of this second international conference. I would like to present a topic on 3D printing. It's not a new topic, but this time I think it is necessary to remind the importance of it. Nowadays we download and print a book from internet. So in the same way, in the near future we will be able to order an object of my choice, given shape, size, strength, just by giving an order through online. The basic idea of 3D printing is presented here. I hope it will give an information to give it unemployed youth, students, educationists, researchers, etc. 3D printing technology. 3D printing works by starting with a digital model in 3D kit to put a design file, and then creating a physical 3-dimensional object. In 1980, 3D printing were used to reproduce prototypes. Today, because of the precision, repeatability, and material range of the printing, it is used as industrial production technology, and it is often called additive manufacturing. 3D printing is a computer-guided process. Computer-aided design software is used for creating industrial objects and artistic design. The software is highly specific in material properties, dimension, tolerance, and specific and printing processes. Some CAD softwares are Tinkercad, FreeCAD, BlockCAD, etc. SOPIS is a software tool for 3D designs, simulation, manufacturing, data management, and incorporate flexibility, control parametric designs. Software is used to slice the 3D design into layers. The slicer converts the model into a series of thin two-dimensional layers and produces a file with instruction, and then the design is printed layer by layer in a 3D printer. The creation of 3D printed object is done by laying down successive layers by layer material. 3D printing is used to construct hearing aids, replacement limbs, surgical implants, details models of the organs, bones, and blood cells for study. 3D printing is used to produce surgical instruments, dental restorations, such as the crown and external prosthetics. 3D modelings make it possible to construct complex geometric structure matched to patient's anatomy and surgeon's requirement. 3D printing makes medical imaging more real. 3D prints are used for visual concepts and for prototypes. The advances in material science make the printer stronger and more resistant. Variety of the materials such as ABS, which is a strong engineering plastic, SLRSC, ZR680, is accurate, white, is transparent, and flax, polycarbonates, which is chemically inert, and high temperature resistance, that's G, etc. To make 3D printing the future of engineering. 3D printing is one of the tools that helps students visualize their design and understand it. It makes both teaching and learning better. The type of 3D printer used in classroom is FD. 3D printing makes the real objects of the computer screen, and the student can inspect and analyze. 3D printing gives benefits to the students. This is excitement, complements the curriculum, gives access to knowledge previously unavailable, opens new possibilities for learning, promotes problem-solving skill. 3D printing of Asia aspires to be an educational leader in Asia. In addition to each track to control 3D printing business in the area, the World 3D Printing Forum is one platform to discuss the latest development, challenges, business opportunities of the 3D printing in today's industry. This forum is an exclusive closed-door platform and industrial and business expert in the Middle East. 3D Hubs continues its expansion in Europe, aiming to overcome Germany, Europe's strongest industrial nation. 3D Hubs online manufacturing platform is made possible due to 3D printing.
Good afternoon, everyone. The title of my topic is Synthesis Characterized and Biological Studies on copper-2 dicyanamide complexes of dual-ethanol and dicyanamide. Introduction: Copper-2 is one of the most commonly investigated transmetal ions due to its binding ability to a large variety of ligands and gives rise to a large number of geometries and stoichiometries. Biological studies of transmetal complexes containing ligands with versatile hydrogen bonding capability is a subject of extensive investigation. The course of various applications in anti-inflammatory, antifungal, antibacterial, antioxidant, and anti-cancerous agents. Biological work is to synthesize copper-2 complex of 1-amino or alkoxyurea and dicyanamide and characterizing the complexes using the IRUP conductance variety moments, and to undergo DNA interaction studies of the synthesized complexes using the thermos DNA, and by means of electron spectra fluorescence studies, thermodynamics studies, heavy studies, and to undergo antimicrobial studies of the synthesized complexes. These are some of the physical parameters which I used for this experiment. Next is experimental section. For preparation of the complexes carried out in two steps. The first one is the preparation of the copper-2 1-amino O2 alkoxyethylurea by the reaction of the copper chloride with dicyannamide with 1:1 molar ratio in the respective alcohols, and it was reduxed on the water bath for about half an hour. And in the second step, the liquid complex is prepared by the reaction of the copper-2 1-amino O2 alkoxyethylurea with dicyannamide in 1:1 molar ratio in water for stirring at room temperature for about half an hour. This synthesized complex is blue in color. It is soluble in water, DMSO, DMF, and alcohol. And this complex's melting points are around 165, 168, and 170. And from the electron spectral studies, this complex shows Swapana geometry, that means 165 nanometer for the peak. IR spectra. The IR spectra of dicyannamides with a strong nitrile band at 2.65 centimeter inverse, and this strong nitrile band is completely absent here in the copper-2 1-amino O2 alkoxyethylurea. And after complexes sent with sodium dicyannamide, this strong nitrile band is found. From this point of view, that means these complexes contain ligands 1-amino alkoxyethylurea with dicyannamide. This is an EPR spectra of the complexes. This is a solid step EPR spectra at RT, and a solid step EPR spectra LNT, and a solution RT and a solution LNT. From the solution spectra, the four-quarter hyperfine spectra shows the copper contain one unpaired electron having the four-quarter hyperfine structure. This is the proposed structure of the complex. We undergo DNA interaction studies for these complexes. First is the absorption titration method. Here, this is the spectra, electron spectra of the DNA with complex. The first peak is the electron spectra of the complex. With additional DNA, that shows hyperchromic shift. Which indicate complex bind to DNA, and their binding constant is determined from this plot using this equation. And this is fluorescence spectral studies. Our complex does not show fluorescence spectra, so we use ethidium bromide as a probe. The first one is the DNA ethidium bromide curve, and with addition of the complexes, their peak gradually increases. They gradually decreases. So from this point, we saw that the complexes bind to DNA, and from their binding constant is determined from this Sternberger equation. This is their binding constant for the complexes using the fluorescence spectra and electron spectra. Human DNA insertion studies also carried out for these complexes. Double-stranded DNA convert to single-stranded DNA with increase in temperature, and this temperature is known as their melting point for DNA. Their melting point is around 75 degrees Celsius. With the addition of the complex, there is slight increase in their thermal temperature. Shows the complex bind to DNA by non-intercalated binding modes. This is the cyclic-Polton of the complex. Cyclic-Poltonity of the complex with addition of DNA, there is slight positive and negative shift of the shipping. Shows the complex bind to DNA. From this investigation, we know that the complexes bind to DNA by non-intercalative modes of binding. We undergo the microbial studies for these complexes. Out of the collected microorganism, these three complexes can bind to, is active against the S-paratype. So these complexes are antimicrobial activity against the S-paratype. From this conclusion point, the complexes bind to DNA by the intercalating mode. The elasticity of binding the synthesis complexes can inhibit growth of S-paratype microorganisms, and we acknowledge Department of Chemistry for giving the chance for the experimental instruction for these complexes, and thank you.
One and all. I'm Dr. Jaideva, Associate Professor, Gitanjali College of Engineering and Technology, Hyderabad. I'm going to talk about anything granules, that is the leaves, that can be used as a potential functional food irritant. Granules is a herb that is grown across the world, and it is a popular herb that is used in various dishes, and it also yields essential oil from the flowers and from the seeds. Various studies have established that they contain polyphenols, then flavonoids, antioxidants, which are widely used in Ayurveda. Dehydration of the leaves, we have used a solar cabinet dryer where we have reached the temperatures of about 40 to 65 degrees centigrade, and a special glass is used to cut the UV radiation so that the micronutrients are preserved. So when the leaves are dehydrated, they have not lost the color. After solar dehydration, we have performed phytochemical screening and physicochemical parameters of anicum granulans. We have used three solvents: water, ethanol, and diethyl ether. And in the studies, we have observed that the flavonoids were present, which were the most important bioactive substances present in the leaves. From previous literature studies, these are the compounds that have biological significance: limonene, carbon, alpha-philandrine, equion, geraniol, paracetamine, and these are observed in the leaves. And now we are going to carry out some important biological activity theoretically using monol inspiration, a software that is available freely on the net. Biological activity is measured using monol inspiration software, which employs bioactivity score, that too within 3 ranges. If the bioactivity score is more than 0, it is considered to have good biological activity, and if the score ranging from 0.5 to 0, moderately active, and if it is less than -0.50, it is inactive. So from our studies, we have observed that the selected reagents are biologically active and have physiological effect. In functional food product development, it is essential to identify a plant or vegetable rich in phytochemicals and incorporate the same into the food matrix. Food matrix acts as a carrier for the bioactive component. The Anicum granulans leaves, that is dill leaves, when processed and tested, have shown the presence of the flavonoids, which contain these biologically active components, and hence these can be used as a potential food additive. So to carry out the further studies, when these processed dill leaves are incorporated in a suitable food matrix, how this biocomponent is getting affected and the absorbance studies of the same can be taken up. Thank you.
Morning, all of you. Today I present quality control, standardization, and antioxidant activity in the aerial part of Solanum fasciculum. Introduction: quality control of herbal drugs standardization helps in correct identification and authentication of the herbal plants. It is very necessary to obtain an appropriate quality control profile for a variety of herbal plants used in two conventional system of medicine. This may be helpful in minimizing the adulteration. The accurate identification and appropriate quality assurance of herbal medicine which contribute to its safety and efficacy. Plant profile of Solanum fasciculum CV Clark is the Xenodem, Solanum VNM Dunum, or Generginum Solanum Hariscanthum Dunum. It's a popular name: Indian nightshade, tropical soda apple, soda maple, Lamhamin in Manipur. Solanum fasciculum contains several glycoalkaloid, steroidal, glycoside, steroidal, saponin, and flavonoid. And this plant is also reportedly rich source of solasodin. Several pharmacological activity like anti-inflammatory and anthelmintic have been identified in Solanum fasciculum. Main objective to evaluate physicochemical characteristic of plant materials and preliminary phytochemical screening of plant extract. Further, total alkaloid contents, total phenolic content, total flavonoid content, and total tannin contents were estimated and quantified from different plant extract to evaluate the antioxidant activity of the plant of Solanum fasciculum by DPPH. Physicochemical evaluation: physicochemical parameters of forest powder plant materials such as aerial part, loss of drying, different age value, extractive values were determined according to the guidelines of WHO and Indian Pharmacopoeia. Extraction: the porosity powder plant material of Solanum fasciculum were successively extracted using solvents such as alcohol using soft-plate apparatus until the whole drug was aegis. Further, the extract was concentrated and evaporated in a rota evaporator and was kept in a desiccator until used. Phytochemical evaluation: preliminary phytochemical screening for the presence of various phytoconstituents was carried out in extract obtained after soft-plate extraction of fruit drug in different solvent. Quantitative estimation: the total phenolic content was estimated according to Alhamani et al. Using gallic acid as standard. Total tannin content was estimated according to Chandran and Indra using tannic acid as standard. Total flavonoid content was determined according to the method of Chang et al. Using quercetin as standard. Total alkaloid content was estimated according to the method of Shimcha and Nikuvi et al. Using atropine as standard. The antioxidant activity of the plant was measured by Delois. And phytochemical evaluation: the different phytochemical like alkaloid, steroid, different phytoconstituents are tested in plant phenolic extract of Solanum fasciculum. And in quantitative estimation, the total flavonoid content was 54.5 milligram. Total tannin content was 47.35 gram. Total tannin phenolic content 62.75 milligram. Total alkaloid content 2.11%. Pharmacognostical evaluation provides valuable information in terms of its physicochemical and phytochemical characteristics. Therefore, it is considered to be the preliminary stage in standardization of the herbal plants. Thus, the obtained quality control standard will play a major role in maintaining quality and purity of Solanum fasciculum. The alkaloids, flavonoids, phenols, and tannins present in phenolic extract of Solanum fasciculum effectuate a potent antioxidant, anti-inflammatory, and antibacterial activities. The quality control standard obtained in the present study will provide reference to crucial information to researchers for proper identification and authentication of plant and will help in maintaining its pharmaceutical, botanical, and economical importance. These are my references. Thank you.
Respected Chairman, teacher, and my dear colleagues, my name is Tombi Singh, research scholar under the guidance of Professor M. Singh, Department of Chemistry, Manipur University. The topic of my presentation is phytochemical and antimicrobial activity of the bark of Vice-Chanceller rock plant. First of all, I let me say about the plant that I have chosen. These are the photo for the plant that I have chosen. Local name of my plant is Yangli, family is Fabaceae. It is a tree climber, usually grow in the river or mountainous region of India. It is perennial and takes some years to overcome mature plant. It flowers in May to June at the start of rainy season and spring. The flowers are blooming like a tea and white in color. This Deris Candice plant have medicine value. It has been used in variety of ways. These are the some uses of this Deris Candice product. It is used as starter in the fermentation of one preparation. This product is used in the treatment of irregularity in menstrual cycle, nourishment of cell, massaging body, appetizer as a solvent, for removing stone in kitchen. Literature survey report that extract from this plant is used as insecticide. Some plant extracts have capacity of cytokinin secretion. Objective of study: to obtain various solvent extract of bark, phytochemical test of extract, antimicrobial activity test. This is the flowchart for my experiment. Plant sample is collected, powdering. Powdered plant is soaked in water for 5 days. After that, filtration was done. Filtrate was taken, residue was discarded. From the filtrate, 3 extracts are prepared. They are water extract, chloroform extract, DE extract. The 3 extracts are conducted phytochemical and antimicrobial tests. Material and methodology steps involved: collection of sample, cleaning, drying, powdering, solvent extraction. These are the photo for preparation of different solvent extract. First picture is the one bark. Second one is powdering. Third one is also powdering. Fourth picture is the powder form of the bark. Fifth picture is the soaking of bark in water. Preparation of different solvent extract. Soaking of plant powder in water, filtration, some ml of the filtrate were concentrated and made solid form, and this is water extract. Number 4, some ml of the filtrate were mixed in separate component and remove the ether solvent extract. Number 5, concentrate the extract to get solid form, and this is ether extract. Similarly, chloroform extract were also prepared. Number 7, study of photochemical and antimicrobial activity of different extract prepared. This is the antimicrobial test region. In water extract, terpenoid, alkaloid, saponin, tannin, glucoside, steroid, phenol are positive. In the chloroform extract, terpenoid, alkaloid, saponin, tannin, glucoside, steroid, and phenol are positive. In the B extract, polyphenol is positive. Antimicrobial activity result. Bacillus show positive activity to water, chloroform, and negative activity to petroleum extract. Mycobacterium show positive activity to water extract, negative to chloroform and petroleum. Micrococcus show negative activity to all 3 extracts. Result and discussion. The experimental results shown in the table come to conclude that alkaloid, saponin, flavonoid, phenol, glucoside, terpenoid are contained as secondary compound. Number 2, the flavonoid exhibit antioxidant, anti-cancer, anti-inflammatory activity. This effect in lower intestinal tract and heart disease, and also has the property of preventing oxidative damage and carcinogenesis. Number 3, the phenol anti-diabetes have ability to block enzymes that cause inflammation, antioxidant, immune danger, anti-clotting, hormone, and modulator. Number 4, saponins show following role in effect on growth, index, protein digestion, immune system, cell membrane, antioxidant effect, and also antimicrobial role. Number 5, the compound are colloid by blocking or intensifying the action of neurotransmitter chemical released by nerve cell in response to an electrical impulse known as neurons. Neurotransmitter diffuse into neighboring cell where they produce an appropriate response, such as electrical impulse in another nerve cell. Number 6, the results show washing to some bacteria, so it can be used for the treatment of some disease. Conclusion. The result obtained from experiment come to conclude that terpenoid, alkaloid, saponin, tannin, sterol, phenol, and glucoside are present. The plant extract so positive to some bacteria, therefore it can be used for the treatment of disease. Again, from analysis, we found that the plant is also used as food. Isolation of the compound present in this extract is future cause of my research.
Hello everyone, I'm Dr. Swapana, Selection Grade Lecturer, Department of Pharmaceutical Sciences, Government Polytechnic. And the topic which I've chosen is formulation, evaluation, and enhancing solubility of oral dispersible tablet of magnesium hydrochloride. As we know that diseases are associated right from the very beginning of life on earth, so as medicine to combat these diseases. These are the contents of my presentation. This is a modern medicine. As we know, they are very colorful. Some of them are very small. Some of them are oval shape, cylindrical shape, some are capsule, and different type of dosage forms are there. But they have to fulfill basic characteristic. They have to fulfill certain basic characteristics, and first and foremost characteristic, 3 characteristics are there, that is safety, stability, and efficacy. And for any formulation of the medicament, the success mantra is safety, stability, and efficacy. Oral dispersible tablet is an innovative dosage form that it is disintegrate in the mouth upon contact with saliva less than 60 seconds, and these are very new drug because of the point that it may target to the bedridden patient, geriatric, and pediatric, which are children which cannot swallow without the intake of the water. So this will disintegrate within 60 seconds. As for Center for Drug Evaluation, Research, and European Pharmacopoeia, they recognize the mouth dissolving tablet as oral dispersible tablet. The aim of the study is to increase the release profile, viability of the drug by enhancing the solubility, and to develop oral dispersible tablet of magnesium hydrochloride, which is mainly used in motion sickness, by incorporating suitable polymers to meet the desired characteristics of the ODT. These are the symptoms of the motion sickness, which may occur mainly when we travel in a car, in a bus, or in air. The symptoms are dizziness, fatigue, nausea, and vomiting are the most common symptoms of the motion sickness. Magnesium hydrochloride is a piperazine derivative having antiemetic, that means emesis means vomiting, antihistaminic, antimuscarinic, and selective property, which are used in motion sickness, as called British Pharmacopoeia, Martindale-Westcott, and Merck Index, and it belongs to biopharmaceutical classification system, class 2. There are four classes of biopharmaceutical classification system. So it belongs to class 2, that is low soluble and high permeable drug. And magnesium hydrochloride was obtained as a gift sample from UCB India, and the brand name Longifeed was also purchased from the retail shop. And before any formulation, the first thing we have to do is the pre-formulation studies, which are very important, which give both physical and chemical investigation. In pre-formulation, mainly the physical side, we have to see the solubility of the drug, the partition coefficient, the pH, the particle size, crystalline or amorphous, and BCS classification. As we know that partition coefficient reflects the permeability as well as the solubility. The pH is also very important aspect, as well as the particle size. Crystalline and amorphous, it actually gives a stability. And permeability and solubility is again given by BCS classification. Before formulation, we have to see the compatibility, whether the drug and the excipients has got any kind of interaction or not. If there is any interaction, there may be complexation, there may be any kind of adverse effect to the drug as well as to the body. So compatibility has to be studied with the drug and excipients. So it can be done with the help of FTIR and DSC. So here the FTIR is being compared with standard magnesium hydrochloride, which is being given in Clark's analysis of drug and poison, 3rd edition, 2nd volume. And then DSC is also being done. So with a pure drug, this way we authenticate the drug. And after this compatibility study, we go to the formulation. Here different types of the drug as well as excipients have been incorporated. And the drug we have taken around 25 mg, HPMC, MCC, aerosil is being used as the anti-adherent, and magnesium stearate is used as lubricating agent, and fabric agent, and cross-provident and super disintegrant. So each and every ingredient has got their own uses in the formulation. These are the odditive characteristics. Here artificial saliva is simulated with a pH 5.8 according to Girl et al. And this is the DSC of the API, active pharmaceutical ingredient, and the excipient. So here we see little bit of as such no significant shift is there. And these are the physical parameters which are being evaluated, where variation actually shows the performance of the machine, the uniformity content. The waiting time is very important in case of the oddity. The hardness to withstand any rigorous during manufacturing, handling, and transportation. And disintegration time is also very important. The friability is also a very important factor. So as to withstand any kind of handling, shipment, there should not be any kind of hindrance to the drug. It should be able to withstand. This is the dissolution profile of batch A, dissolution profile of the batch B formulation. This is for the complexation, and this is the marketed product Longifeed. And here is a comparison in the release profile of different formulation, and highest is in the case of the complexation with beta-cyclic upstream. And here I conclude stating that magnesium hydrochloride and excipient can be incorporated and formulated with direct compression method, and further we can study the stability as per ICS guideline, and in vivo studies can also be performed. These are the references. Thank you all once more.
Very good evening to all of you. My name is Mr. Sujit Baburao Dhawan. I am from Maharashtra. I work as assistant professor at Ideal Institute of Management, Manipur. And my presentation is on pros and cons of implementing Industry 4.0 for the organizations. This is the introduction. Industry 4.0 is one of the trending topics among the academicians and practitioners around the world. The pros and cons of Industry 4.0 are significantly important because it It will help the organizations to make a sensible decision regarding its implementation. The adoption of technologies among organizations may change based on the location of the organization, level of ICT infrastructure, culture, level of education, economic and political stability, and perceived advantage may interfere in the value perception and level of investment in technologies of Industry 4.0. These are some parts contributing to the Industry 4.0. That is, these are the components which are important for it. Those are robots, Internet of Things, simulation, cybersecurity, system integration, cloud computing, 3D, big data, augmented reality. These are some of the pros and advantages of Industry 4.0. Manufacturing innovation. The industrial equipment which communicates with other machines and users in a self-regulating and automated process, which warrants a low degree of human intervention. Dynamic communications and controlling automated modules between shop floor and markets are created and manufacturing parallel. Profitability. Implementing Industry 4.0 will be profitable in the long run. It will also open new opportunities to serve larger markets, customized and smart products, intelligent products, and operations to offer services. Improve product safety and quality. The use of product safety data, such as product recall data, common incident problems, solutions, improve quality management systems, self-regulating and automatic monitoring of predefined quality characteristics to the implementation of vertical, horizontal, and end-to-end integration in Industry 4.0 will reduce the safety and quality issues. Delightful customer experience. The responsiveness and profound information availability into vertical, horizontal integration. Improve operations. The improved coordination in the supply chain with real-time data will result in the reduction of inventory across all elements in the supply chain. Strategic competitive advantage. In a competitive sense, the smart products will create product differentiation, customer segmentation to the sense, customer segmentation, gender-wise, age-wise segmentation, income-wise segmentation, then dynamic price setting, value-added services, and closer customer relationships. Organizational efficiency and effectiveness. Then next advantage is organization agility. The intelligent cross-linking of various subsystems within the organization through a self-regulating and decentralized framework will create a possibility to manufacture a small block of products in an economically viable manner, meeting the customer need for customization. Next advantage is environmental and social benefits. These are some of the cons, like negative points. Negative impact of data sharing in a competitive environment. The high degree of transparency may result in risks such as cyber attacks, industrial spying, and other challenges such as data rights and access. The organizations which set the platform standards will hinder the other organizations with well-established unique selling points and may also drive them out of the business. Need for high skill level. The technical competencies expected of employees are state-of-the-art knowledge, technical skills, process understanding, etc. Next, disadvantages. Socio-technical implications. The cybersecurity. Cybersecurity issues such as process manipulation, shutdown by cyber attacks, know-how protection, data protection, product protection, and other sensitive data protection. The next disadvantage is high initial cost. Next is total implementation is necessary for success. Then handling employees and trade unions applications. The trade unions of the organizations may resist for the Industry 4.0 initiatives as it involves a radical change in terms of how traditional work is carried out in the market. Now, this is the conclusion. The main objective of this study was to review and analyze the extent literature on the pros and cons of Industry 4.0 in a systematic manner to provide insights from an academic perspective. The pros of Industry 4.0 found are strategic competitive advantage, organization agility, etc. The cons are negative impact of data sharing in a competitive environment and the employee and trading application, need for high skill labor, etc. Finally, as Mr. Warren said, the factory of the future will have two employees, a human and a dog. The task of the human will be to feed the dog. The dog will have the task to insinuate that you want to touch the fundamentals. Thank you.
Good evening, everyone. My name is Netra Maslata. I'm working as an assistant professor in the Humanities and Basic Sciences Department of Manipur Institute of Technology. Today, I'm going to deliver a topic on phytochemical profiling and antioxidant activities of Retrosomal Khongyang, blood stem, Jaideva Singh, and edible species of as an introduction part, we already know in human history, plants play an important role due to their nutritional value as well as the major portion of diet and presence of natural antioxidant phytochemicals. The plant Retrosomal Khongyang blood stem belongs to the Arachi family. That is September 2017. The sample species were submitted to IPS trial Harvard protected rights. Extraction of the plant methods. Extraction of the plant stem was carried out with methanol and chloroform by using the method. In this method, we choose the solvent in the increasing order of polarity. the extraction, we analyze preliminary phytochemical analysis and the flavonoid and the phenolic tests also. First, we conducted preliminary phytochemical analysis by using the carbon, gelene, and potassium methods. We conducted the test of alkaloids, saponins, sterins, sodium glycosides, flavonoids, phenols, steroids, terpenoids, phenols, proteins, anthocyanins, and potassium. We also perform physiochemical evaluation. In this, we determine the S values, heavy metals, and the alpha toxins present in cytosoma secreting body. Total phenolic and the total flavonoid content is also determined by using the Pauling short Jew method using gallic acid as a reference gas of phenolic. The result were expressed as gallic acid equivalent in microgram. Total flavonoid content is also performed in both the aspects, that is chloroform and ethanol. This gas processing is used in the study. From the preliminary phytochemical analysis, we got in gas of chloroform extract presence of glycoside, cardiac glycoside, flavonoids, phenols, steroids, and terpenoids were present, and gas of ethanol, oily, cardiac glycosides, phenol, and the terpenoids. Chemical parameters, parameters, total as 19.24, acid soluble 1.02%. In Heterosoma secretarial plants, in stem, alpha toxins like B1, alpha toxins B1, B2, B1, B2 were not detected. And heavy metals and elemental analysis from heavy metals and elemental analysis. Heavy metals like arsenic, lead, mercury, according to from the elemental analysis, we recorded the presence of iron, zinc, potassium, calcium, and acid metals. This is the standard curve of gallic acid. The standard curve of phosphate. From this result, the total phenol content in the plant extract for chloroform and ethanol used the calibration curve was found to be 16.20513 and 57.25597 gram of gallic acid, equivalent per gram dry weight of extracts, and the total flavonoid content in the test sample used the calibration curve was found to be 119.94 for ethanol extract and for chloroform extract 16.35 grams of quercetin equivalents dry weight of the acid. So, in conclusion, we conclude that preliminary phytochemical evaluation showed the presence of glycoside, steroid, graphite, tannins, and phenol, terpenoids. Chloroform extract showed the presence of phytochemical extract content maximum percentage of phenolic component and flavonoid compound and ethanol and chloroform extract content Lastly, I take the opportunity to acknowledge my sincere thank to Professor and supervisor and the department. My cousin sister, Dr. M. Swapana, Department of Pharmacology from Manipur Technical and from Sujata and Dr. Vishweshwari for your constant support and encouragement to do this research.
Okay, that comes to the end of this oral presentation. Today we have 12 oral presentation, and the remaining oral presentation will be done tomorrow. So finally we have come to the end of day 1 session. Today we have a very exciting presentation from all our speakers, and we are also very thankful to the chairpersons who have chaired the session. And we are also thankful to all the oral presenters for presenting their novel research work. With this word, now we will be closing the day 1 session. So let's meet tomorrow again at day 2. So that's for the day.